1. Introduction. 1.1 Understanding pollution. Pollution is a pressing global issue that affects the environment, human health, and the overall well-being of our planet. It refers to the introduction of harmful substances or contaminants into the natural environment, causing adverse effects on living organisms and ecosystems. Understanding pollution is crucial in order to address its causes, impacts, and find effective solutions to mitigate its effects. 1.1.1 What is pollution? Pollution can take various forms, including air pollution, water pollution, soil pollution, noise pollution, light pollution, plastic pollution, industrial pollution, agricultural pollution, transportation pollution, and waste pollution. Each type of pollution has its own unique characteristics and sources, but they all share the common attribute of being detrimental to the environment. 1.1.2 Causes of pollution. Pollution is primarily caused by human activities, although natural events such as volcanic eruptions and forest fires can also contribute to certain types of pollution. Human activities that contribute to pollution include industrial processes, transportation, agricultural practices, improper waste disposal, and the use of harmful chemicals and substances. Industrial activities, such as manufacturing and power generation, release large amounts of pollutants into the air, water, and soil. These pollutants can include toxic gases, heavy metals, and hazardous chemicals. Similarly, transportation, especially vehicles that run on fossil fuels, emits pollutants such as carbon monoxide, nitrogen oxides, and particulate matter, contributing to air pollution. Agricultural practices, including the use of pesticides and fertilizers, can lead to water pollution through runoff and leaching. Improper waste disposal, both in landfills and in bodies of water, can contaminate the environment with harmful substances. Additionally, the excessive use of artificial lighting and the improper management of plastic waste also contribute to light and plastic pollution, respectively. 1.1.3 Impacts of pollution. Pollution has far-reaching impacts on the environment, ecosystems, and human health. Air pollution, for example, can lead to respiratory problems, cardiovascular diseases, and even premature death. It also contributes to the formation of smog and acid rain, which have detrimental effects on vegetation, buildings, and bodies of water. Water pollution poses a threat to aquatic life and ecosystems. Contaminated water sources can lead to the death of fish and other aquatic organisms, disrupt the balance of ecosystems, and contaminate drinking water supplies. Soil pollution affects the fertility of land, making it unsuitable for agriculture and posing risks to human health through the consumption of contaminated food. Noise pollution can cause stress, sleep disturbances, and hearing loss in humans and animals. It can also disrupt communication and behavior patterns in wildlife. Light pollution disrupts natural ecosystems and can have negative effects on nocturnal animals, migratory patterns, and human sleep cycles. Plastic pollution poses a significant threat to marine life, with millions of marine animals dying each year due to ingestion or entanglement in plastic debris. It also affects terrestrial ecosystems, as plastic waste takes hundreds of years to decompose and can leach harmful chemicals into the soil and water. 1.1.4 The need for action. The detrimental effects of pollution on the environment and human health necessitate immediate action to address this global problem. It is crucial to raise awareness about pollution and its impacts, as well as to promote sustainable practices and policies that reduce pollution levels. By understanding the causes and impacts of pollution, individuals, communities, and governments can work together to implement effective solutions. This includes adopting cleaner technologies, promoting renewable energy sources, improving waste management systems, implementing stricter regulations, and encouraging sustainable practices in various sectors. In the following chapters, we will delve deeper into the different types of pollution, their causes, effects, and potential solutions. By gaining a comprehensive understanding of pollution and its perpetrators, we can take the necessary steps to protect our environment and create a healthier and more sustainable future for generations to come. 1.2 Types of pollution. Pollution is a global issue that affects the environment, human health, and the overall well-being of our planet. It is caused by various sources and can take different forms. In this section, we will explore the different types of pollution that exist and understand their characteristics and impacts. 1.2.1 Air pollution. Air pollution refers to the contamination of the air with harmful substances that can have detrimental effects on human health, ecosystems, and the environment. It is primarily caused by the release of pollutants from industrial activities, transportation, and the burning of fossil fuels. Common air pollutants include carbon monoxide, sulfur dioxide, nitrogen oxides, particulate matter, and volatile organic compounds. The effects of air pollution can be seen in the form of respiratory problems, cardiovascular diseases, and even premature death. It also contributes to the formation of smog, acid rain, and climate change. To combat air pollution, it is essential to reduce emissions from vehicles and industries, promote renewable energy sources, and improve air quality monitoring and regulations. 1.2.2 Water pollution. Water pollution occurs when harmful substances contaminate water bodies such as rivers, lakes, oceans, and groundwater. It can be caused by industrial waste, agricultural runoff, improper disposal of chemicals and waste, and sewage discharge. Water pollution not only affects aquatic life but also poses a significant risk to human health. The impacts of water pollution include the destruction of ecosystems, the loss of biodiversity, and the contamination of drinking water sources. It can lead to waterborne diseases, such as cholera and dysentery, and have long-term effects on human health. Preventing water pollution requires implementing proper waste management practices, reducing the use of harmful chemicals, and treating wastewater before it is discharged into water bodies. 1.2.3 Soil pollution. Soil pollution refers to the contamination of the soil with toxic substances, such as heavy metals, pesticides, and industrial waste. It can occur due to improper waste disposal, agricultural practices, and industrial activities. Soil pollution not only affects the fertility of the soil but also poses a threat to plants, animals, and human health. The effects of soil pollution include reduced crop yields, the accumulation of toxins in food chains, and the degradation of ecosystems. It can also lead to the contamination of groundwater, further exacerbating water pollution. Remediation of soil pollution involves implementing proper waste management practices, promoting sustainable agricultural practices, and conducting soil remediation techniques. 1.2.4 Noise pollution. Noise pollution refers to excessive or disturbing noise that can have harmful effects on human health and well-being. It is caused by various sources, including transportation, industrial activities, construction, and recreational activities. Prolonged exposure to high levels of noise can lead to hearing loss, stress, sleep disturbances, and impaired cognitive function. The impacts of noise pollution extend beyond human health and can disrupt wildlife habitats, communication among animals, and overall ecosystem balance. To reduce noise pollution, it is important to implement noise control measures, such as sound barriers, noise insulation, and regulations on noise levels in different settings. 1.2.5 Light pollution. Light pollution refers to the excessive or misdirected artificial light that interferes with the natural darkness of the night sky. It is primarily caused by outdoor lighting from streetlights, buildings, and advertisements. Light pollution not only affects astronomical observations but also disrupts ecosystems and human health. The effects of light pollution include the disruption of natural light cycles, the disorientation of migratory birds and sea turtles, and the disturbance of nocturnal animals. It can also have adverse effects on human health, such as sleep disorders and disruption of circadian rhythms. Mitigating light pollution involves using energy-efficient lighting, directing light downward, and implementing regulations on outdoor lighting. 1.2.6 Plastic pollution. Plastic pollution refers to the accumulation of plastic waste in the environment, particularly in oceans, rivers, and landfills. It is caused by improper disposal of plastic products, inadequate recycling systems, and the use of single-use plastics. Plastic pollution poses a significant threat to marine life, ecosystems, and human health. The impacts of plastic pollution include the entanglement and ingestion of marine animals, the contamination of food chains, and the release of toxic chemicals from plastic debris. Managing plastic pollution requires reducing plastic consumption, promoting recycling and waste management practices, and developing sustainable alternatives to single-use plastics. 1.2.7 Industrial pollution. Industrial pollution refers to the release of harmful substances into the environment as a result of industrial activities. It can include air emissions, water discharges, and the improper disposal of hazardous waste. Industrial pollution not only affects the environment but also poses risks to human health and ecosystems. The effects of industrial pollution include air and water contamination, soil degradation, and the release of toxic chemicals into the environment. To mitigate industrial pollution, it is crucial to implement pollution control technologies, enforce regulations on emissions and waste management, and promote sustainable industrial practices. 1.2.8 Agricultural pollution. Agricultural pollution refers to the contamination of soil, water, and air as a result of agricultural practices. It can be caused by the use of pesticides and fertilizers, improper waste management, and soil erosion. Agricultural pollution has significant impacts on ecosystems, water quality, and human health. The effects of agricultural pollution include the loss of biodiversity, the contamination of water bodies with pesticides and nutrients, and the degradation of soil fertility. Implementing sustainable farming practices, reducing the use of chemicals, and promoting organic farming can help prevent agricultural pollution. 1.2.9 Transportation pollution. Transportation pollution refers to the emissions and environmental impacts associated with the transportation sector, including vehicles, airplanes, ships, and trains. It is primarily caused by the combustion of fossil fuels, which releases pollutants into the air. Transportation pollution contributes to air pollution, climate change, and the depletion of natural resources. The effects of transportation pollution include air pollution-related health problems, greenhouse gas emissions, and the loss of biodiversity due to habitat destruction. To reduce transportation pollution, it is important to promote the use of public transportation, electric vehicles, and alternative fuels. Additionally, improving transportation infrastructure and implementing efficient urban planning can help reduce the need for excessive transportation. 1.2.10 Waste pollution. Waste pollution refers to the improper disposal and management of waste, including solid waste, hazardous waste, and electronic waste. It can occur due to inadequate waste management systems, illegal dumping, and the lack of recycling facilities. Waste pollution poses risks to human health, ecosystems, and the environment. The impacts of waste pollution include the contamination of soil and water, the release of toxic substances, and the depletion of natural resources. Implementing proper waste management strategies, promoting recycling and composting, and adopting a circular economy approach can help reduce waste pollution and promote sustainable resource management. In conclusion, pollution takes various forms and has significant impacts on the environment, human health, and ecosystems. Understanding the different types of pollution is crucial for developing effective strategies and solutions to mitigate and prevent pollution. By addressing the root causes and implementing sustainable practices, we can work towards a cleaner and healthier planet for future generations. 1.3 Impact of pollution. Pollution is a global issue that affects every aspect of our lives. It has far-reaching consequences on the environment, human health, and the economy. The impact of pollution can be seen in various forms, from the degradation of ecosystems to the rise in respiratory diseases. In this section, we will explore the different ways in which pollution affects our world. 1.3.1 Environmental impact. Pollution has a profound impact on the environment, disrupting delicate ecosystems and causing irreparable damage to natural resources. One of the most visible effects of pollution is the deterioration of air quality. Air pollution, primarily caused by industrial emissions, vehicle exhaust, and burning of fossil fuels, leads to the formation of smog and the depletion of the ozone layer. This not only affects human health but also harms plants, animals, and aquatic life. Water pollution is another significant environmental consequence of pollution. Contamination of water bodies, such as rivers, lakes, and oceans, occurs due to the discharge of industrial waste, agricultural runoff, and improper disposal of household chemicals. This pollution disrupts aquatic ecosystems, leading to the death of marine life and the destruction of coral reefs. It also renders water unfit for human consumption, posing a threat to public health. Soil pollution, caused by the excessive use of pesticides, herbicides, and chemical fertilizers, has detrimental effects on agricultural productivity and biodiversity. The accumulation of toxic substances in the soil not only affects the growth of crops but also seeps into groundwater, further exacerbating water pollution. Additionally, soil pollution disrupts the natural balance of microorganisms and beneficial insects, leading to a decline in soil fertility and the loss of valuable species. 1.3.2 Human health impact. Pollution poses a significant risk to human health, with both short-term and long-term consequences. Air pollution, for instance, is a leading cause of respiratory diseases such as asthma, bronchitis, and lung cancer. The inhalation of pollutants, such as particulate matter and toxic gases, can cause inflammation of the respiratory system and damage lung tissue. Prolonged exposure to air pollution can also lead to cardiovascular problems, neurological disorders, and even premature death. Water pollution also has severe implications for human health. Contaminated water sources can harbor harmful bacteria, viruses, and parasites, leading to waterborne diseases like cholera, dysentery, and typhoid. Chemical pollutants, such as heavy metals and pesticides, can accumulate in the body over time, causing chronic illnesses and impairing organ function. Moreover, the consumption of polluted seafood can expose individuals to toxins like mercury, which can have detrimental effects on the nervous system. Soil pollution indirectly affects human health through the food chain. When crops absorb contaminants from polluted soil, they become a source of exposure to toxic substances for humans. Ingesting food contaminated with pesticides or heavy metals can lead to various health issues, including organ damage, developmental disorders, and an increased risk of cancer. Additionally, the loss of fertile soil due to pollution can impact agricultural productivity, leading to food scarcity and malnutrition. 1.3.3 Economic impact. The impact of pollution extends beyond the environment and human health. It also has significant economic consequences. The costs associated with pollution are multifaceted, ranging from healthcare expenses to the loss of productivity and damage to infrastructure. Healthcare costs related to pollution-induced illnesses are substantial. Treating respiratory diseases, waterborne infections, and other pollution-related health conditions puts a strain on healthcare systems, requiring significant financial resources. Additionally, the loss of productivity due to illness and premature death affects both individuals and the economy as a whole. Pollution also affects industries and businesses. For example, air pollution can lead to reduced agricultural yields, impacting the livelihoods of farmers and the availability of food. Water pollution can harm fisheries and aquaculture, leading to a decline in the fishing industry and the loss of jobs. Moreover, pollution can damage infrastructure, such as buildings and bridges, requiring costly repairs and maintenance. Furthermore, pollution can have long-term economic implications. The degradation of natural resources, such as forests and water bodies, can disrupt tourism and recreational activities, impacting local economies that rely on these sectors. Additionally, the reputation of a polluted area can deter investment and economic development, further exacerbating the economic impact of pollution. In conclusion, pollution has a profound impact on our environment, human health, and economy. It disrupts ecosystems, harms wildlife, and degrades natural resources. It poses significant risks to human health, leading to respiratory diseases, waterborne infections, and chronic illnesses. Moreover, pollution has economic consequences, including healthcare costs, loss of productivity, and damage to industries. Recognizing the impact of pollution is crucial in understanding the urgency for action and implementing effective measures to mitigate and prevent pollution. 1.4 The need for action. Pollution is a global crisis that poses a significant threat to the environment, human health, and the overall well-being of our planet. The detrimental effects of pollution are widespread and can be observed in various forms, such as air pollution, water pollution, soil pollution, noise pollution, light pollution, plastic pollution, industrial pollution, agricultural pollution, transportation pollution, and waste pollution. The severity of these issues demands immediate action from individuals, communities, governments, and international organizations. 1.4.1 Understanding the scale of the problem. To comprehend the urgency of addressing pollution, it is crucial to understand the scale of the problem. Pollution is not limited to a specific region or country, it affects every corner of the globe. The consequences of pollution are far-reaching and impact both developed and developing nations. The release of harmful pollutants into the environment has led to the degradation of ecosystems, loss of biodiversity, and the emergence of numerous health issues. 1.4.2 Environmental degradation. Pollution is a major contributor to environmental degradation. The release of pollutants into the air, water, and soil has led to the destruction of natural habitats and ecosystems. Air pollution, caused by emissions from vehicles, industries, and power plants, not only affects human health but also damages vegetation and contributes to climate change. Water pollution, resulting from industrial waste, agricultural runoff, and improper waste disposal, contaminates water bodies, making them unfit for human consumption and threatening aquatic life. Soil pollution, caused by the excessive use of pesticides, fertilizers, and improper waste disposal, degrades soil quality, leading to reduced agricultural productivity and ecosystem imbalance. 1.4.3 Human health impacts. The impact of pollution on human health cannot be overstated. Exposure to air pollutants, such as particulate matter, nitrogen dioxide, and ozone, has been linked to respiratory diseases, cardiovascular problems, and even premature death. Water pollution, particularly the contamination of drinking water sources, can lead to waterborne diseases, including cholera, dysentery, and hepatitis. Soil pollution can result in the accumulation of toxic substances in crops, posing a risk to human health when consumed. Noise pollution has been associated with stress, sleep disturbances, and hearing loss. Light pollution disrupts natural sleep patterns and affects the circadian rhythm, leading to various health issues, including insomnia and mood disorders. 1.4.4 Ecological imbalance. Pollution disrupts the delicate balance of ecosystems, leading to a loss of biodiversity and ecological imbalances. Air pollution harms plants, reducing their ability to photosynthesize and negatively impacting the food chain. Water pollution affects aquatic organisms, leading to the decline of fish populations and the destruction of coral reefs. Soil pollution affects soil microorganisms and beneficial insects, disrupting the natural processes that support plant growth and nutrient cycling. Noise pollution disrupts animal communication and behavior, affecting their ability to find mates, hunt, and navigate. Light pollution disrupts the natural patterns of nocturnal animals, affecting their feeding and breeding habits. 1.4.5 Economic consequences. The consequences of pollution extend beyond the environmental and health impacts, they also have significant economic implications. The costs associated with healthcare, environmental cleanup, and the loss of productivity due to pollution-related illnesses are substantial. Industries that rely on clean air, water, and soil face challenges when pollution levels rise, leading to increased production costs and reduced competitiveness. Tourism, a vital source of revenue for many countries, can be negatively affected by pollution, as visitors are deterred by polluted environments. Additionally, the degradation of natural resources due to pollution can hinder sustainable development and economic growth. 1.4.6 Interconnectedness and global responsibility. Pollution knows no boundaries and affects all nations, regardless of their level of development. The interconnectedness of our world demands collective action to address pollution effectively. While individual efforts are essential, they alone cannot solve the problem. Governments and international organizations must implement policies and regulations to control pollution and promote sustainable practices. Cooperation between countries is crucial to address transboundary pollution issues and ensure a healthier and cleaner future for all. 1.4.7 Education and awareness. To tackle pollution effectively, education and awareness play a vital role. It is essential to educate individuals about the causes and consequences of pollution, as well as the actions they can take to reduce their environmental footprint. By raising awareness and promoting sustainable practices, we can empower individuals to make informed choices and contribute to pollution control efforts. 1.4.8 The time for action is now. The need for action to combat pollution is urgent. Delaying or ignoring the problem will only exacerbate its consequences and make it more challenging to reverse the damage. Governments, industries, communities, and individuals must come together to implement sustainable solutions, reduce pollution levels, and protect the environment for future generations. By taking action now, we can create a cleaner, healthier, and more sustainable world for all. 2. Air pollution. 2.1 Causes of air pollution. Air pollution is a significant environmental issue that affects the health and well-being of both humans and the planet. It occurs when harmful substances, known as pollutants, are released into the atmosphere, resulting in the degradation of air quality. These pollutants can originate from various sources and activities, contributing to the deterioration of air quality and the subsequent negative impacts on human health, ecosystems, and climate. In this section, we will explore some of the major causes of air pollution and delve into the details of each. 2.1.1 Industrial emissions. One of the primary contributors to air pollution is industrial emissions. Industries such as manufacturing, power generation, and chemical production release a significant amount of pollutants into the air. These emissions often include harmful gases, particulate matter, and volatile organic compounds (VOCs). The burning of fossil fuels, such as coal, oil, and natural gas, for energy production is a major source of industrial emissions. Additionally, industrial processes like smelting, refining, and manufacturing release pollutants such as sulfur dioxide, nitrogen oxides, and carbon monoxide into the atmosphere. 2.1.2 Vehicle emissions. The transportation sector is another major source of air pollution, primarily due to vehicle emissions. The combustion of fossil fuels in cars, trucks, motorcycles, and other vehicles releases pollutants such as carbon monoxide, nitrogen oxides, and particulate matter into the air. The increasing number of vehicles on the roads, especially in urban areas, has led to a significant rise in air pollution levels. Additionally, older vehicles that do not meet modern emission standards contribute disproportionately to air pollution. 2.1.3 Residential and commercial activities. Residential and commercial activities also play a role in air pollution. The burning of solid fuels, such as wood and coal, for heating and cooking purposes in households can release harmful pollutants into the air. In many developing countries, where access to clean energy sources is limited, this form of indoor air pollution poses a significant health risk, particularly for women and children who spend a considerable amount of time indoors. Commercial activities, such as the operation of restaurants, hotels, and other businesses, can also contribute to air pollution through the release of smoke, fumes, and chemicals. 2.1.4 Agricultural practices. Certain agricultural practices can contribute to air pollution as well. The use of chemical fertilizers and pesticides in farming can release nitrogen oxides and volatile organic compounds into the atmosphere. Additionally, the burning of agricultural waste, such as crop residues, can release large amounts of smoke and particulate matter into the air. These agricultural emissions can have detrimental effects on air quality, especially in rural areas where farming is prevalent. 2.1.5 Waste management. Improper waste management is another significant cause of air pollution. When waste is not adequately disposed of or treated, it can release harmful gases and particulate matter into the air. Landfills, for example, produce methane, a potent greenhouse gas that contributes to climate change. Open burning of waste, a common practice in some regions, releases toxic fumes and pollutants into the atmosphere. Incineration of waste, if not carried out with proper pollution control measures, can also release harmful emissions. 2.1.6 Natural sources. While human activities are the primary contributors to air pollution, natural sources also play a role. Volcanic eruptions, wildfires, and dust storms can release large amounts of pollutants into the air. Although these events are natural occurrences, they can have significant impacts on air quality, especially in the immediate vicinity. However, it is important to note that the contribution of natural sources to overall air pollution is relatively small compared to human activities. 2.1.7 Climate change and air pollution feedback. Air pollution and climate change are interconnected issues that influence each other. Certain air pollutants, such as black carbon, can contribute to global warming by absorbing sunlight and heating the atmosphere. On the other hand, climate change can worsen air pollution by altering weather patterns, increasing the frequency and intensity of wildfires, and promoting the formation of ground-level ozone. This feedback loop between air pollution and climate change highlights the need for comprehensive strategies to address both issues simultaneously. In conclusion, air pollution is caused by a combination of human activities and natural sources. Industrial emissions, vehicle emissions, residential and commercial activities, agricultural practices, waste management, and natural events all contribute to the degradation of air quality. Understanding the causes of air pollution is crucial for developing effective strategies and policies to mitigate its harmful effects on human health and the environment. By addressing these causes and implementing sustainable practices, we can work towards cleaner and healthier air for present and future generations. 2.2 Effects of air pollution. Air pollution is a significant environmental issue that affects the health and well-being of both humans and the planet. The effects of air pollution can be seen and felt in various aspects of our lives, from the quality of the air we breathe to the overall balance of ecosystems. In this section, we will explore the wide-ranging effects of air pollution on different levels. 2.2.1 Health impacts. One of the most concerning effects of air pollution is its impact on human health. Breathing in polluted air can have severe consequences for our respiratory system, cardiovascular health, and overall well-being. The pollutants present in the air, such as particulate matter, nitrogen dioxide, sulfur dioxide, and ozone, can penetrate deep into our lungs and enter our bloodstream, causing a range of health problems. Exposure to air pollution has been linked to respiratory diseases such as asthma, bronchitis, and chronic obstructive pulmonary disease, COPD. It can also worsen existing respiratory conditions, leading to increased hospitalizations and even premature death. Additionally, air pollution can trigger cardiovascular issues, including heart attacks, strokes, and high blood pressure. Children, the elderly, and individuals with pre-existing health conditions are particularly vulnerable to the health impacts of air pollution. Prolonged exposure to polluted air can hinder lung development in children, leading to long-term respiratory problems. Moreover, pregnant women exposed to air pollution may experience complications such as preterm birth and low birth weight. 2.2.2 Environmental consequences. Air pollution not only affects human health but also has far-reaching consequences for the environment. It disrupts the delicate balance of ecosystems and poses a threat to various plant and animal species. Let's explore some of the environmental impacts of air pollution. 2.2.2.1 Climate change. Air pollution contributes to climate change by releasing greenhouse gases into the atmosphere. The burning of fossil fuels, industrial processes, and deforestation all release carbon dioxide, CO2, and other greenhouse gases, trapping heat in the Earth's atmosphere. This leads to global warming, rising temperatures, and changes in weather patterns. Climate change caused by air pollution has numerous detrimental effects, including the melting of polar ice caps, rising sea levels, and more frequent and intense extreme weather events such as hurricanes, droughts, and heatwaves. These changes disrupt ecosystems, threaten biodiversity, and impact the livelihoods of communities around the world. 2.2.2.2 Acid rain. Air pollution also contributes to the formation of acid rain. When pollutants such as sulfur dioxide and nitrogen oxides react with water vapor in the atmosphere, they form sulfuric acid and nitric acid, which then fall to the ground as acid rain. Acid rain has detrimental effects on forests, lakes, and aquatic ecosystems. The acidic deposition from acid rain damages trees and plants, making them more susceptible to diseases and pests. It also acidifies lakes and rivers, harming aquatic life and disrupting the entire food chain. Acid rain can have long-lasting effects on ecosystems, leading to the decline of certain species and the loss of biodiversity. 2.2.2.3 Ozone depletion. Certain air pollutants, such as chlorofluorocarbons, CFCs, contribute to the depletion of the ozone layer in the Earth's stratosphere. The ozone layer acts as a shield, protecting life on Earth from harmful ultraviolet, UV, radiation. However, the release of CFCs from industrial processes and aerosol products has led to the thinning of the ozone layer. The depletion of the ozone layer allows more UV radiation to reach the Earth's surface, increasing the risk of skin cancer, cataracts, and other health problems in humans. It also affects marine life, including phytoplankton, which forms the base of the ocean food chain. Additionally, ozone depletion can harm terrestrial plants, leading to reduced crop yields and ecosystem disruptions. 2.2.3 Economic impact. Air pollution has significant economic consequences as well. The costs associated with healthcare, reduced productivity, and environmental damage can be substantial. Let's explore some of the economic impacts of air pollution. 2.2.3.1 Healthcare costs. The health effects of air pollution result in increased healthcare costs. Treating respiratory and cardiovascular diseases, as well as other health conditions related to air pollution, puts a strain on healthcare systems. The expenses associated with hospitalizations, medications, and long-term care for individuals affected by air pollution can be substantial. 2.2.3.2 Reduced productivity. Air pollution can also lead to reduced productivity in various sectors. When individuals suffer from respiratory illnesses or other health issues caused by polluted air, their ability to work efficiently is compromised. This can result in increased absenteeism, decreased productivity, and economic losses for both individuals and businesses. 2.2.3.3 Environmental cleanup and restoration. Addressing the environmental damage caused by air pollution requires significant financial resources. Efforts to clean up polluted air, restore ecosystems, and mitigate the impacts of climate change involve substantial investments. Governments, communities, and industries must allocate funds to implement pollution control measures, develop sustainable technologies, and restore damaged environments. Conclusion. The effects of air pollution are wide-ranging and have profound implications for human health, the environment, and the economy. It is crucial to recognize the gravity of the situation and take immediate action to reduce air pollution levels. By implementing effective pollution control measures, promoting sustainable practices, and raising awareness, we can mitigate the harmful effects of air pollution and create a healthier and more sustainable future for all. 2.3 Major air pollutants. Air pollution is a significant environmental issue that affects the health and well-being of both humans and the planet. It is caused by various pollutants released into the atmosphere from a wide range of sources. These pollutants can have detrimental effects on air quality, leading to respiratory problems, environmental damage, and climate change. In this section, we will explore some of the major air pollutants and their sources. 2.3.1 Particulate matter, PM. Particulate matter (PM) refers to a mixture of solid particles and liquid droplets suspended in the air. These particles can vary in size, composition, and origin. PM is classified based on its diameter, with PM10 referring to particles with a diameter of 10 micrometers or less and PM2.5 referring to particles with a diameter of 2.5 micrometers or less. Sources of PM include combustion processes, such as vehicle emissions, industrial activities, and the burning of fossil fuels for energy production. Dust and smoke from construction sites, wildfires, and agricultural activities also contribute to PM pollution. These particles can remain suspended in the air for long periods and can be transported over long distances, leading to regional and even global impacts. Exposure to PM can have severe health effects, particularly on the respiratory and cardiovascular systems. Fine particles, such as PM2.5, can penetrate deep into the lungs and enter the bloodstream, causing or exacerbating respiratory diseases, heart attacks, and strokes. PM pollution also contributes to reduced visibility, haze, and the formation of smog. 2.3.2 Nitrogen oxides (NOx). Nitrogen oxides (NOx) are a group of highly reactive gases composed of nitrogen and oxygen atoms. The two primary forms of NOx are nitrogen dioxide, number 2, and nitric oxide, NO. These gases are produced during high-temperature combustion processes, such as those occurring in vehicle engines, power plants, and industrial facilities. The main sources of NOx emissions include the burning of fossil fuels, particularly in transportation and energy production. Vehicle exhaust is a significant contributor to urban NOx pollution, especially in densely populated areas. Industrial processes, such as the burning of coal and oil, also release substantial amounts of NOx into the atmosphere. NOx is a key component in the formation of ground-level ozone, a harmful air pollutant. It also contributes to the formation of acid rain and the production of fine particles. Prolonged exposure to NOx can lead to respiratory problems, increased susceptibility to respiratory infections, and the aggravation of asthma symptoms. 2.3.3 Sulfur dioxide, SO2. Sulfur dioxide, SO2, is a colorless gas with a pungent odor. It is primarily produced by the burning of fossil fuels that contain sulfur, such as coal and oil. Industrial processes, particularly those in power plants and refineries, are significant sources of SO2 emissions. SO2 can have both short-term and long-term effects on human health. Short-term exposure to high levels of SO2 can cause respiratory symptoms, such as coughing, wheezing, and shortness of breath. Prolonged exposure to lower levels of SO2 can lead to chronic respiratory conditions, such as bronchitis and reduced lung function. SO2 also contributes to the formation of acid rain when it reacts with water vapor in the atmosphere. Acid rain can have detrimental effects on ecosystems, including the acidification of lakes and rivers, damage to forests, and corrosion of buildings and infrastructure. 2.3.4 Carbon monoxide, CO. Carbon monoxide, CO, is a colorless and odorless gas produced by the incomplete combustion of fossil fuels and biomass. It is primarily emitted from vehicle exhaust, industrial processes, and residential heating systems. CO is a highly toxic gas that can be harmful even at low concentrations. When inhaled, it binds to hemoglobin in the blood, reducing its ability to transport oxygen to the body's tissues and organs. This can lead to symptoms such as headaches, dizziness, nausea, and in severe cases, can be fatal. 2.3.5 Volatile organic compounds, VOCs. Volatile organic compounds, VOCs, are a diverse group of organic chemicals that easily evaporate at room temperature. They are emitted from various sources, including vehicle emissions, industrial processes, solvents, and household products. VOCs play a significant role in the formation of ground-level ozone and the production of secondary organic aerosols, which are fine particles suspended in the air. They also contribute to the formation of smog and can have adverse health effects, including respiratory irritation, headaches, and the exacerbation of asthma symptoms. 2.3.6 Ozone, O3. Ozone, O3, is a gas that occurs both in the Earth's upper atmosphere, stratospheric ozone, and at ground level, tropospheric ozone. While stratospheric ozone plays a crucial role in protecting us from harmful ultraviolet, UV, radiation, tropospheric ozone is a harmful air pollutant. Tropospheric ozone is formed through complex chemical reactions involving sunlight, nitrogen oxides, NOx, and volatile organic compounds, VOCs. It is a major component of smog and is primarily produced in urban and industrial areas with high levels of NOx and VOC emissions. Exposure to high levels of ozone can cause respiratory problems, such as coughing, throat irritation, and reduced lung function. It can also worsen existing respiratory conditions, such as asthma and chronic obstructive pulmonary disease, COPD. Ozone pollution can have detrimental effects on crops, forests, and other vegetation. 2.3.7 Heavy metals. Heavy metals, such as lead, Pb, mercury, Hg, and cadmium, Cd, are toxic pollutants that can be released into the air through various industrial processes, combustion of fossil fuels, and waste incineration. These metals can persist in the environment for long periods and can bioaccumulate in the food chain, posing risks to human health and ecosystems. Exposure to heavy metals can lead to a range of health problems, including neurological disorders, kidney damage, respiratory issues, and developmental abnormalities in children. Efforts to reduce heavy metal emissions focus on implementing strict regulations and control measures in industries and promoting the use of cleaner technologies. 2.3.8 Greenhouse gases. While not traditionally considered air pollutants, greenhouse gases (GHGs) play a significant role in air pollution and climate change. The major greenhouse gases include carbon dioxide, CO2, methane, CH4, nitrous oxide, N2O, and fluorinated gases. These gases trap heat in the Earth's atmosphere, leading to global warming and climate change. The primary sources of greenhouse gas emissions are the burning of fossil fuels for energy production, transportation, and industrial processes. Deforestation and land use changes also contribute to GHG emissions. The accumulation of these gases in the atmosphere is causing rising global temperatures, sea level rise, and extreme weather events. Reducing greenhouse gas emissions is crucial for mitigating climate change and improving air quality. This requires transitioning to cleaner and renewable energy sources, improving energy efficiency, promoting sustainable transportation, and implementing policies and international agreements to limit emissions. In conclusion, understanding the major air pollutants and their sources is essential for addressing air pollution effectively. By implementing sustainable practices, adopting cleaner technologies, and promoting policies and regulations, we can reduce the emissions of these pollutants and improve the quality of the air we breathe. 2.4 Solutions to air pollution. Air pollution is a significant environmental issue that affects the health and well-being of individuals and the planet as a whole. It is caused by a variety of factors, including industrial emissions, vehicle exhaust, and the burning of fossil fuels. The consequences of air pollution are far-reaching, impacting both human health and the environment. However, there are several solutions that can be implemented to mitigate and reduce air pollution. In this section, we will explore some of the key strategies and initiatives that can help combat air pollution and create a cleaner and healthier atmosphere for all. 2.4.1 Transition to clean energy sources. One of the most effective ways to tackle air pollution is by transitioning from fossil fuels to clean and renewable energy sources. Fossil fuels, such as coal, oil, and natural gas, are major contributors to air pollution due to their high carbon emissions. By investing in renewable energy technologies like solar, wind, and hydroelectric power, we can significantly reduce the release of harmful pollutants into the atmosphere. Governments, businesses, and individuals can play a crucial role in supporting and promoting the adoption of clean energy sources. 2.4.2 Improve energy efficiency. Another important solution to air pollution is improving energy efficiency in various sectors. Energy-efficient technologies and practices can help reduce the overall energy consumption, thereby decreasing the reliance on fossil fuels and minimizing air pollution. This can be achieved through the use of energy-efficient appliances, better insulation in buildings, and the implementation of energy-saving practices in industries. By optimizing energy usage, we can not only reduce air pollution but also save money and conserve valuable resources. 2.4.3 Enhance public transportation. The transportation sector is a significant contributor to air pollution, primarily through vehicle emissions. Encouraging the use of public transportation systems can help reduce the number of vehicles on the road, thereby decreasing air pollution levels. Governments should invest in the development and improvement of public transportation infrastructure, including buses, trains, and trams. Additionally, promoting the use of bicycles and walking can further reduce the reliance on private vehicles and contribute to cleaner air in urban areas. 2.4.4 Promote electric vehicles. Electric vehicles (EVs) offer a promising solution to reduce air pollution from transportation. Unlike conventional vehicles, EVs produce zero tailpipe emissions, significantly reducing the release of pollutants into the air. Governments can incentivize the adoption of electric vehicles by providing subsidies, tax benefits, and establishing charging infrastructure. Additionally, businesses and individuals can contribute to this transition by choosing electric vehicles as their preferred mode of transportation. The widespread adoption of EVs can have a substantial positive impact on air quality and help combat climate change. 2.4.5 Implement stricter emission standards. Regulations and emission standards play a crucial role in controlling air pollution. Governments should enforce and strengthen emission standards for industries, power plants, and vehicles. By setting strict limits on the amount of pollutants that can be released into the atmosphere, we can ensure that industries and vehicles operate in an environmentally responsible manner. Regular monitoring and enforcement of these standards are essential to ensure compliance and maintain air quality. 2.4.6 Encourage sustainable agriculture practices. Agricultural activities, such as the use of pesticides and fertilizers, contribute to air pollution through the release of harmful chemicals and greenhouse gases. Encouraging sustainable farming practices, such as organic farming and integrated pest management, can help reduce the use of harmful chemicals and minimize air pollution. Additionally, promoting agroforestry and planting trees in agricultural areas can help absorb carbon dioxide and improve air quality. 2.4.7 Raise awareness and education. Raising awareness about the causes and consequences of air pollution is crucial in driving change and encouraging individuals to take action. Education campaigns can help people understand the importance of clean air and the steps they can take to reduce pollution in their daily lives. By promoting sustainable practices, such as reducing energy consumption, using public transportation, and supporting clean energy initiatives, individuals can contribute to improving air quality and protecting the environment. 2.4.8 International cooperation. Air pollution is a global issue that requires international cooperation and collaboration. Countries can work together to share knowledge, best practices, and technologies to combat air pollution effectively. International agreements and initiatives, such as the Paris Agreement, aim to address climate change and air pollution on a global scale. By joining forces, countries can develop and implement strategies to reduce emissions, promote sustainable practices, and protect the air we breathe for future generations. In conclusion, air pollution is a pressing environmental problem that demands immediate attention and action. By transitioning to clean energy sources, improving energy efficiency, enhancing public transportation, promoting electric vehicles, implementing stricter emission standards, encouraging sustainable agriculture practices, raising awareness, and fostering international cooperation, we can effectively combat air pollution. It is essential for governments, businesses, communities, and individuals to come together and take proactive measures to create a cleaner and healthier environment for ourselves and future generations. 3. Water pollution. 3.1 Causes of water pollution. Water pollution is a significant environmental issue that affects the health and well-being of both humans and ecosystems. It occurs when harmful substances enter bodies of water, such as rivers, lakes, and oceans, and disrupt the natural balance of aquatic ecosystems. The causes of water pollution are diverse and can be attributed to various human activities and natural processes. In this section, we will explore some of the major contributors to water pollution, including both point sources and non-point sources. 3.1.1 Industrial discharges. Industrial activities play a significant role in water pollution. Many industries release untreated or inadequately treated wastewater into nearby water bodies, contaminating them with a wide range of pollutants. These pollutants can include heavy metals, toxic chemicals, oils, solvents, and other harmful substances. Industrial discharges can have severe consequences for aquatic life, as they can disrupt the natural balance of ecosystems and harm fish, plants, and other organisms. 3.1.2 Agricultural runoff. Agricultural practices, particularly the use of fertilizers and pesticides, contribute to water pollution through runoff. When farmers apply fertilizers and pesticides to their fields, rainwater or irrigation water can wash away these chemicals and carry them into nearby rivers, streams, and groundwater. Excessive nutrient runoff, such as nitrogen and phosphorus from fertilizers, can lead to eutrophication, a process in which excessive plant growth depletes oxygen levels in the water, suffocating aquatic organisms. 3.1.3 Municipal wastewater. The discharge of untreated or poorly treated sewage from municipal wastewater treatment plants is another significant cause of water pollution. In many developing countries, inadequate infrastructure and lack of proper treatment facilities result in the release of untreated sewage directly into water bodies. This sewage contains harmful pathogens, bacteria, viruses, and other contaminants that can pose serious health risks to humans and aquatic life. 3.1.4 Oil spills. Oil spills, whether from tanker accidents, offshore drilling operations, or illegal dumping, have devastating effects on water ecosystems. When oil is released into the water, it forms a slick on the surface, preventing oxygen exchange and sunlight penetration. This can lead to the death of marine organisms, as well as long-term damage to habitats and ecosystems. Oil spills also contaminate water with toxic chemicals, which can persist in the environment for years and have far-reaching ecological consequences. 3.1.5 Improper waste disposal. Improper disposal of waste, including household waste, industrial waste, and hazardous waste, contributes to water pollution. When waste is dumped into rivers, lakes, or oceans, it can contaminate the water with a variety of pollutants, including heavy metals, chemicals, plastics, and organic matter. These pollutants can have detrimental effects on aquatic life and can also find their way into the food chain, posing risks to human health. 3.1.6 Construction activities. Construction activities, such as building roads, bridges, and buildings, can also contribute to water pollution. Sediments, chemicals, and construction debris can be washed into nearby water bodies during rainfall or through improper waste disposal practices. Sediments can smother aquatic habitats, making it difficult for plants and animals to survive. Chemicals from construction materials, such as cement, paints, and solvents, can contaminate water and harm aquatic organisms. 3.1.7 Mining operations. Mining activities, particularly open-pit mining and strip mining, can have severe impacts on water quality. During the extraction of minerals, large amounts of soil and rock are removed, exposing sulfide minerals to air and water. This can result in the formation of acid mine drainage, which is highly acidic and contains toxic metals. Acid mine drainage can contaminate nearby water bodies, making them uninhabitable for aquatic life and posing risks to human health. 3.1.8 Atmospheric deposition. Atmospheric deposition, also known as acid rain, is another significant contributor to water pollution. When pollutants, such as sulfur dioxide and nitrogen oxides, are released into the atmosphere from industrial processes, power plants, and vehicles, they can combine with water vapor and form acidic compounds. These compounds can then be deposited onto land and water surfaces through rainfall or dry deposition, leading to the acidification of lakes, rivers, and streams. Acidic water can harm aquatic organisms and disrupt the natural balance of ecosystems. 3.1.9 Natural processes. While human activities are the primary causes of water pollution, natural processes can also contribute to the contamination of water bodies. For example, volcanic eruptions, earthquakes, and weathering of rocks can release minerals and other substances into water, altering its composition. Additionally, excessive algal blooms, known as harmful algal blooms, can occur naturally and produce toxins that contaminate water and pose risks to human and animal health. In conclusion, water pollution is a complex issue with multiple causes. Industrial discharges, agricultural runoff, municipal wastewater, oil spills, improper waste disposal, construction activities, mining operations, atmospheric deposition, and natural processes all contribute to the contamination of water bodies. Understanding these causes is crucial for developing effective strategies and regulations to prevent and mitigate water pollution. 3.2 Effects of water pollution. Water pollution is a significant environmental issue that has far-reaching consequences for both ecosystems and human health. The contamination of water bodies, such as rivers, lakes, oceans, and groundwater, by various pollutants has detrimental effects on aquatic life, biodiversity, and the overall balance of ecosystems. Additionally, the consumption of polluted water can lead to severe health problems in humans. In this section, we will explore the effects of water pollution in detail. 3.2.1 Impact on aquatic life. Water pollution poses a grave threat to aquatic organisms and their habitats. The presence of pollutants in water bodies can disrupt the delicate balance of aquatic ecosystems, leading to the decline or extinction of various species. The effects of water pollution on aquatic life can be categorized into direct and indirect impacts. 3.2.1.1 Direct impacts. Direct impacts of water pollution on aquatic life occur when pollutants directly come into contact with organisms. Chemical pollutants, such as heavy metals, pesticides, and industrial waste, can be toxic to aquatic organisms. These pollutants can interfere with the respiratory, reproductive, and immune systems of aquatic organisms, leading to reduced fertility, impaired growth, and increased susceptibility to diseases. Additionally, some pollutants can bioaccumulate in the tissues of organisms, causing long-term damage and even death. 3.2.1.2 Indirect impacts. Indirect impacts of water pollution on aquatic life occur when pollutants alter the physical and chemical properties of water bodies, affecting the availability of oxygen, light penetration, and nutrient levels. Excessive nutrient pollution, such as from agricultural runoff or untreated sewage, can lead to eutrophication. This process causes an overgrowth of algae, depleting oxygen levels in the water and creating dead zones, where aquatic organisms cannot survive. The loss of oxygen in water bodies can result in mass fish kills and the collapse of entire aquatic ecosystems. 3.2.2 Threat to biodiversity. Water pollution poses a significant threat to biodiversity, as it can disrupt the delicate balance of ecosystems and lead to the loss of species. Aquatic ecosystems are home to a wide range of plant and animal species, each playing a crucial role in maintaining the ecological balance. When water bodies become polluted, the survival of many species becomes compromised. Pollutants can directly harm aquatic plants and animals, leading to a decline in their populations. Additionally, the disruption of food chains and the loss of habitat due to pollution can have cascading effects on other species, leading to a decrease in biodiversity. The loss of biodiversity not only affects the natural beauty of ecosystems but also disrupts the ecological services they provide, such as water purification, nutrient cycling, and climate regulation. 3.2.3 Human health impacts. Water pollution has severe implications for human health, particularly in areas where contaminated water is used for drinking, cooking, and bathing. The consumption of polluted water can lead to various waterborne diseases, including cholera, typhoid, dysentery, and hepatitis. These diseases are caused by bacteria, viruses, and parasites that thrive in polluted water. Furthermore, exposure to certain pollutants in water, such as heavy metals and industrial chemicals, can have long-term health effects. Heavy metals like lead, mercury, and arsenic can accumulate in the body over time, leading to neurological disorders, kidney damage, and even cancer. Industrial chemicals, such as PCBs and dioxins, have been linked to reproductive problems, developmental disorders, and an increased risk of cancer. 3.2.4 Economic consequences. Water pollution also has significant economic consequences. Contaminated water sources can render them unsuitable for various purposes, such as agriculture, fishing, and tourism. The loss of these industries can have a detrimental impact on local economies, leading to unemployment and reduced income for communities that rely on these activities. Moreover, the treatment and purification of polluted water require substantial financial resources. Governments and communities must invest in water treatment facilities and technologies to ensure access to clean and safe water. The economic burden of water pollution falls not only on governments but also on individuals who have to bear the costs of purchasing bottled water or installing water purification systems. In conclusion, water pollution has wide-ranging effects on both ecosystems and human health. It threatens aquatic life, biodiversity, and the overall balance of ecosystems. Additionally, polluted water poses significant health risks to humans, leading to waterborne diseases and long-term health problems. The economic consequences of water pollution further exacerbate the issue. It is crucial to take immediate action to prevent and mitigate water pollution through effective regulations, sustainable practices, and public awareness campaigns. 3.3 Types of water pollutants. Water pollution is a significant environmental issue that affects the quality and availability of water resources worldwide. It occurs when harmful substances enter water bodies, such as rivers, lakes, oceans, and groundwater, making them unfit for human consumption and detrimental to aquatic life. Various types of pollutants contribute to water pollution, originating from both natural and human activities. Understanding the different types of water pollutants is crucial for developing effective strategies to prevent and mitigate water pollution. In this section, we will explore some of the most common types of water pollutants and their sources. 3.3.1 Organic pollutants. Organic pollutants are substances that contain carbon and are derived from living organisms or their byproducts. These pollutants can have detrimental effects on water quality and aquatic ecosystems. Some common sources of organic pollutants include sewage. Domestic and industrial wastewater contains organic matter, such as human waste, food scraps, and detergents. When untreated or inadequately treated sewage is discharged into water bodies, it introduces high levels of organic pollutants, leading to oxygen depletion and the growth of harmful bacteria and algae. Agricultural runoff. The use of fertilizers, pesticides, and animal manure in agriculture can result in the runoff of organic pollutants into nearby water sources. These pollutants can cause eutrophication, a process in which excessive nutrients promote the growth of algae, leading to oxygen depletion and the death of aquatic organisms. Industrial discharges. Industries that produce organic compounds, such as chemicals, solvents, and oils, can release these substances into water bodies through improper disposal practices or accidental spills. These pollutants can persist in the environment and have long-term detrimental effects on aquatic ecosystems. 3.3.2 Inorganic pollutants. Inorganic pollutants are substances that do not contain carbon and are often derived from non-living sources. These pollutants can have various sources and can significantly impact water quality. Some common types of inorganic pollutants include heavy metals. Heavy metals, such as lead, mercury, cadmium, and arsenic, are toxic substances that can enter water bodies through industrial discharges, mining activities, and improper waste disposal. These pollutants can accumulate in the tissues of aquatic organisms, leading to bioaccumulation and biomagnification in the food chain, posing risks to both aquatic life and human health. Acids and bases. Acidic or basic substances can enter water bodies through industrial discharges, acid rain, or improper waste disposal. Acidic pollutants, such as sulfuric acid and nitric acid, can lower the pH of water, making it acidic and harmful to aquatic organisms. On the other hand, basic pollutants, such as ammonia, can increase the pH of water, leading to imbalances in aquatic ecosystems. Nitrates and phosphates. Nitrates and phosphates are nutrients that are essential for plant growth. However, excessive amounts of these nutrients can enter water bodies through agricultural runoff and sewage discharges, leading to eutrophication. The overgrowth of algae and aquatic plants due to high nutrient levels can deplete oxygen in the water, causing harm to fish and other aquatic organisms. 3.3.3 Microbiological pollutants. Microbiological pollutants are microorganisms, such as bacteria, viruses, and parasites, that can contaminate water sources and pose significant risks to human health. These pollutants can enter water bodies through various sources, including human and animal waste. Contaminated water sources, such as sewage and animal waste, can contain pathogenic microorganisms that cause waterborne diseases. When these pollutants enter water bodies, they can spread diseases like cholera, typhoid, and hepatitis, especially in areas with inadequate sanitation and water treatment facilities. Stormwater runoff. Rainwater runoff from urban areas can carry bacteria and viruses from animal waste, garbage, and other sources of contamination into water bodies. This can lead to the contamination of recreational waters and pose health risks to individuals who come into contact with the polluted water. 3.3.4 Synthetic pollutants. Synthetic pollutants are human-made chemicals that do not occur naturally in the environment. These pollutants can have diverse sources and can persist in the environment for extended periods. Some common types of synthetic pollutants include pesticides and herbicides. Agricultural practices involve the use of pesticides and herbicides to control pests and weeds. However, these chemicals can enter water bodies through runoff and leaching, contaminating water sources and posing risks to aquatic organisms and human health. Industrial chemicals. Various industrial activities produce synthetic chemicals that can enter water bodies through improper disposal or accidental spills. Examples include solvents, heavy metals, and persistent organic pollutants (POPs). These pollutants can have long-term detrimental effects on aquatic ecosystems and can bioaccumulate in the food chain. Pharmaceuticals and personal care products. Pharmaceuticals and personal care products, such as antibiotics, hormones, and cosmetics, can enter water bodies through wastewater discharges. These pollutants can have adverse effects on aquatic organisms and may contribute to the development of antibiotic resistance in bacteria. Understanding the different types of water pollutants is essential for implementing effective pollution prevention and control measures. By identifying the sources of these pollutants, we can develop strategies to reduce their release into water bodies and protect the quality and sustainability of our water resources. 3.4 Preventing water pollution. Water pollution is a significant environmental issue that poses a threat to the health and well-being of both humans and ecosystems. It is caused by various factors, including industrial activities, agricultural practices, improper waste disposal, and urban runoff. To address this problem, it is crucial to implement effective preventive measures that can help reduce and prevent water pollution. In this section, we will explore some key strategies and actions that can be taken to prevent water pollution. 3.4.1 Implementing proper waste management. One of the primary causes of water pollution is the improper disposal of waste materials. To prevent water pollution, it is essential to implement proper waste management practices. This includes promoting recycling and composting, as well as ensuring that hazardous materials are disposed of safely and responsibly. By reducing the amount of waste that ends up in landfills or is improperly disposed of, we can significantly reduce the risk of water pollution. 3.4.2 Controlling industrial discharges. Industrial activities are a major contributor to water pollution. To prevent industrial discharges from contaminating water sources, it is crucial to enforce strict regulations and control measures. Industries should be required to treat their wastewater before releasing it into water bodies, ensuring that it meets the necessary quality standards. Regular monitoring and inspections can help ensure compliance and prevent pollution incidents. 3.4.3 Promoting sustainable agriculture practices. Agricultural activities, such as the use of pesticides and fertilizers, can lead to water pollution through runoff and leaching. To prevent this, it is important to promote sustainable agriculture practices. This includes reducing the use of harmful chemicals, implementing proper irrigation techniques, and adopting organic farming methods. By minimizing the use of chemicals and managing soil erosion, we can prevent agricultural pollutants from entering water bodies. 3.4.4 Protecting riparian zones and wetlands. Riparian zones and wetlands play a crucial role in filtering and purifying water. They act as natural buffers, preventing pollutants from reaching water bodies. To prevent water pollution, it is essential to protect and restore these important ecosystems. This can be done through the establishment of buffer zones along rivers and lakes, as well as the preservation and restoration of wetlands. By safeguarding these areas, we can enhance water quality and reduce the risk of pollution. 3.4.5 Managing stormwater runoff. Urban areas are often characterized by extensive surfaces covered with impermeable materials, such as concrete and asphalt. When it rains, these surfaces prevent water from infiltrating the ground, leading to increased stormwater runoff. This runoff can carry pollutants, such as oil, chemicals, and debris, into water bodies. To prevent water pollution from stormwater runoff, it is important to implement effective stormwater management practices. This can include the use of permeable pavements, green roofs, and rain gardens to capture and treat runoff before it enters water bodies. 3.4.6 Educating and raising awareness. Education and awareness play a crucial role in preventing water pollution. By educating individuals, communities, and industries about the impacts of water pollution and the importance of conservation, we can foster a sense of responsibility and encourage sustainable practices. This can be done through public awareness campaigns, educational programs in schools, and the dissemination of information through various media channels. By empowering people with knowledge, we can promote behavior change and create a collective effort to prevent water pollution. 3.4.7 Strengthening regulatory frameworks. To effectively prevent water pollution, it is essential to have strong regulatory frameworks in place. Governments should establish and enforce laws and regulations that set standards for water quality and pollution control. These regulations should cover various sectors, including industry, agriculture, and waste management. Regular monitoring and enforcement of these regulations are crucial to ensure compliance and prevent pollution incidents. Additionally, penalties and incentives can be implemented to encourage industries and individuals to adopt sustainable practices and reduce their impact on water quality. 3.4.8 Encouraging collaboration and partnerships. Preventing water pollution requires collaboration and partnerships between various stakeholders, including governments, industries, communities, and non-governmental organizations. By working together, sharing knowledge and resources, and implementing joint initiatives, we can achieve more significant and long-lasting results. Collaboration can involve the development of pollution prevention programs, the sharing of best practices, and the establishment of monitoring and reporting systems. By fostering collaboration, we can create a united front against water pollution and work towards a cleaner and healthier environment. In conclusion, preventing water pollution is a complex task that requires a multifaceted approach. By implementing proper waste management practices, controlling industrial discharges, promoting sustainable agriculture, protecting riparian zones, managing stormwater runoff, educating and raising awareness, strengthening regulatory frameworks, and encouraging collaboration, we can make significant progress in preventing water pollution. It is essential for individuals, communities, industries, and governments to take proactive measures to protect our water resources and ensure a sustainable future for generations to come. 4. Soil pollution. 4.1 Causes of soil pollution. Soil pollution is a significant environmental issue that arises from various sources and activities. It occurs when the soil becomes contaminated with harmful substances, making it unfit for its natural functions and posing risks to human health, ecosystems, and agricultural productivity. Understanding the causes of soil pollution is crucial in developing effective strategies to prevent and mitigate its impacts. In this section, we will explore some of the major contributors to soil pollution. 4.1.1 Industrial activities. Industrial activities play a significant role in soil pollution. Factories and manufacturing plants often release hazardous chemicals and pollutants into the environment, which can find their way into the soil. Chemical spills, improper waste disposal, and inadequate containment measures can lead to the contamination of nearby soil. Heavy metals, such as lead, mercury, cadmium, and arsenic, are common pollutants associated with industrial activities. These toxic substances can persist in the soil for long periods, posing serious health risks to humans and other organisms. 4.1.2 Agricultural practices. Agricultural practices, while essential for food production, can also contribute to soil pollution. The use of pesticides, herbicides, and fertilizers in large-scale agriculture can contaminate the soil. Pesticides and herbicides contain chemicals that are designed to kill pests and weeds, but they can also harm beneficial organisms and accumulate in the soil over time. Similarly, excessive use of fertilizers can lead to nutrient imbalances and soil degradation. When these chemicals leach into the soil, they can contaminate groundwater and affect the quality of surrounding ecosystems. 4.1.3 Improper waste disposal. Improper waste disposal is a significant cause of soil pollution. When waste is not managed correctly, it can end up in landfills or be dumped directly onto the ground. Landfills, if not properly designed and managed, can release harmful substances into the soil and groundwater. Hazardous waste, such as chemicals, heavy metals, and electronic waste, can contaminate the soil and persist for long periods, posing serious risks to human health and the environment. Additionally, the disposal of organic waste, such as food scraps and agricultural residues, can lead to the release of pollutants and contribute to soil degradation. 4.1.4 Mining activities. Mining activities, including both surface and underground mining, can have severe impacts on soil quality. The extraction of minerals and ores often involves the use of chemicals and heavy machinery, which can disturb the soil and release pollutants. Mining waste, known as tailings, contains high concentrations of heavy metals and other toxic substances. If not properly managed, these tailings can contaminate the soil and nearby water bodies, leading to long-term environmental damage. 4.1.5 Construction and urbanization. The rapid growth of urban areas and construction activities can also contribute to soil pollution. During construction, the soil is often excavated, compacted, and covered with impermeable surfaces such as concrete and asphalt. These activities can disrupt the natural soil structure and reduce its ability to absorb and filter water. Construction sites may also release pollutants such as cement, paint, and chemicals into the soil, further degrading its quality. Urbanization can lead to increased soil sealing, preventing water infiltration and exacerbating the risk of soil erosion and contamination. 4.1.6 Accidental spills and contamination. Accidental spills and contamination events can have significant impacts on soil quality. Oil spills, chemical leaks, and transportation accidents can release large quantities of pollutants into the environment, including the soil. These incidents can result in immediate contamination and long-term damage to soil ecosystems. The spilled substances can penetrate the soil, affecting its fertility, microbial activity, and overall health. Cleanup efforts following such incidents are crucial to prevent further soil pollution and mitigate the potential risks to human health and the environment. 4.1.7 Deforestation and land degradation. Deforestation and land degradation contribute to soil pollution by removing vegetation cover and exposing the soil to erosion. When forests are cleared for agriculture, logging, or urban development, the protective layer of vegetation is lost, leaving the soil vulnerable to erosion by wind and water. Erosion can transport sediments, pollutants, and nutrients away from their original locations, leading to soil degradation and contamination. The loss of forests also disrupts the natural nutrient cycling processes, further compromising soil health and fertility. 4.1.8 Atmospheric deposition. Atmospheric deposition refers to the deposition of pollutants from the air onto the soil surface. Airborne pollutants, such as heavy metals, pesticides, and industrial emissions, can settle onto the soil through precipitation or dry deposition. These pollutants can accumulate in the soil over time, leading to contamination. Atmospheric deposition is particularly significant in areas near industrial facilities, major roadways, and agricultural regions where the use of pesticides and fertilizers is prevalent. In conclusion, soil pollution is caused by a combination of human activities and natural processes. Industrial activities, agricultural practices, improper waste disposal, mining activities, construction and urbanization, accidental spills, deforestation, and atmospheric deposition all contribute to soil pollution. Understanding these causes is essential in developing effective strategies to prevent soil pollution, protect human health, and preserve the integrity of ecosystems. By addressing these causes and adopting sustainable practices, we can work towards a cleaner and healthier environment for present and future generations. 4.2 Effects of soil pollution. Soil pollution, also known as land pollution, is the contamination of the soil with harmful substances that adversely affect its quality and fertility. It is caused by various human activities, such as industrial waste disposal, agricultural practices, improper waste management, and the use of hazardous chemicals. Soil pollution has significant effects on the environment, ecosystems, and human health. In this section, we will explore the various effects of soil pollution in detail. 4.2.1 Degradation of soil quality. One of the primary effects of soil pollution is the degradation of soil quality. When the soil becomes contaminated with pollutants, it loses its ability to support plant growth and sustain healthy ecosystems. Pollutants such as heavy metals, pesticides, herbicides, and industrial chemicals can alter the physical, chemical, and biological properties of the soil. This leads to a decrease in soil fertility, nutrient imbalance, and reduced water holding capacity. As a result, the productivity of agricultural lands decreases, affecting food production and posing a threat to global food security. 4.2.2 Contamination of groundwater. Soil pollution can also contaminate groundwater, which is a vital source of drinking water for many communities. When pollutants seep through the soil layers, they can reach the groundwater reservoirs, leading to the contamination of water sources. This contamination poses a significant risk to human health as it can result in the consumption of polluted water, causing various waterborne diseases and long-term health issues. Additionally, the contamination of groundwater affects aquatic ecosystems, disrupting the balance of aquatic life and biodiversity. 4.2.3 Negative impact on biodiversity. Soil pollution has a detrimental impact on biodiversity. The presence of pollutants in the soil can harm soil organisms, including earthworms, bacteria, fungi, and other microorganisms that play a crucial role in maintaining soil health and nutrient cycling. These organisms are essential for the decomposition of organic matter, nutrient availability, and the overall functioning of ecosystems. When the soil becomes polluted, it disrupts the delicate balance of the soil food web, leading to a decline in biodiversity and the loss of important ecological functions. 4.2.4 Crop contamination and food safety concerns. Another significant effect of soil pollution is the contamination of crops grown in polluted soil. Plants absorb pollutants from the soil through their roots, which can accumulate in their tissues. This poses a serious risk to human health as consuming contaminated crops can lead to the ingestion of toxic substances. Heavy metals, pesticides, and other pollutants can accumulate in the edible parts of plants, making them unsafe for consumption. This raises concerns about food safety and the potential health risks associated with the consumption of contaminated produce. 4.2.5 Soil erosion and land degradation. Soil pollution can contribute to soil erosion and land degradation. When the soil is contaminated, it becomes less stable and more susceptible to erosion by wind and water. The loss of topsoil due to erosion reduces soil fertility and the ability of the land to support vegetation. This leads to desertification, loss of arable land, and the destruction of natural habitats. Soil erosion also contributes to sedimentation in water bodies, leading to water pollution and the degradation of aquatic ecosystems. 4.2.6 Impact on human health. Soil pollution poses significant risks to human health. Exposure to contaminated soil can occur through direct contact, inhalation of dust particles, or consumption of contaminated food and water. The toxic substances present in polluted soil can enter the human body and cause various health problems. Heavy metals such as lead, cadmium, and mercury can accumulate in the body over time and lead to neurological disorders, kidney damage, and developmental issues, especially in children. Prolonged exposure to pesticides and other chemicals in the soil can also increase the risk of cancer, respiratory diseases, and reproductive disorders. 4.2.7 Disruption of ecosystem services. Ecosystem services, such as nutrient cycling, water filtration, and climate regulation, are essential for the functioning of ecosystems and the well-being of human societies. Soil pollution disrupts these ecosystem services by altering the natural processes that occur in the soil. For example, the presence of pollutants can inhibit the decomposition of organic matter, leading to a decrease in nutrient availability for plants. This can have cascading effects on the entire ecosystem, affecting plant growth, animal populations, and the overall balance of the ecosystem. 4.2.8 Economic implications. The effects of soil pollution also have significant economic implications. The decrease in soil fertility and agricultural productivity can result in reduced crop yields and increased production costs for farmers. This can lead to food shortages, higher food prices, and economic losses for agricultural communities. Additionally, the cleanup and remediation of polluted soil requires substantial financial resources. The economic burden of soil pollution extends beyond the agricultural sector, affecting industries, tourism, and overall economic development. In conclusion, soil pollution has wide-ranging effects on the environment, ecosystems, and human health. It degrades soil quality, contaminates groundwater, disrupts biodiversity, poses food safety concerns, contributes to soil erosion and land degradation, impacts human health, disrupts ecosystem services, and has significant economic implications. Addressing soil pollution requires a comprehensive approach that includes sustainable agricultural practices, proper waste management, remediation of contaminated sites, and the promotion of environmentally friendly policies and regulations. 4.3 Contaminants in soil. Soil pollution is a significant environmental issue that poses a threat to the health of ecosystems and human beings. It occurs when harmful substances, known as contaminants, are introduced into the soil, leading to its degradation and the potential contamination of water sources and food crops. Contaminants in soil can originate from various sources, including industrial activities, agricultural practices, improper waste disposal, and accidental spills. In this section, we will explore some of the common contaminants found in soil and their impact on the environment. 4.3.1 Heavy metals. Heavy metals are one of the most prevalent contaminants in soil. They include elements such as lead, mercury, cadmium, arsenic, and chromium. These metals are naturally occurring but can also be released into the environment through human activities. Industrial processes, mining operations, and the use of certain fertilizers and pesticides contribute to the accumulation of heavy metals in soil. The presence of heavy metals in soil can have severe consequences. They are toxic to both plants and animals, and their absorption by plants can lead to the contamination of the food chain. Human exposure to heavy metals through contaminated soil can result in various health issues, including neurological disorders, kidney damage, and cancer. Therefore, it is crucial to monitor and remediate soil contaminated with heavy metals to protect both the environment and human health. 4.3.2 Organic pollutants. Organic pollutants are another category of contaminants commonly found in soil. These pollutants include various chemicals, such as pesticides, herbicides, industrial solvents, and petroleum hydrocarbons. They can enter the soil through agricultural practices, industrial activities, and improper waste disposal. The persistence of organic pollutants in soil is a significant concern. Some of these compounds, such as polychlorinated biphenyls (PCBs) and polycyclic aromatic hydrocarbons (PAHs), can remain in the soil for extended periods, leading to long-term contamination. These pollutants can have detrimental effects on soil microorganisms, plant growth, and the overall soil ecosystem. Moreover, they can leach into groundwater, posing a risk to drinking water sources. Efforts to mitigate the presence of organic pollutants in soil include implementing proper waste management practices, promoting the use of organic farming methods, and adopting sustainable industrial processes. Additionally, the remediation of contaminated sites through techniques like bioremediation and phytoremediation can help restore the health of the soil. 4.3.3 Nutrient imbalances. While nutrients are essential for plant growth, an imbalance in their concentration can lead to soil pollution. Excessive use of chemical fertilizers in agriculture can result in the accumulation of nutrients such as nitrogen and phosphorus in the soil. This can cause nutrient runoff into water bodies, leading to eutrophication and the formation of harmful algal blooms. Nutrient imbalances in soil can also affect the composition of the soil microbiome, leading to a decline in beneficial microorganisms and an increase in harmful pathogens. This imbalance can disrupt the natural nutrient cycling processes in the soil and negatively impact plant health. To address nutrient imbalances, sustainable agricultural practices such as precision farming, organic fertilization, and crop rotation can be implemented. These practices aim to optimize nutrient use efficiency, reduce fertilizer runoff, and promote the overall health of the soil. 4.3.4 Radioactive contaminants. Radioactive contaminants, such as uranium, radium, and cesium, can also contaminate soil. These contaminants can enter the soil through nuclear accidents, improper disposal of radioactive waste, or natural processes like the weathering of rocks containing radioactive elements. The presence of radioactive contaminants in soil poses significant risks to both the environment and human health. Exposure to high levels of radiation can cause genetic mutations, cancer, and other serious health conditions. Therefore, it is crucial to monitor and remediate soil contaminated with radioactive substances to prevent their spread and minimize the associated risks. Remediation techniques for radioactive contaminants in soil include soil washing, stabilization, and immobilization. These methods aim to reduce the mobility and bioavailability of radioactive elements, thereby minimizing their potential impact on the environment. 4.3.5 Emerging contaminants. In addition to the well-known contaminants, there are also emerging contaminants that pose a growing concern for soil pollution. These include pharmaceuticals, personal care products, flame retardants, and microplastics. These contaminants can enter the soil through various pathways, such as wastewater irrigation, landfill leachate, and the application of biosolids. The impact of emerging contaminants on soil health and the environment is still being studied. However, early research suggests that they can have adverse effects on soil microorganisms, plant growth, and the overall soil ecosystem. Therefore, it is essential to monitor and regulate the use and disposal of these emerging contaminants to prevent their accumulation in soil. In conclusion, soil contamination by various contaminants is a significant environmental issue. Heavy metals, organic pollutants, nutrient imbalances, radioactive contaminants, and emerging contaminants all contribute to soil pollution. The presence of these contaminants can have detrimental effects on soil health, plant growth, and the overall ecosystem. Implementing proper waste management practices, promoting sustainable agricultural and industrial practices, and adopting remediation techniques are crucial steps in mitigating soil pollution and protecting the environment and human health. 4.4 Remediation of soil pollution. Soil pollution is a significant environmental issue that poses a threat to ecosystems, human health, and agricultural productivity. It occurs when harmful substances contaminate the soil, making it unsuitable for plant growth and disrupting the delicate balance of the soil ecosystem. The causes of soil pollution are diverse and can range from industrial activities and improper waste disposal to the use of pesticides and fertilizers in agriculture. Remediation of soil pollution is crucial to restore the health and fertility of contaminated soils. It involves the implementation of various techniques and strategies to remove or neutralize pollutants, minimize their spread, and promote the recovery of the soil ecosystem. The choice of remediation method depends on the type and extent of contamination, as well as the specific characteristics of the soil and pollutants involved. 4.4.1 Physical remediation techniques. Physical remediation techniques involve the physical removal or containment of pollutants from the soil. These methods are often used for surface contamination or when the pollutants are easily accessible. Some common physical remediation techniques include 4.4.1.1 Excavation and removal. Excavation and removal involve the excavation of contaminated soil and its transportation to a designated disposal site. This method is effective for localized contamination but can be costly and disruptive, especially for large-scale pollution incidents. Proper handling and disposal of the excavated soil are essential to prevent further contamination. 4.4.1.2 Soil vapor extraction. Soil vapor extraction is a technique used to remove volatile organic compounds, VOCs, from the soil. It involves the installation of extraction wells in the contaminated area, which create a vacuum to draw out the vapors. The extracted vapors are then treated and disposed of properly. This method is effective for shallow contamination and can be combined with other techniques for better results. 4.4.1.3 Soil washing. Soil washing is a process that uses water or other solvents to remove contaminants from the soil. The contaminated soil is mixed with the solvent, and the mixture is agitated to release the pollutants. The soil is then separated from the solvent, and the extracted contaminants are treated or disposed of appropriately. Soil washing is effective for removing heavy metals and organic pollutants but may require additional treatment steps for complete remediation. 4.4.2 Chemical remediation techniques. Chemical remediation techniques involve the use of chemicals to transform or degrade pollutants in the soil. These methods are often used for subsurface contamination or when physical removal is not feasible. Some common chemical remediation techniques include 4.4.2.1 Soil stabilization. Soil stabilization aims to immobilize contaminants in the soil, reducing their mobility and bioavailability. This technique involves the addition of chemicals such as lime, cement, or phosphate compounds to the contaminated soil. These chemicals react with the pollutants, forming stable compounds or reducing their solubility. Soil stabilization is effective for heavy metals and certain organic pollutants but may require long-term monitoring to ensure the stability of the treated soil. 4.4.2.2 Chemical oxidation. Chemical oxidation is a technique used to degrade organic pollutants in the soil. It involves the application of oxidizing agents such as hydrogen peroxide, ozone, or potassium permanganate to the contaminated soil. These agents react with the pollutants, breaking them down into less harmful substances. Chemical oxidation can be applied in situ or ex situ, depending on the extent of contamination and site conditions. 4.4.2.3 Phytoremediation. Phytoremediation is a natural and sustainable remediation technique that utilizes plants to remove, degrade, or immobilize pollutants in the soil. Certain plants, known as hyperaccumulators, have the ability to absorb and accumulate high concentrations of heavy metals or organic pollutants in their tissues. Phytoremediation can be implemented through various methods, including phytoextraction, phytostabilization, and rhizodegradation. It is a cost-effective and environmentally friendly approach but may require a longer time frame for complete remediation. 4.4.3 Biological remediation techniques. Biological remediation techniques involve the use of microorganisms or plants to degrade or transform pollutants in the soil. These methods harness the natural abilities of living organisms to break down contaminants and restore the soil ecosystem. Some common biological remediation techniques include 4.4.3.1 Bioremediation. Bioremediation is a technique that utilizes microorganisms to degrade or transform pollutants in the soil. It can be achieved through natural attenuation, bioaugmentation, or biostimulation. Natural attenuation relies on the existing microbial population in the soil to degrade the contaminants over time. Bioaugmentation involves the introduction of specific microorganisms to enhance the degradation process. Biostimulation aims to stimulate the growth and activity of indigenous microorganisms through the addition of nutrients or other amendments. Bioremediation is a cost-effective and sustainable approach but requires careful monitoring and optimization. 4.4.3.2 Phytoremediation. As mentioned earlier, phytoremediation is a biological technique that uses plants to remediate soil pollution. It relies on the ability of certain plants to absorb, accumulate, and detoxify pollutants in their tissues. Phytoremediation can be combined with other techniques to enhance its effectiveness. The choice of plants depends on the type of contaminants present and the specific site conditions. 4.4.4 Integrated remediation approaches. In many cases, a combination of different remediation techniques is necessary to achieve effective and sustainable soil remediation. Integrated remediation approaches involve the use of multiple techniques in a coordinated manner to address the complexity of soil pollution. These approaches may include a combination of physical, chemical, and biological techniques tailored to the specific contamination scenario. Integrated remediation approaches aim to maximize the efficiency of remediation while minimizing the environmental impact and cost. Remediation of soil pollution is a challenging task that requires careful planning, implementation, and monitoring. It is essential to consider the long-term sustainability of the remediation methods and their potential impacts on the soil ecosystem. Additionally, public awareness and education play a crucial role in preventing soil pollution and promoting sustainable land management practices. By taking proactive measures and implementing appropriate remediation strategies, we can mitigate the impacts of soil pollution and ensure the health and productivity of our soils for future generations. 5. Noise pollution. 5.1 Sources of noise pollution. Noise pollution is a growing concern in our modern society. It refers to the excessive and unwanted sound that disrupts the environment and affects human health and well-being. The sources of noise pollution are diverse and can be found in various aspects of our daily lives. In this section, we will explore some of the major sources of noise pollution and their impact on our lives. 5.1.1 Transportation noise. One of the primary sources of noise pollution is transportation. The constant noise generated by vehicles, such as cars, motorcycles, trucks, and airplanes, contributes significantly to the overall noise levels in urban areas. Road traffic noise is particularly problematic, especially in densely populated cities. The continuous honking of horns, engine noise, and tire screeching can be highly disruptive and lead to increased stress levels, sleep disturbances, and even hearing loss. Airports are another significant contributor to transportation noise pollution. The loud noise generated by aircraft taking off and landing can be heard over long distances, affecting not only those living near airports but also communities located further away. The constant exposure to aircraft noise can have detrimental effects on mental health, concentration, and overall quality of life. 5.1.2 Construction and industrial activities. Construction sites and industrial areas are notorious for generating high levels of noise pollution. The use of heavy machinery, power tools, and equipment produces loud and persistent noise that can be heard for miles. Construction activities, such as drilling, hammering, and excavation, can disrupt the peace and tranquility of residential areas, causing annoyance and discomfort to nearby residents. Industrial facilities, including factories, power plants, and manufacturing units, also contribute significantly to noise pollution. The operation of large machinery, ventilation systems, and the movement of goods and materials generate continuous noise that can have adverse effects on the health and well-being of workers in nearby communities. Prolonged exposure to industrial noise can lead to hearing impairment, stress-related disorders, and reduced productivity. 5.1.3 Recreational and entertainment noise. Recreational and entertainment activities can be enjoyable, but they can also be a significant source of noise pollution. Events such as concerts, sporting events, festivals, and nightclubs often involve loud music and cheering crowds, which can create excessive noise levels. While these activities are meant for entertainment, they can cause discomfort, annoyance, and even permanent hearing damage if proper precautions are not taken. In residential areas, the use of loudspeakers, home theaters, and personal music systems at high volumes can also contribute to noise pollution. The sound can easily travel through walls and disturb neighbors, leading to conflicts and a decrease in the overall quality of life. 5.1.4 Commercial and urban noise. Commercial areas and urban environments are prone to noise pollution due to various activities and infrastructure. Restaurants, bars, and cafes with outdoor seating often generate noise from conversations, music, and kitchen operations. The constant flow of customers and delivery vehicles can add to the overall noise levels in these areas. Urban noise pollution is also caused by the presence of construction sites, traffic congestion, and public transportation systems. The continuous movement of people, vehicles, and public announcements can create a cacophony of sounds that can be overwhelming and disruptive to residents and workers in urban areas. 5.1.5 Household noise. Even within our own homes, noise pollution can be a concern. Household appliances such as vacuum cleaners, washing machines, and blenders can produce high levels of noise that can be bothersome, especially in small living spaces. Additionally, the use of power tools, home renovations, and even loud conversations or arguments can contribute to noise pollution within residential areas. It is important to note that while some noise sources may seem insignificant individually, their cumulative effect can be significant, leading to chronic exposure and adverse health effects. Understanding the sources of noise pollution is crucial in developing effective strategies to mitigate its impact on our lives. In the next section, we will explore the effects of noise pollution on human health and well-being. 5.2 Effects of noise pollution. Noise pollution is a growing concern in our modern society. It refers to the excessive or disturbing noise that disrupts the natural environment and causes adverse effects on human health and well-being. While noise is a part of everyday life, excessive and prolonged exposure to high levels of noise can have significant impacts on individuals, communities, and the environment. 5.2.1 Health impacts of noise pollution. The effects of noise pollution on human health are wide-ranging and can manifest in various ways. Prolonged exposure to loud noise can lead to hearing loss, especially in occupational settings where workers are exposed to high noise levels for extended periods. Additionally, noise pollution can disrupt sleep patterns, leading to sleep disturbances and insomnia. Lack of quality sleep can have detrimental effects on overall health, including increased stress levels, impaired cognitive function, and decreased productivity. Noise pollution has also been linked to cardiovascular problems. Studies have shown that chronic exposure to high levels of noise can increase the risk of hypertension, heart disease, and stroke. The constant stimulation of the body's stress response due to noise can elevate blood pressure and heart rate, leading to long-term cardiovascular issues. Furthermore, noise pollution can have psychological effects on individuals. Continuous exposure to loud and disturbing noise can cause irritability, anxiety, and even depression. It can disrupt concentration and impair cognitive performance, affecting learning abilities and productivity. Children exposed to noise pollution may experience difficulties in language development and academic performance. 5.2.2 Environmental impacts of noise pollution. Noise pollution not only affects human health but also has significant impacts on the environment and wildlife. Excessive noise can disrupt the natural behavior and communication patterns of animals, leading to changes in their feeding, mating, and migration patterns. Marine animals, such as whales and dolphins, rely heavily on sound for communication and navigation. Underwater noise pollution from activities like shipping, sonar systems, and offshore drilling can interfere with their ability to communicate and locate food, resulting in disorientation and even death. In terrestrial ecosystems, noise pollution can disrupt the balance of predator-prey relationships. Animals that rely on hearing for hunting or avoiding predators may be at a disadvantage when exposed to excessive noise. It can also lead to habitat fragmentation, as animals may avoid noisy areas, limiting their access to essential resources and reducing biodiversity. 5.2.3 Social and economic impacts of noise pollution. Noise pollution can have significant social and economic consequences for communities. Excessive noise in residential areas can lead to annoyance, stress, and decreased quality of life for residents. It can disrupt daily activities, such as conversation, relaxation, and sleep, leading to frustration and dissatisfaction. Noise pollution near schools and hospitals can affect the learning environment and patient recovery, respectively. In urban areas, noise pollution from transportation, construction, and industrial activities can contribute to noise-related stress and reduce property values. It can deter potential investors and businesses from establishing in noisy areas, impacting economic growth and development. Additionally, noise pollution can affect tourism, as visitors may seek quieter destinations for relaxation and enjoyment. 5.2.4 Mitigating noise pollution. To address the adverse effects of noise pollution, various measures can be taken at individual, community, and governmental levels. Noise control and mitigation strategies include regulations and standards. Governments can establish and enforce noise regulations and standards to limit noise levels in different settings, such as residential, industrial, and transportation areas. These regulations can include restrictions on noise-emitting activities, noise insulation requirements for buildings, and noise limits for vehicles and machinery. Noise barriers and insulation. The construction of noise barriers, such as walls and berms, can help reduce the transmission of noise from highways, railways, and industrial areas to nearby residential areas. Additionally, the use of noise insulation materials in buildings can minimize indoor noise levels and provide a quieter living and working environment. Urban planning and design. Urban planners can incorporate noise reduction strategies into city design, such as locating residential areas away from noisy sources, creating green spaces as noise buffers, and implementing traffic management measures to reduce noise from vehicles. Technology and engineering solutions. Advancements in technology and engineering have led to the development of quieter machinery, vehicles, and infrastructure. The use of noise-reducing technologies, such as low-noise tires, sound barriers on highways, and noise-canceling devices, can help mitigate noise pollution. Public awareness and education. Raising awareness about the impacts of noise pollution and promoting responsible behavior can encourage individuals to reduce noise levels in their daily lives. Education programs can focus on noise management techniques, the importance of quiet zones, and the benefits of noise reduction for health and well-being. By implementing these measures, we can effectively reduce noise pollution and create healthier, more peaceful environments for both humans and wildlife. It requires a collective effort from individuals, communities, and governments to address this pervasive issue and ensure a quieter and more sustainable future. 5.3 Health impacts of noise pollution. Noise pollution is a pervasive problem in our modern society, with detrimental effects on human health and well-being. Excessive noise levels can have both immediate and long-term impacts on various aspects of our physical and mental health. In this section, we will explore the health consequences of noise pollution and the importance of addressing this issue. 5.3.1 Physical health effects. Hearing loss. One of the most well-known health effects of noise pollution is hearing loss. Prolonged exposure to loud noises can damage the delicate structures of the inner ear, leading to permanent hearing impairment. This is particularly concerning in occupational settings where workers are exposed to high noise levels for extended periods. Industries such as construction, manufacturing, and transportation are known to contribute significantly to noise-induced hearing loss. Cardiovascular problems. Noise pollution has been linked to an increased risk of cardiovascular diseases. Studies have shown that chronic exposure to loud noise can elevate blood pressure, increase heart rate, and disrupt normal heart rhythm. These physiological responses can contribute to the development of conditions such as hypertension, heart disease, and stroke. Individuals living in noisy urban areas or near busy roadways are particularly vulnerable to these cardiovascular effects. Sleep disturbances. Noise pollution can severely disrupt our sleep patterns, leading to a range of health issues. Continuous exposure to loud noises during the night can make it difficult to fall asleep and maintain a deep sleep state. This can result in sleep deprivation, which has been associated with a weakened immune system, impaired cognitive function, and an increased risk of chronic conditions such as obesity, diabetes, and depression. Children are especially susceptible to the negative effects of noise on sleep, which can hinder their growth and development. 5.3.2 Mental health effects. Stress and anxiety. Excessive noise can trigger stress responses in the body, leading to increased levels of stress hormones such as cortisol. Chronic exposure to noise pollution can contribute to the development of anxiety disorders, including generalized anxiety disorder and post-traumatic stress disorder (PTSD). The constant presence of noise can create a sense of helplessness and irritability, negatively impacting our overall mental well-being. Cognitive impairment. Noise pollution can impair our cognitive abilities, affecting our concentration, memory, and problem-solving skills. Studies have shown that exposure to loud noises can hinder learning outcomes in schools and decrease productivity in workplaces. The constant background noise can make it challenging to focus on tasks, leading to decreased performance and increased errors. Children exposed to noise pollution during critical developmental stages may experience long-term cognitive deficits. Psychological distress. Living in noisy environments can contribute to psychological distress and mood disorders. The constant barrage of noise can lead to feelings of frustration, annoyance, and even anger. Individuals exposed to high levels of noise for prolonged periods may experience symptoms of depression and have a higher risk of developing mental health conditions. Noise pollution can also disrupt social interactions and decrease overall quality of life. 5.3.3 Vulnerable populations. Certain groups of people are more susceptible to the health impacts of noise pollution. Children. Children, especially infants and young children, are particularly vulnerable to the adverse effects of noise pollution. Their developing auditory systems are more sensitive to loud noises, and exposure to excessive noise can hinder their language acquisition and cognitive development. Additionally, noise-related sleep disturbances can disrupt their growth and overall well-being. Elderly. The elderly population is also at a higher risk of experiencing health issues related to noise pollution. Age-related hearing loss, known as presbycusis, can make older individuals more susceptible to the damaging effects of loud noises. Noise pollution can exacerbate their existing hearing impairments and contribute to social isolation, communication difficulties, and cognitive decline. Individuals with existing health conditions. People with pre-existing health conditions such as cardiovascular diseases, mental health disorders, and sleep disorders are more susceptible to the negative impacts of noise pollution. The additional stress and disruption caused by noise can worsen their symptoms and overall health outcomes. 5.3.4 Noise pollution control and prevention. Given the significant health impacts of noise pollution, it is crucial to implement measures to control and prevent excessive noise levels. Some strategies include urban planning and design. Incorporating noise reduction measures into urban planning and design can help create quieter and more livable cities. This includes implementing noise barriers along highways, using noise-absorbing materials in buildings, and designing green spaces as buffers against noise. Noise regulations and standards. Enforcing noise regulations and standards is essential to limit excessive noise levels in various settings. This includes setting noise limits for industrial activities, construction sites, and transportation. Strict enforcement of these regulations can help protect both workers and the general population from the harmful effects of noise pollution. Noise barriers and insulation. Installing noise barriers and insulation in buildings can significantly reduce the transmission of external noise into indoor spaces. This is particularly important for schools, hospitals, and residential areas located near noisy sources such as airports or highways. Public awareness and education. Raising public awareness about the health impacts of noise pollution is crucial for promoting individual and collective action. Educating communities about the importance of noise reduction and providing practical tips for reducing noise exposure can empower individuals to take steps towards a quieter and healthier environment. In conclusion, noise pollution has far-reaching health consequences, affecting both our physical and mental well-being. It is essential to address this issue through effective noise control measures, regulations, and public awareness campaigns. By reducing noise pollution, we can create healthier and more peaceful environments for everyone. 5.4 Reducing noise pollution. Noise pollution is a growing concern in our modern society. It is caused by various sources such as traffic, construction activities, industrial machinery, and even everyday activities like loud music or conversations. Excessive noise can have detrimental effects on human health, including stress, sleep disturbances, hearing loss, and impaired cognitive function. It can also disrupt wildlife habitats and interfere with their communication and behavior. To combat noise pollution, it is essential to implement effective measures that reduce noise levels and create a more peaceful environment for everyone. In this section, we will explore some strategies and solutions to mitigate noise pollution. 5.4.1 Noise barriers and soundproofing. One of the most effective ways to reduce noise pollution is by implementing noise barriers and soundproofing measures. Noise barriers are physical structures designed to block or absorb sound waves, preventing them from reaching sensitive areas. They are commonly used along highways, railways, and construction sites to minimize the impact of noise on nearby communities. Soundproofing, on the other hand, involves modifying buildings or spaces to reduce the transmission of sound. This can be achieved through the use of sound-absorbing materials, such as acoustic panels or insulation, which absorb and dampen sound waves. Soundproof windows and doors can also significantly reduce noise infiltration from outside sources. 5.4.2 Urban planning and land use regulations. Proper urban planning and land use regulations play a crucial role in reducing noise pollution. By strategically designing cities and communities, we can minimize noise exposure and create quieter living environments. This can be achieved by separating residential areas from noisy industrial or commercial zones and locating schools, hospitals, and other sensitive facilities away from high-noise areas. Land use regulations can also impose restrictions on noise-emitting activities, such as construction work or outdoor events, during specific hours to minimize disturbance to residents. Additionally, zoning laws can limit the establishment of noisy businesses near residential areas, ensuring a more peaceful coexistence. 5.4.3 Noise control in transportation. Transportation is a significant contributor to noise pollution, particularly in urban areas. To reduce noise from vehicles, several measures can be implemented. These include the use of noise-reducing road surfaces, such as rubberized asphalt, which absorbs and dampens tire noise. Additionally, the installation of noise barriers along highways and railways can help mitigate the impact of traffic noise on nearby communities. In terms of public transportation, the use of electric or hybrid vehicles can significantly reduce noise emissions compared to traditional combustion engines. Encouraging the adoption of quieter transportation options, such as bicycles or electric scooters, can also contribute to noise reduction in urban areas. 5.4.4 Noise reduction in construction and industrial activities. Construction and industrial activities are notorious for generating high levels of noise. However, there are several measures that can be implemented to minimize their impact. Construction sites can adopt quieter construction methods and equipment, such as electric-powered machinery or noise-reducing attachments. Additionally, implementing strict noise control regulations and monitoring systems can ensure that noise levels are kept within acceptable limits. Industrial facilities can also invest in noise control measures, such as enclosing noisy machinery, using vibration isolation techniques, or implementing noise-reducing technologies. Regular maintenance and inspection of equipment can also help identify and address noise-related issues promptly. 5.4.5 Noise education and awareness. Raising awareness about the harmful effects of noise pollution is crucial in promoting behavior change and encouraging individuals to take action. Educational campaigns can inform the public about the sources and impacts of noise pollution, as well as provide practical tips on how to reduce noise exposure in their daily lives. Schools and educational institutions can incorporate noise pollution awareness into their curriculum, teaching students about the importance of quiet environments and the steps they can take to minimize noise pollution. Public awareness campaigns, through various media channels, can also reach a wider audience and encourage collective action. 5.4.6 Noise regulations and enforcement. Government regulations and enforcement play a vital role in controlling noise pollution. Setting noise standards and limits for different activities and environments is essential to ensure that noise levels are kept within acceptable ranges. These regulations can include restrictions on noise-emitting activities, permissible noise levels for different zones, and penalties for non-compliance. Effective enforcement of noise regulations is equally important. Regular monitoring and inspections can help identify violators and ensure that necessary actions are taken to address noise pollution. Collaboration between government agencies, law enforcement, and community organizations can strengthen the enforcement process and create a culture of compliance. 5.4.7 Community involvement and collaboration. Reducing noise pollution requires collective efforts from individuals, communities, and various stakeholders. Community involvement plays a crucial role in identifying noise sources, advocating for noise reduction measures, and monitoring compliance with noise regulations. Establishing community noise action groups or committees can provide a platform for residents to voice their concerns and work together towards noise reduction initiatives. Collaboration between community organizations, local businesses, and government agencies can lead to the development of effective noise reduction strategies tailored to specific communities. In conclusion, noise pollution is a significant environmental issue that affects our well-being and quality of life. By implementing a combination of measures such as noise barriers, soundproofing, urban planning, transportation improvements, and community involvement, we can effectively reduce noise pollution and create quieter and more peaceful environments for everyone. It is essential for individuals, communities, and governments to work together to address this issue and promote a healthier and more sustainable future. 6. Light pollution. 6.1 Causes of light pollution. Light pollution is a growing environmental concern that is caused by the excessive and misdirected artificial lighting in our surroundings. It is the result of the overuse and misuse of artificial light sources, which leads to the brightening of the night sky and the obscuring of natural darkness. While light is essential for human activities and safety, the uncontrolled and unnecessary use of artificial lighting has significant negative impacts on the environment, wildlife, human health, and astronomical observations. 6.1.1 Urbanization and development. One of the primary causes of light pollution is the rapid urbanization and development of cities and towns. As urban areas expand, the demand for artificial lighting increases to meet the needs of businesses, industries, and residential areas. The excessive use of streetlights, building lights, and illuminated signs contributes to the overall brightness of the night sky. The uncontrolled growth of urban areas without proper lighting regulations exacerbates the problem, leading to the spread of light pollution. 6.1.2 Outdoor lighting practices. The way outdoor lighting is designed and implemented also plays a significant role in contributing to light pollution. Improperly designed lighting fixtures, such as those that emit light in all directions instead of directing it downward, contribute to the scattering of light into the atmosphere. This scattering effect creates a glow in the sky, making it difficult to see stars and other celestial objects. Additionally, the excessive brightness of outdoor lighting can spill over into neighboring areas, causing unnecessary illumination and wastage of energy. 6.1.3 Excessive illumination. Excessive illumination is another major cause of light pollution. Many outdoor spaces, such as parking lots, sports fields, and commercial areas, are often illuminated far beyond what is necessary for safety and security purposes. This over-illumination not only wastes energy but also contributes to the overall brightness of the night sky. The use of high-intensity discharge lamps, such as mercury vapor lamps and high-pressure sodium lamps, further exacerbates the problem by emitting large amounts of light in all directions. 6.1.4 Advertising and decorative lighting. Advertising and decorative lighting also contribute significantly to light pollution. Brightly lit billboards, neon signs, and decorative lighting installations are often designed to attract attention and create a visually appealing environment. However, these lighting practices often result in the unnecessary and excessive use of artificial light, which adds to the overall brightness of the night sky. Additionally, the constant illumination of these advertising and decorative lights throughout the night further disrupts the natural day-night cycle and affects the behavior of nocturnal animals. 6.1.5 Inefficient lighting technology. The use of inefficient lighting technology is another cause of light pollution. Traditional incandescent bulbs and older fluorescent tubes are highly inefficient and emit light in all directions, including upwards. These outdated lighting technologies waste a significant amount of energy and contribute to the overall brightness of the night sky. However, the widespread adoption of more energy-efficient lighting options, such as light-emitting diodes (LEDs), has the potential to reduce light pollution. LEDs can be directed and controlled more effectively, minimizing light spillage and reducing energy consumption. 6.1.6 Lack of awareness and education. A lack of awareness and education about the impacts of light pollution is also a contributing factor. Many people are unaware of the negative consequences of excessive artificial lighting and the importance of preserving natural darkness. Without proper knowledge and understanding, individuals and communities may not take the necessary steps to reduce light pollution. Education and awareness campaigns can play a crucial role in promoting responsible lighting practices and encouraging the adoption of lighting technologies that minimize light pollution. 6.1.7 Absence of lighting regulations. The absence or inadequate enforcement of lighting regulations is a significant cause of light pollution. Without proper guidelines and restrictions on outdoor lighting, there is little incentive for individuals, businesses, and municipalities to reduce light pollution. Implementing and enforcing lighting regulations that promote the use of shielded and directed lighting fixtures, as well as setting limits on illumination levels, can help mitigate the problem. Additionally, the establishment of dark sky reserves and protected areas can preserve natural darkness and promote stargazing and astronomical research. In conclusion, light pollution is primarily caused by urbanization and development, improper outdoor lighting practices, excessive illumination, advertising and decorative lighting, inefficient lighting technology, lack of awareness and education, and the absence of lighting regulations. Understanding these causes is crucial in developing effective strategies to mitigate light pollution and preserve the beauty of the night sky while minimizing its negative impacts on the environment, wildlife, and human well-being. 6.2 Effects of light pollution. Light pollution refers to the excessive or misdirected artificial light that is emitted into the environment. While it may seem harmless, light pollution has a range of negative effects on various aspects of our lives, including human health, wildlife, and the overall ecosystem. In this section, we will explore the different effects of light pollution and its consequences. 6.2.1 Disruption of natural cycles. One of the primary effects of light pollution is the disruption of natural cycles, particularly the circadian rhythm. The circadian rhythm is the internal biological clock that regulates various physiological processes in living organisms. Artificial light at night can interfere with this natural rhythm, leading to sleep disturbances, insomnia, and other sleep-related disorders in humans. It can also disrupt the natural sleep-wake cycle of nocturnal animals, affecting their behavior, reproduction, and overall survival. 6.2.2 Impact on wildlife. Light pollution has a significant impact on wildlife, particularly birds, insects, and marine creatures. Many bird species rely on natural light cues, such as the position of the sun and stars, for navigation during migration. Artificial lights can disorient birds, causing them to collide with buildings, communication towers, or other structures, resulting in injury or death. Similarly, nocturnal insects are attracted to artificial lights, leading to population declines and disruptions in ecosystems. In marine environments, light pollution can have detrimental effects on various species, including sea turtles. Hatchling sea turtles rely on the natural light from the moon to find their way to the ocean after hatching. However, artificial lights near beaches can confuse them, leading them away from the ocean and towards danger. This can significantly impact sea turtle populations, which are already facing numerous threats. 6.2.3 Ecological consequences. Light pollution can have far-reaching ecological consequences. It disrupts the natural balance of ecosystems by altering the behavior and interactions of different species. For example, predators that rely on darkness for hunting may become less effective, leading to imbalances in prey populations. Additionally, the excessive artificial light can interfere with the pollination process, as nocturnal pollinators such as moths and bats are attracted to artificial lights instead of flowers, impacting plant reproduction. Furthermore, light pollution can disrupt the natural patterns of plant growth and development. Many plants require periods of darkness to initiate certain physiological processes, such as flowering and fruiting. Artificial lights can interfere with these processes, leading to reduced plant productivity and biodiversity. 6.2.4 Health impacts on humans. The effects of light pollution extend beyond disrupting sleep patterns. Studies have shown that exposure to artificial light at night can have adverse effects on human health. Chronic exposure to excessive artificial light has been linked to an increased risk of various health conditions, including obesity, diabetes, cardiovascular diseases, and certain types of cancer. The disruption of the circadian rhythm caused by light pollution can also affect hormone regulation, leading to hormonal imbalances and associated health issues. Additionally, exposure to bright artificial light at night can suppress the production of melatonin, a hormone that plays a crucial role in regulating sleep and other physiological processes. 6.2.5 Astronomical interference. Another significant consequence of light pollution is its interference with astronomical observations. The excessive artificial light in urban areas creates a glow in the night sky, making it difficult to observe stars, planets, and other celestial objects. This not only hinders scientific research but also deprives people of the opportunity to appreciate the beauty and wonder of the night sky. 6.2.6 Energy waste and environmental impact. Light pollution also contributes to unnecessary energy consumption and environmental degradation. The excessive use of artificial lighting results in the wasteful use of electricity, leading to increased greenhouse gas emissions and the depletion of natural resources. Moreover, the production and disposal of lighting fixtures and bulbs contribute to pollution and waste generation. 6.2.7 Psychological and social effects. Lastly, light pollution can have psychological and social effects on individuals and communities. The constant exposure to artificial light at night can disrupt the sense of tranquility and connection with nature. It can also contribute to a sense of disconnection from the natural environment, and the loss of the night as a time for relaxation and rejuvenation. In urban areas, the constant presence of artificial light can lead to a loss of the night sky as a shared cultural and recreational resource. This can impact the quality of life and well-being of individuals, as well as the sense of community and connection within neighborhoods. Overall, the effects of light pollution are diverse and far-reaching. It not only impacts human health but also disrupts natural cycles, harms wildlife, alters ecosystems, interferes with astronomical observations, wastes energy, and affects psychological well-being. Recognizing the detrimental effects of light pollution is crucial in implementing effective measures to mitigate its impact and preserve the natural darkness of our environment. 6.3 Ecological consequences of light pollution. Light pollution, the excessive or misdirected artificial light produced by human activities, has far-reaching ecological consequences. While often overlooked compared to other forms of pollution, such as air or water pollution, light pollution poses significant threats to various ecosystems and the organisms that inhabit them. In this section, we will explore the ecological consequences of light pollution and its impact on different aspects of the natural world. 6.3.1 Disruption of natural cycles. One of the most significant ecological consequences of light pollution is the disruption of natural cycles. Many organisms, including plants, animals, and insects, rely on natural light cues to regulate their behavior and biological processes. Artificial light at night can interfere with these natural cycles, leading to detrimental effects on the ecosystem. For example, light pollution can disrupt the circadian rhythms of animals, which can affect their feeding patterns, reproduction, and migration. Nocturnal animals, such as birds, bats, and insects, are particularly vulnerable to the effects of light pollution. Artificial lights can disorient them, leading to collisions with buildings or other structures, and interfering with their ability to navigate and find food. Light pollution can also disrupt the natural cycles of plants. Many plants rely on periods of darkness to initiate important physiological processes, such as flowering and seed germination. Artificial light at night can disrupt these processes, leading to reduced reproductive success and altered plant communities. 6.3.2 Alteration of ecosystem dynamics. Light pollution can alter the dynamics of ecosystems by changing the interactions between different species. For example, artificial lights can attract insects, which in turn attract predators such as bats and birds. This can disrupt natural predator-prey relationships and lead to imbalances in the ecosystem. Additionally, light pollution can affect the behavior of nocturnal pollinators, such as moths and bats, which play a crucial role in pollinating plants. Artificial lights can attract these pollinators away from their natural habitats, reducing their effectiveness in pollination and potentially impacting plant reproduction. Furthermore, light pollution can disrupt the natural behavior of marine organisms. Many marine species, including sea turtles and certain fish species, rely on natural light cues for navigation and reproduction. Artificial lights near coastal areas can disorient sea turtles, leading to nesting failures and increased vulnerability to predation. It can also disrupt the feeding patterns of marine organisms, affecting the balance of marine ecosystems. 6.3.3 Impact on wildlife and biodiversity. Light pollution poses a significant threat to wildlife and biodiversity. Many species have evolved in darkness and are not adapted to cope with the presence of artificial lights. The constant exposure to artificial lights can have detrimental effects on their health and survival. For example, light pollution can disrupt the natural behavior of nocturnal animals, making them more vulnerable to predation. It can also interfere with their ability to find food and mates, leading to reduced reproductive success and population decline. Additionally, light pollution can have indirect effects on wildlife by altering the availability of resources. For instance, excessive lighting can disrupt the natural patterns of insect populations, which are a vital food source for many species. This disruption can have cascading effects throughout the food chain, impacting the abundance and diversity of other organisms. 6.3.4 Disturbance of natural habitats. Light pollution can also disturb natural habitats, particularly those that are sensitive to light. Many ecosystems, such as forests, wetlands, and coastal areas, have evolved under natural light conditions. Artificial lights can disrupt these habitats, leading to changes in species composition and ecosystem functioning. For example, excessive lighting near coastal areas can disrupt the natural behavior of marine organisms and impact the health of coral reefs and seagrass beds. In forests, light pollution can affect the growth and development of plants, leading to changes in the structure of the forest and the composition of plant communities. Furthermore, light pollution can contribute to the fragmentation of habitats. Bright lights can create barriers for certain species, preventing them from accessing essential resources or dispersing to new areas. This fragmentation can isolate populations, reduce genetic diversity, and increase the risk of local extinctions. 6.3.5 Conservation Challenges. The ecological consequences of light pollution present significant challenges for conservation efforts. Protecting and restoring natural habitats is crucial for maintaining biodiversity and ecosystem functioning. However, the pervasive nature of light pollution makes it difficult to mitigate its effects. Conservationists and researchers are working to raise awareness about the ecological consequences of light pollution and develop strategies to minimize its impact. These strategies include implementing lighting regulations, using shielded and energy-efficient lighting fixtures, and promoting the use of dark sky areas where artificial lights are minimized. Furthermore, collaboration between different stakeholders, including governments, communities, and industries, is essential to address the issue of light pollution effectively. By working together, we can reduce the ecological consequences of light pollution and create a more sustainable and harmonious environment for both humans and wildlife. In the next section, we will explore various measures and techniques to mitigate light pollution and promote responsible lighting practices. 6.4 Mitigating light pollution. Light pollution is a growing concern that affects both urban and rural areas. It disrupts the natural balance of day and night, interferes with ecosystems, and has negative impacts on human health. To address this issue, it is crucial to implement effective strategies to mitigate light pollution. In this section, we will explore various approaches and solutions that can be adopted to reduce the harmful effects of light pollution. 6.4.1 Outdoor lighting regulations. One of the most effective ways to mitigate light pollution is through the implementation of outdoor lighting regulations. These regulations aim to control the amount, direction, and intensity of artificial lighting used in outdoor spaces. By enforcing proper lighting practices, we can minimize unnecessary light spillage and glare, which are major contributors to light pollution. Municipalities and local governments can play a significant role in implementing and enforcing outdoor lighting regulations. These regulations can include requirements for shielding outdoor lights, using energy-efficient lighting fixtures, and limiting the use of excessive lighting. By adopting these measures, we can ensure that outdoor lighting is used responsibly and efficiently, reducing the overall impact of light pollution. 6.4.2 Dark sky preserves and lighting zones. Creating dark sky preserves and lighting zones is another effective strategy to mitigate light pollution. Dark sky preserves are designated areas where artificial lighting is strictly controlled to preserve the natural darkness of the night sky. These areas are typically located in remote or rural regions with minimal light pollution. By establishing dark sky preserves, we can protect and preserve the night sky, allowing people to experience the beauty of stars and other celestial objects without the interference of excessive artificial lighting. Similarly, lighting zones can be designated in urban areas to ensure that lighting is used appropriately and efficiently, minimizing light pollution while still meeting the needs of safety and security. 6.4.3 Use of proper lighting fixtures. Choosing the right lighting fixtures can significantly contribute to mitigating light pollution. By using fixtures that are designed to minimize light spillage and glare, we can reduce the amount of unnecessary light that escapes into the atmosphere. Shielded fixtures, for example, direct light downward and prevent it from dispersing in all directions, thus reducing light pollution. Additionally, using energy-efficient lighting technologies such as LED, light-emitting diode, can also help in reducing light pollution. LED lights consume less energy compared to traditional lighting sources, resulting in lower greenhouse gas emissions and less light pollution. By promoting the use of proper lighting fixtures and energy-efficient technologies, we can make significant progress in mitigating light pollution. 6.4.4 Public awareness and education. Raising public awareness about the impacts of light pollution is crucial in promoting its mitigation. Educating individuals, communities, and businesses about the importance of responsible lighting practices can lead to a collective effort in reducing light pollution. Public awareness campaigns, educational programs, and workshops can help people understand the negative consequences of excessive artificial lighting and encourage them to adopt more sustainable lighting practices. By fostering a sense of responsibility and understanding among the general public, we can create a culture that values the preservation of natural darkness and the reduction of light pollution. This can lead to increased support for outdoor lighting regulations, the use of proper lighting fixtures, and the establishment of dark sky preserves and lighting zones. 6.4.5 Collaboration and international cooperation. Mitigating light pollution requires collaboration and international cooperation. Since light pollution knows no boundaries, it is essential for countries and organizations to work together to address this issue on a global scale. Sharing best practices, exchanging knowledge, and implementing joint initiatives can help in developing effective strategies to reduce light pollution worldwide. International organizations such as the International Dark Sky Association (IDA) play a crucial role in promoting the preservation of dark skies and mitigating light pollution. The IDA works with governments, communities, and businesses to raise awareness, develop lighting guidelines, and advocate for responsible lighting practices. By fostering collaboration and international cooperation, we can create a unified approach to mitigating light pollution, ensuring the protection of our night skies for future generations. In conclusion, mitigating light pollution requires a combination of outdoor lighting regulations, the establishment of dark sky preserves and lighting zones, the use of proper lighting fixtures, public awareness and education, and collaboration on a global scale. By implementing these strategies, we can reduce the harmful effects of light pollution, preserve the beauty of the night sky, and create a more sustainable and environmentally friendly future. 7. Plastic pollution. 7.1 The problem with plastic. Plastic pollution has become one of the most pressing environmental issues of our time. The widespread use and improper disposal of plastic have led to a significant increase in plastic waste, causing severe damage to ecosystems and human health. In this section, we will explore the problem with plastic and its detrimental effects on the environment. 7.1.1 Plastic production and consumption. Plastic is a synthetic material derived from petroleum, and its production has skyrocketed over the past few decades. The convenience, durability, and versatility of plastic have made it a popular choice for packaging, construction, and various consumer products. However, the excessive production and consumption of plastic have resulted in a massive accumulation of plastic waste. 7.1.2 Plastic waste and marine pollution. One of the most alarming consequences of plastic pollution is its impact on marine ecosystems. Every year, millions of tons of plastic waste end up in the oceans, posing a significant threat to marine life. Marine animals often mistake plastic debris for food, leading to ingestion and entanglement. This not only causes suffering and death for countless marine species but also disrupts the delicate balance of marine ecosystems. 7.1.3 Microplastics and human health. Plastic pollution not only affects marine life but also poses risks to human health. As plastic breaks down into smaller fragments, known as microplastics, it enters the food chain and can be consumed by humans through seafood, drinking water, and even the air we breathe. The long-term health effects of microplastic ingestion are still not fully understood, but studies have shown potential links to various health issues, including hormonal disruptions, reproductive problems, and even cancer. 7.1.4 Land pollution and environmental impact. Plastic waste not only accumulates in our oceans but also pollutes our land and natural habitats. Improper disposal of plastic, such as littering or inadequate waste management, leads to the contamination of soil and water sources. This contamination can have detrimental effects on plant and animal life, disrupting ecosystems and biodiversity. Additionally, plastic waste takes hundreds of years to decompose, further exacerbating the problem and leaving a lasting impact on the environment. 7.1.5 Plastic recycling challenges. While recycling is often seen as a solution to plastic pollution, it comes with its own set of challenges. Many types of plastic are not easily recyclable, and the recycling infrastructure is often inadequate to handle the sheer volume of plastic waste generated. As a result, a significant portion of plastic waste ends up in landfills or incinerators, contributing to pollution and greenhouse gas emissions. 7.1.6 Single-use plastics and disposable culture. The prevalence of single-use plastics, such as plastic bags, bottles, and packaging, has contributed significantly to the plastic pollution crisis. These items are often used for a short period and then discarded, leading to a rapid accumulation of plastic waste. The disposable culture surrounding single-use plastics has created a cycle of overconsumption and waste generation that is difficult to break. 7.1.7 Lack of awareness and education. Another challenge in addressing plastic pollution is the lack of awareness and education among the general public. Many people are unaware of the environmental consequences of plastic waste and the importance of reducing plastic consumption. Education and awareness campaigns are crucial in promoting behavior change and encouraging individuals to adopt more sustainable alternatives. 7.1.8 Plastic industry and government responsibility. The plastic industry and government bodies also play a significant role in addressing plastic pollution. The industry must take responsibility for reducing plastic production, promoting sustainable alternatives, and investing in research and development of eco-friendly materials. Governments need to implement stricter regulations on plastic production, promote recycling and waste management initiatives, and support the transition to a circular economy. 7.1.9 Individual and collective actions. Addressing the problem of plastic pollution requires a collective effort from individuals, communities, industries, and governments. As individuals, we can reduce our plastic consumption by opting for reusable alternatives, such as cloth bags, stainless steel water bottles, and glass containers. Supporting local initiatives, participating in beach cleanups, and advocating for plastic reduction policies are also impactful ways to contribute to the solution. In conclusion, plastic pollution is a global crisis that demands immediate attention and action. The excessive production, consumption, and improper disposal of plastic have led to severe environmental consequences, including marine pollution, land contamination, and potential health risks. By understanding the problem with plastic and taking individual and collective actions, we can work towards a more sustainable and plastic-free future. 7.2 Impacts of plastic pollution. Plastic pollution has become a global environmental crisis, with devastating impacts on our ecosystems, wildlife, and human health. The excessive production and improper disposal of plastic waste have led to the accumulation of plastic debris in our oceans, rivers, and landfills. In this section, we will explore the various impacts of plastic pollution and the far-reaching consequences it has on our planet. 7.2.1 Marine life and ecosystems. Plastic pollution poses a significant threat to marine life and ecosystems. The ingestion of plastic by marine animals, such as turtles, seabirds, and marine mammals, is a common occurrence. Mistaking plastic debris for food, these animals often suffer from internal injuries, blockages, and malnutrition. The ingestion of microplastics, tiny plastic particles, can also lead to bioaccumulation and biomagnification, as these particles move up the food chain, affecting larger marine organisms and ultimately humans. Plastic debris also entangles marine animals, causing injuries, suffocation, and even death. Fishing nets, ropes, and plastic bags are particularly hazardous, as they can trap marine creatures, preventing them from swimming, feeding, or escaping predators. The loss of marine biodiversity due to plastic pollution disrupts delicate ecosystems, affecting the balance of marine food webs and the overall health of our oceans. 7.2.2 Terrestrial ecosystems. Plastic pollution not only affects marine ecosystems but also has detrimental impacts on terrestrial environments. Improper disposal of plastic waste leads to its accumulation in landfills, open spaces, and natural habitats. Plastic debris can persist in the environment for hundreds of years, releasing harmful chemicals and leaching toxins into the soil and groundwater. The presence of plastic in soil disrupts its natural composition and hinders the growth of plants. Plastic fragments can prevent water absorption, leading to waterlogging and soil erosion. In agricultural areas, plastic pollution can contaminate crops, affecting their quality and posing risks to human health. The accumulation of plastic waste in natural habitats also disrupts the habitats of terrestrial animals, affecting their behavior, reproduction, and overall survival. 7.2.3 Human health. Plastic pollution has direct and indirect impacts on human health. The consumption of seafood contaminated with plastic particles and toxic chemicals poses a risk to human health. These contaminants can accumulate in our bodies, potentially causing hormonal disruptions, reproductive issues, and an increased risk of certain diseases. Furthermore, the production and incineration of plastic contribute to air pollution, releasing harmful gases and particulate matter into the atmosphere. The inhalation of these pollutants can lead to respiratory problems, allergies, and even cancer. Additionally, the improper disposal of plastic waste in open spaces and water bodies can contaminate drinking water sources, jeopardizing the health of communities that rely on these water sources. 7.2.4 Economic impact. Plastic pollution also has significant economic consequences. The cleanup and management of plastic waste require substantial financial resources. Coastal communities heavily reliant on tourism and fisheries suffer from the negative impacts of plastic pollution, as polluted beaches and waters deter tourists and harm marine ecosystems, affecting fish populations and the livelihoods of fishermen. Plastic pollution also affects industries such as shipping and transportation. The entanglement of plastic debris in propellers and the fouling of ship hulls increase maintenance costs and fuel consumption. Moreover, the presence of plastic waste in water bodies can clog drainage systems, leading to flooding and costly infrastructure damage. 7.2.5 Environmental Aesthetics. Plastic pollution not only harms the environment and human health but also diminishes the natural beauty of our planet. Plastic debris litters our beaches, rivers, and landscapes, creating an eyesore and degrading the aesthetic value of our surroundings. The accumulation of plastic waste in natural areas, such as national parks and protected reserves, undermines their ecological integrity and compromises the enjoyment of these spaces for both locals and tourists. 7.2.6 Climate Change. Plastic pollution also contributes to climate change. The production of plastic requires the extraction and processing of fossil fuels, releasing greenhouse gas emissions into the atmosphere. Additionally, the incineration of plastic waste releases carbon dioxide and other harmful gases, further exacerbating the greenhouse effect. Furthermore, plastic debris in oceans and landfills acts as a heat-trapping material, increasing the temperature of these environments. This rise in temperature can have detrimental effects on marine and terrestrial ecosystems, disrupting the delicate balance of these systems and exacerbating the impacts of climate change. In conclusion, plastic pollution has far-reaching impacts on our environment, wildlife, human health, and economy. It is crucial that we take immediate action to reduce plastic consumption, improve waste management systems, and promote sustainable alternatives. By addressing the issue of plastic pollution, we can protect our ecosystems, preserve biodiversity, and ensure a healthier future for generations to come. 7.3 Plastic Waste Management. Plastic waste has become a significant environmental concern due to its widespread use and improper disposal. The accumulation of plastic waste in our oceans, landfills, and natural habitats has led to severe ecological and health consequences. To address this issue, effective plastic waste management strategies are crucial. In this section, we will explore various approaches to managing plastic waste and reducing its impact on the environment. 7.3.1 Collection and Sorting. The first step in plastic waste management is the collection and sorting of plastic materials. This process involves the separation of different types of plastics based on their composition and recyclability. Collection systems can vary from curbside recycling programs to designated drop-off points. It is essential to educate the public about the importance of proper plastic waste disposal and encourage their participation in recycling initiatives. Once collected, the plastic waste is sorted into different categories, such as PET polyethylene terephthalate, HDPE, high-density polyethylene, PVC, polyvinyl chloride, LDPE, low-density polyethylene, and PP polypropylene. Sorting allows for more efficient recycling and ensures that the plastic waste is appropriately processed. 7.3.2 Recycling. Recycling is a key component of plastic waste management. It involves the conversion of plastic waste into new products, reducing the need for virgin plastic production. The recycling process typically includes several steps, such as shredding, washing, melting, and reforming the plastic waste into pellets or flakes. Different types of plastics require specific recycling techniques due to variations in their chemical composition and properties. For example, PET bottles can be recycled into new bottles or polyester fibers used in clothing, while HDPE can be transformed into plastic lumber or drainage pipes. By recycling plastic waste, we can conserve resources, reduce energy consumption, and minimize the environmental impact associated with plastic production. 7.3.3 Extended Producer Responsibility (EPR). Extended Producer Responsibility (EPR) is a policy approach that holds manufacturers accountable for the entire life cycle of their products, including their disposal. EPR programs encourage manufacturers to take responsibility for the collection, recycling, and proper management of the plastic waste generated by their products. By implementing EPR policies, governments can incentivize manufacturers to design products that are more easily recyclable and promote the use of recycled materials in their production processes. EPR programs also help fund the collection and recycling infrastructure necessary for effective plastic waste management. By shifting the financial burden from local governments to producers, EPR encourages manufacturers to adopt more sustainable practices and reduce the environmental impact of their products. 7.3.4 Waste-to-energy conversion. In cases where plastic waste cannot be effectively recycled, waste-to-energy conversion can be a viable option. This process involves the conversion of plastic waste into energy through various methods such as incineration or pyrolysis. While waste-to-energy conversion can help reduce the volume of plastic waste in landfills and generate energy, it is crucial to ensure that these processes are carried out using advanced technologies that minimize air pollution and greenhouse gas emissions. It is important to note that waste-to-energy conversion should not be seen as a substitute for recycling. Recycling should always be prioritized as the preferred method of plastic waste management. Waste-to-energy conversion should only be considered for non-recyclable plastic waste as a last resort. 7.3.5 Plastic bans and regulations. To tackle the plastic waste crisis, many countries and municipalities have implemented plastic bans and regulations. These measures aim to reduce the consumption and production of single-use plastics, which are a major contributor to plastic pollution. Plastic bans often target items such as plastic bags, straws, cutlery, and foam packaging. By implementing plastic bans and regulations, governments can encourage the use of more sustainable alternatives and promote a shift towards a circular economy. These measures also raise awareness about the environmental impact of plastic waste and encourage individuals and businesses to adopt more eco-friendly practices. 7.3.6 Public awareness and education. Public awareness and education play a crucial role in plastic waste management. By educating individuals about the environmental consequences of plastic pollution and the importance of proper waste disposal, we can encourage responsible behavior and promote sustainable practices. Public awareness campaigns can highlight the benefits of recycling, the importance of reducing plastic consumption, and the need for proper waste management infrastructure. Educational programs in schools and communities can teach individuals about the different types of plastics, their recyclability, and the impact of plastic waste on ecosystems and human health. 7.3.7 Collaboration and international cooperation. Plastic waste management is a global issue that requires collaboration and international cooperation. Governments, businesses, non-governmental organizations, and individuals must work together to develop innovative solutions and share best practices. International agreements and initiatives, such as the Basel Convention and the Global Plastic Action Partnership, aim to address plastic pollution on a global scale. These platforms facilitate knowledge exchange, promote research and development, and encourage countries to adopt sustainable plastic waste management practices. By fostering collaboration and international cooperation, we can develop comprehensive strategies to tackle plastic waste and protect our environment for future generations. Conclusion. Plastic waste management is a complex challenge that requires a multifaceted approach. By implementing effective collection and sorting systems, promoting recycling, adopting extended producer responsibility policies, exploring waste-to-energy conversion options, implementing plastic bans and regulations, raising public awareness, and fostering international cooperation, we can mitigate the environmental impact of plastic pollution. It is crucial for individuals, communities, governments, and industries to take collective action and work towards a more sustainable and plastic-free future. 7.4 Alternatives to plastic. Plastic pollution has become a significant environmental concern, with its detrimental effects on ecosystems and human health. As we strive to reduce our reliance on plastic, it is essential to explore alternative materials and solutions that can help mitigate the problem. In this section, we will discuss various alternatives to plastic and their potential benefits. 7.4.1 Biodegradable and compostable materials. One of the most promising alternatives to traditional plastic is the use of biodegradable and compostable materials. These materials are designed to break down naturally over time, reducing their impact on the environment. Biodegradable plastics, for example, are made from renewable resources such as cornstarch or vegetable oils and can decompose into natural elements like water and carbon dioxide. Compostable materials, on the other hand, can be broken down through industrial composting processes, resulting in nutrient-rich compost. The use of biodegradable and compostable materials offers several advantages. Firstly, they reduce the accumulation of plastic waste in landfills and oceans, as they break down more quickly. Secondly, they have a lower carbon footprint compared to traditional plastics, as they are often derived from renewable resources. Lastly, these materials can help promote a circular economy by being recycled or composted, thus reducing the need for virgin materials. 7.4.2 Paper and cardboard. Paper and cardboard are widely available and renewable resources that can serve as alternatives to plastic in various applications. They have been used for packaging, disposable cups, and food containers for many years. Paper and cardboard products are biodegradable and can be recycled multiple times, making them more environmentally friendly than plastic. However, it is important to note that the production of paper and cardboard also has its environmental impacts, such as deforestation and water consumption. To mitigate these issues, it is crucial to promote sustainable forestry practices and increase the use of recycled paper and cardboard. 7.4.3 Glass. Glass is another viable alternative to plastic, especially for packaging and containers. It is made from abundant raw materials like sand and can be recycled indefinitely without losing its quality. Glass containers are non-toxic, impermeable, and do not leach harmful chemicals into the products they hold. Additionally, glass has excellent heat resistance, making it suitable for hot beverages and food items. While glass offers many advantages, it also has some drawbacks. Glass is heavier and more fragile than plastic, making it less suitable for certain applications. Moreover, the production of glass requires high energy consumption, which contributes to greenhouse gas emissions. However, the recyclability and durability of glass make it a sustainable alternative to plastic in many cases. 7.4.4 Metal. Metal, particularly aluminum and steel, can be used as alternatives to plastic in various forms. Aluminum cans, for instance, are widely used for packaging beverages and can be recycled repeatedly without losing their quality. Steel is commonly used for food containers and can also be recycled efficiently. Metal containers offer several advantages over plastic. They are durable, resistant to temperature changes, and have a long lifespan. Additionally, metal recycling requires significantly less energy compared to the production of virgin metal, making it an environmentally friendly option. However, metal containers can be heavier and more expensive than plastic, which may limit their use in certain applications. Furthermore, the mining and extraction of metals have their environmental impacts, such as habitat destruction and water pollution. Therefore, it is crucial to promote responsible mining practices and increase the use of recycled metals. 7.4.5 Natural fibers. Natural fibers, such as cotton, hemp, jute, and bamboo, offer sustainable alternatives to plastic in various applications. These fibers can be used to make bags, clothing, packaging materials, and even biodegradable cutlery. Natural fiber products are renewable, biodegradable, and have a lower environmental impact compared to plastic. Using natural fibers helps reduce the reliance on synthetic materials derived from fossil fuels. Additionally, these fibers can be grown without the use of harmful pesticides and chemicals, making them safer for both the environment and human health. However, it is important to consider the environmental impact of growing and processing natural fibers. For example, cotton production requires significant amounts of water and pesticides, which can have adverse effects on ecosystems. Therefore, it is crucial to promote sustainable farming practices and increase the use of organic and responsibly sourced natural fibers. 7.4.6 Innovative materials. In addition to the traditional alternatives mentioned above, researchers and innovators are continuously developing new materials to replace plastic. These innovative materials include bio-based polymers, algae-based plastics, and even edible packaging. Bio-based polymers are derived from renewable resources such as corn, sugarcane, or algae. They have similar properties to traditional plastics but have a lower environmental impact. Algae-based plastics, on the other hand, are made from algae biomass and have the potential to be more sustainable and biodegradable. Edible packaging is a unique solution that aims to eliminate packaging waste altogether. It involves creating packaging materials from edible substances such as seaweed or starch, which can be consumed along with the food or easily biodegraded. While these innovative materials show promise, further research and development are needed to ensure their scalability, cost-effectiveness, and environmental benefits. Conclusion. Reducing our reliance on plastic is crucial for mitigating the environmental impacts of pollution. By exploring and adopting alternatives to plastic, such as biodegradable and compostable materials, paper and cardboard, glass, metal, natural fibers, and innovative materials, we can make significant progress towards a more sustainable future. It is essential for individuals, businesses, and governments to work together to promote and implement these alternatives, ultimately reducing plastic pollution and preserving our planet for future generations. 8. Industrial pollution. 8.1 Industrial activities and pollution. Industrial activities play a significant role in the global economy, providing goods and services that are essential for our daily lives. However, these activities also contribute to pollution on a large scale. Industrial pollution refers to the contamination of the environment by harmful substances released during various industrial processes. This section will explore the relationship between industrial activities and pollution, highlighting the major sources and impacts of industrial pollution. 8.1.1 Sources of industrial pollution. Industrial pollution arises from a wide range of activities across different sectors, including manufacturing, mining, energy production, and chemical processing. These activities release various pollutants into the air, water, and soil, causing significant harm to the environment and human health. Air pollution. Industrial processes emit a significant amount of pollutants into the atmosphere. Combustion of fossil fuels, such as coal, oil, and natural gas, in power plants and industrial boilers releases large quantities of greenhouse gases, sulfur dioxide, nitrogen oxides, and particulate matter. These pollutants contribute to air pollution and are responsible for the formation of smog, acid rain, and the deterioration of air quality in many regions. Water pollution. Industrial activities generate wastewater that contains a wide range of pollutants, including heavy metals, organic compounds, and toxic chemicals. Improper disposal of industrial wastewater directly into water bodies or inadequate treatment before discharge can lead to water pollution. This pollution not only affects aquatic ecosystems but also poses a threat to human health when contaminated water is used for drinking, irrigation, or recreational purposes. Soil pollution. Industrial processes can contaminate soil through the release of hazardous substances, such as heavy metals, pesticides, solvents, and petroleum products. Accidental spills, improper waste disposal, and leakage from storage tanks are common sources of soil pollution. Contaminated soil can have detrimental effects on plant growth, soil fertility, and the overall health of ecosystems. 8.1.2 Impacts of industrial pollution. The impacts of industrial pollution are far-reaching and can have severe consequences for both the environment and human well-being. Some of the key impacts include: environmental impacts. Industrial pollution poses a significant threat to biodiversity and ecosystem health. The release of pollutants into the air, water, and soil can lead to the destruction of habitats, the decline of plant and animal species, and the disruption of ecological processes. Pollutants can accumulate in the food chain, leading to bioaccumulation and biomagnification, which can have long-term effects on the entire ecosystem. Human health impacts. Exposure to industrial pollutants can have detrimental effects on human health. Air pollution from industrial emissions is linked to respiratory diseases, cardiovascular problems, and increased mortality rates. Water pollution can lead to waterborne diseases, such as cholera and dysentery, as well as long-term health issues due to the ingestion of toxic substances. Soil pollution can contaminate crops and food, posing risks to human health through the consumption of contaminated produce. Economic impacts. Industrial pollution can also have significant economic consequences. The degradation of natural resources, such as air, water, and soil, can result in reduced agricultural productivity, increased healthcare costs, and damage to infrastructure. Additionally, pollution incidents can lead to legal liabilities, fines, and reputational damage for industries, affecting their profitability and sustainability. 8.1.3 Regulations and Control Measures. To address the issue of industrial pollution, governments and international organizations have implemented regulations and control measures to mitigate the environmental and health impacts. These measures aim to reduce pollutant emissions, promote cleaner production practices, and ensure the proper management of industrial waste. Environmental regulations. Many countries have established environmental regulations that set emission limits for industrial pollutants. These regulations often require industries to install pollution control technologies, such as scrubbers, filters, and catalytic converters, to reduce emissions. Governments also enforce monitoring and reporting requirements to ensure compliance with these regulations. Waste management. Proper waste management is crucial in preventing industrial pollution. Governments and regulatory bodies enforce regulations on the handling, storage, and disposal of industrial waste. Industries are required to implement waste management practices, such as recycling, treatment, and safe disposal, to minimize the release of hazardous substances into the environment. Environmental impact assessments. Before initiating new industrial projects or expanding existing ones, environmental impact assessments (EIAs) are often required. EIAs evaluate the potential environmental impacts of proposed activities and help identify measures to mitigate these impacts. This process ensures that industrial projects are designed and operated in an environmentally responsible manner. 8.1.4 Promoting sustainable industries. Transitioning towards sustainable industrial practices is essential for reducing pollution and minimizing the environmental footprint of industrial activities. Several strategies can be employed to promote sustainability in industries. Cleaner production. Cleaner production focuses on minimizing waste generation, reducing resource consumption, and adopting cleaner technologies and processes. By implementing cleaner production practices, industries can reduce their environmental impact while improving efficiency and cost-effectiveness. Renewable energy adoption. Shifting towards renewable energy sources, such as solar, wind, and hydropower, can help reduce the reliance on fossil fuels and decrease greenhouse gas emissions from industrial activities. Governments and organizations can provide incentives and support for industries to adopt renewable energy technologies. Circular economy. The concept of a circular economy promotes the reuse, recycling, and repurposing of materials and products. By closing the loop and minimizing waste generation, industries can reduce their environmental impact and conserve resources. Corporate social responsibility. Industries can take responsibility for their environmental impact by implementing corporate social responsibility (CSR) initiatives. This includes investing in sustainable practices, supporting environmental conservation projects, and engaging in transparent reporting of their environmental performance. In conclusion, industrial activities are significant contributors to pollution, releasing harmful substances into the air, water, and soil. The impacts of industrial pollution are wide-ranging, affecting ecosystems, human health, and the economy. However, through the implementation of regulations, waste management practices, and sustainable strategies, industries can reduce their pollution footprint and promote a cleaner and more sustainable future. 8.2 Effects of industrial pollution. Industrial pollution refers to the contamination of the environment by various harmful substances released during industrial activities. These activities can have significant negative impacts on the environment, human health, and the overall well-being of ecosystems. In this section, we will explore the effects of industrial pollution and the consequences it has on our planet. 8.2.1 Air pollution. One of the most significant effects of industrial pollution is air pollution. Industrial processes release a wide range of pollutants into the atmosphere, including sulfur dioxide, nitrogen oxides, carbon monoxide, volatile organic compounds (VOCs), and particulate matter. These pollutants contribute to the formation of smog, acid rain, and the depletion of the ozone layer. The release of sulfur dioxide and nitrogen oxides from industrial activities leads to the formation of acid rain. Acid rain has detrimental effects on forests, lakes, and aquatic ecosystems. It damages plant life, reduces soil fertility, and contaminates water bodies, making them uninhabitable for many species. Particulate matter, such as soot and dust, released from industrial sources can cause respiratory problems and other health issues in humans. These tiny particles can penetrate deep into the lungs, leading to respiratory infections, asthma, and even lung cancer. Additionally, industrial emissions contribute to the formation of smog, which can cause respiratory and cardiovascular problems, especially in densely populated areas. 8.2.2 Water pollution. Industrial pollution also has severe consequences for water bodies. Industrial activities often release toxic chemicals, heavy metals, and other pollutants into rivers, lakes, and oceans. These pollutants can contaminate water sources, making them unsafe for human consumption and harmful to aquatic life. Chemicals such as mercury, lead, arsenic, and cadmium, which are commonly found in industrial waste, can accumulate in the tissues of aquatic organisms. This bioaccumulation can lead to the disruption of ecosystems and the poisoning of fish and other marine life. Consuming contaminated fish can have detrimental effects on human health, causing neurological disorders, organ damage, and developmental issues, especially in children. Industrial pollution also contributes to the eutrophication of water bodies. Excessive nutrient runoff from industrial activities, such as nitrogen and phosphorus, can lead to the overgrowth of algae and other aquatic plants. This overgrowth depletes oxygen levels in the water, creating dead zones where marine life cannot survive. 8.2.3 Soil pollution. Industrial pollution can contaminate soil through the release of hazardous chemicals, heavy metals, and other pollutants. These pollutants can have long-lasting effects on soil fertility, agricultural productivity, and the health of ecosystems. Heavy metals, such as lead, cadmium, and chromium, released from industrial activities can accumulate in the soil over time. These metals can be taken up by plants and enter the food chain, posing a risk to human health. Additionally, contaminated soil can affect the growth and development of plants, leading to reduced crop yields and decreased agricultural productivity. Chemicals used in industrial processes, such as pesticides, herbicides, and solvents, can also contaminate soil. These chemicals can leach into groundwater, polluting water sources and posing a risk to human health. Moreover, they can persist in the environment for extended periods, causing long-term damage to ecosystems. 8.2.4 Biodiversity loss. Industrial pollution has a significant impact on biodiversity. The release of pollutants into the environment can disrupt ecosystems, leading to the loss of plant and animal species. Pollution can degrade habitats, destroy breeding grounds, and contaminate food sources, making it difficult for many species to survive. Chemical pollutants can have direct toxic effects on organisms, leading to illness, reproductive problems, and death. Additionally, pollution can alter the balance of ecosystems, favoring certain species over others and disrupting the natural interactions between organisms. The loss of biodiversity has far-reaching consequences for the stability and resilience of ecosystems. It can disrupt nutrient cycles, reduce ecosystem productivity, and make ecosystems more vulnerable to invasive species and diseases. The loss of keystone species, which play critical roles in maintaining ecosystem balance, can have cascading effects on the entire ecosystem. 8.2.5 Climate change. Industrial pollution is a significant contributor to climate change. The release of greenhouse gases, such as carbon dioxide, methane, and nitrous oxide, from industrial activities contributes to the warming of the planet and the disruption of global climate patterns. The burning of fossil fuels in industrial processes releases large amounts of carbon dioxide into the atmosphere. This greenhouse gas traps heat in the Earth's atmosphere, leading to global warming and climate change. The increased temperatures have far-reaching effects, including the melting of polar ice caps, rising sea levels, extreme weather events, and shifts in precipitation patterns. Climate change caused by industrial pollution poses significant risks to human health, agriculture, and natural ecosystems. It can lead to the spread of infectious diseases, crop failures, water scarcity, and the loss of habitats for many species. The impacts of climate change are already being felt worldwide and require urgent action to mitigate further damage. In conclusion, industrial pollution has wide-ranging and severe effects on the environment, human health, and ecosystems. It contributes to air pollution, water pollution, soil pollution, biodiversity loss, and climate change. Addressing industrial pollution requires the implementation of strict regulations, the adoption of cleaner technologies, and the promotion of sustainable practices. It is crucial for industries to take responsibility for their pollution and work towards minimizing their environmental footprint for the well-being of present and future generations. 8.3 Regulations and control measures. Regulations and control measures play a crucial role in addressing industrial pollution and holding gross polluters accountable for their actions. These measures are essential for protecting the environment, human health, and promoting sustainable industrial practices. In this section, we will explore the various regulations and control measures that are in place to mitigate industrial pollution. 8.3.1 Environmental regulations. Environmental regulations are laws and guidelines established by governments to regulate industrial activities and minimize their negative impact on the environment. These regulations set standards for emissions, waste disposal, and resource usage, among other things. They aim to ensure that industries operate in an environmentally responsible manner. One of the primary tools used in environmental regulations is the issuance of permits. Industries must obtain permits that outline the specific conditions and limits they must adhere to in order to operate legally. These permits often include requirements for monitoring and reporting emissions, implementing pollution control technologies, and managing waste. 8.3.2 Emission Standards. Emission standards are regulations that set limits on the amount of pollutants that industries can release into the air, water, or soil. These standards are based on scientific research and aim to protect human health and the environment from harmful pollutants. They vary depending on the type of industry and the specific pollutants involved. For air pollution, emission standards typically focus on pollutants such as sulfur dioxide, nitrogen oxides, particulate matter, and volatile organic compounds. Industries are required to install pollution control devices, such as scrubbers and filters, to reduce emissions to acceptable levels. Regular monitoring and reporting of emissions are also mandated to ensure compliance. Similarly, water pollution control measures include limits on the discharge of pollutants into water bodies. Industries must treat their wastewater before releasing it to meet the specified standards. This may involve the use of treatment systems, such as sedimentation tanks, biological filters, and chemical processes, to remove contaminants. 8.3.3 Waste Management Regulations. Waste management regulations are designed to ensure proper handling, storage, transportation, and disposal of industrial waste. These regulations aim to prevent the release of hazardous substances into the environment and promote the use of environmentally friendly waste management practices. Industries are required to classify their waste according to its characteristics and potential harm. Hazardous waste, such as chemicals and heavy metals, must be treated and disposed of in specialized facilities. Non-hazardous waste should be managed through recycling, reuse, or safe disposal methods. To enforce waste management regulations, governments often establish waste management authorities or agencies. These entities oversee the implementation of waste management practices, conduct inspections, and enforce penalties for non-compliance. 8.3.4 Monitoring and Enforcement. Monitoring and enforcement are crucial aspects of regulating industrial pollution. Governments and regulatory bodies employ various methods to ensure that industries comply with environmental regulations. Regular inspections are conducted to assess the compliance of industries with emission standards, waste management practices, and other regulatory requirements. These inspections may be scheduled or unannounced, and they involve assessing records, conducting site visits, and collecting samples for analysis. In addition to inspections, industries are often required to install monitoring systems to track their emissions, waste generation, and other environmental parameters. This data is then reported to the regulatory authorities on a regular basis. Non-compliance can result in fines, penalties, or even the suspension of operations. 8.3.5 Collaboration and International Agreements. Industrial pollution is a global issue that requires collaboration and cooperation among nations. International agreements and collaborations play a significant role in addressing pollution caused by multinational industries and promoting sustainable practices worldwide. Agreements such as the Paris Agreement and the Basel Convention provide a framework for countries to work together to reduce greenhouse gas emissions and regulate the transboundary movement of hazardous waste, respectively. These agreements facilitate the exchange of knowledge, technology, and best practices among nations. Furthermore, international organizations like the United Nations Environment Programme (UNEP) and the World Health Organization (WHO) work towards promoting sustainable industrial practices and providing guidance on pollution control measures. They support countries in developing and implementing effective regulations and control measures. In conclusion, regulations and control measures are essential for mitigating industrial pollution and holding gross polluters accountable. Environmental regulations, emission standards, waste management regulations, monitoring and enforcement, and international collaborations all contribute to creating a cleaner and more sustainable industrial sector. By implementing and enforcing these measures, we can protect the environment, safeguard human health, and promote a greener future. 8.4 Promoting Sustainable Industries. Sustainable industries play a crucial role in mitigating pollution and minimizing the negative impact on the environment. As we have discussed in previous chapters, industrial pollution is a significant contributor to various forms of pollution, including air, water, soil, and waste pollution. However, it is important to note that not all industries are equally responsible for pollution. Some industries are considered gross polluters due to their high levels of emissions and waste generation. In this section, we will explore the concept of promoting sustainable industries and the steps that can be taken to encourage environmentally friendly practices. 8.4.1 Understanding gross polluters. Before we delve into promoting sustainable industries, it is essential to understand the concept of gross polluters. Gross polluters are industries that significantly contribute to pollution due to their large-scale operations, high energy consumption, and inefficient waste management practices. These industries often release substantial amounts of pollutants into the air, water, and soil, leading to severe environmental degradation. Gross polluters can be found in various sectors, including manufacturing, energy production, mining, and chemical production. These industries typically emit large quantities of greenhouse gases, toxic chemicals, and hazardous waste, posing a significant threat to human health and the ecosystem. 8.4.2 The importance of promoting sustainable industries. Promoting sustainable industries is crucial for several reasons. Firstly, sustainable industries prioritize environmental protection and adopt practices that minimize pollution and resource depletion. By encouraging sustainable practices, we can reduce the negative impact of industrial activities on the environment and human health. Secondly, promoting sustainable industries can drive innovation and technological advancements. By investing in research and development, sustainable industries can develop cleaner and more efficient production processes, leading to reduced emissions and waste generation. This not only benefits the environment but also creates opportunities for economic growth and job creation. Lastly, promoting sustainable industries aligns with the global commitment to sustainable development and the achievement of the United Nations Sustainable Development Goals (SDGs). By transitioning towards sustainable practices, industries can contribute to goals such as climate action, responsible consumption and production, and the protection of ecosystems and biodiversity. 8.4.3 Strategies for promoting sustainable industries. To promote sustainable industries effectively, a multifaceted approach is required. Here are some strategies that can be implemented. 8.4.3.1 Government incentives and regulations. Governments play a crucial role in promoting sustainable industries through the implementation of incentives and regulations. By providing financial incentives, such as tax breaks or grants, governments can encourage industries to adopt sustainable practices. Additionally, strict regulations can be put in place to limit emissions, waste generation, and the use of harmful substances. These regulations can include mandatory environmental impact assessments, emission standards, and waste management guidelines. 8.4.3.2 Collaboration and partnerships. Collaboration between governments, industries, and environmental organizations is essential for promoting sustainable industries. By working together, stakeholders can share knowledge, resources, and best practices. Partnerships can be formed to develop and implement sustainable technologies, promote sustainable supply chains, and support research and development initiatives. 8.4.3.3 Research and development. Investing in research and development is crucial for promoting sustainable industries. By supporting research initiatives, governments and industries can drive innovation and develop cleaner and more efficient technologies. Research can focus on areas such as renewable energy, waste management, pollution prevention, and sustainable production processes. 8.4.3.4 Education and awareness. Raising awareness and educating the public about the importance of sustainable industries is vital. By promoting environmental education in schools, universities, and communities, individuals can understand the impact of their consumption choices and support sustainable businesses. Additionally, awareness campaigns can be conducted to inform consumers about environmentally friendly products and services, encouraging them to make sustainable choices. 8.4.3.5 Financial support and investment. Financial support and investment in sustainable industries are crucial for their growth and development. Governments and financial institutions can provide funding and loans to support the transition towards sustainable practices. Additionally, investors can prioritize sustainable businesses and divest from industries that are not committed to environmental protection. 8.4.4 Success stories in promoting sustainable industries. Several success stories demonstrate the positive impact of promoting sustainable industries. For example, the renewable energy sector has experienced significant growth in recent years, driven by government incentives and public demand for clean energy. This growth has led to a reduction in greenhouse gas emissions and a shift towards a more sustainable energy system. Another success story is the adoption of sustainable manufacturing practices by various industries. By implementing energy-efficient technologies, waste reduction strategies, and sustainable supply chain management, companies have been able to reduce their environmental footprint while maintaining profitability. 8.4.5 Conclusion. Promoting sustainable industries is crucial for addressing the issue of industrial pollution and achieving a more sustainable future. By implementing strategies such as government incentives, collaboration, research and development, education, and financial support, we can encourage industries to adopt sustainable practices. Through these efforts, we can reduce pollution, protect the environment, and create a healthier and more sustainable world for future generations. 9. Agricultural pollution. 9.1 Pesticides and fertilizers. Pesticides and fertilizers play a significant role in modern agriculture, helping to increase crop yields and protect plants from pests and diseases. However, the excessive and improper use of these chemicals has led to a range of environmental and health issues, making them significant contributors to agricultural pollution. In this section, we will explore the impact of pesticides and fertilizers on the environment and discuss the need for sustainable farming practices. 9.1.1 Pesticides. Pesticides are chemical substances used to control or eliminate pests that can damage crops and reduce agricultural productivity. They include insecticides, herbicides, fungicides, and rodenticides. While pesticides have undoubtedly played a crucial role in increasing food production, their widespread use has raised concerns about their adverse effects on the environment and human health. Environmental impact. One of the primary environmental concerns associated with pesticides is their potential to contaminate water bodies. When pesticides are applied to fields, they can be washed off by rainwater or irrigation and enter nearby streams, rivers, and groundwater. This contamination can have detrimental effects on aquatic ecosystems, leading to the death of fish and other aquatic organisms. Pesticides can also persist in the environment for extended periods, accumulating in soil and water, and potentially entering the food chain. Furthermore, pesticides can harm non-target organisms, including beneficial insects, birds, and mammals. For example, insecticides designed to kill specific pests can also harm pollinators like bees and butterflies, which are essential for the reproduction of many plant species. The loss of pollinators can have far-reaching consequences for both agricultural and natural ecosystems. Human health concerns. Pesticides can pose significant risks to human health, particularly for those who work directly with these chemicals or live in close proximity to agricultural fields. Exposure to pesticides can occur through inhalation, ingestion of contaminated food and water, or direct contact with the skin. Long-term exposure to certain pesticides has been linked to various health issues, including respiratory problems, neurological disorders, reproductive disorders, and even cancer. Children are particularly vulnerable to the harmful effects of pesticides due to their developing immune systems and higher exposure levels relative to their body weight. Studies have shown that children living in agricultural areas with intensive pesticide use may experience developmental delays, cognitive impairments, and increased risk of certain childhood cancers. 9.1.2 Fertilizers. Fertilizers are substances added to soil or plants to provide essential nutrients that promote plant growth and increase crop yields. They typically contain nitrogen, phosphorus, and potassium, along with other micronutrients. While fertilizers have played a crucial role in addressing global food demand, their excessive and improper use can have detrimental effects on the environment and human health. Environmental impact. One of the significant environmental concerns associated with fertilizers is nutrient runoff. When fertilizers are applied in excessive amounts or at inappropriate times, rainwater or irrigation can wash away the excess nutrients from fields into nearby water bodies. This nutrient runoff can lead to eutrophication, a process in which excessive nutrients cause algal blooms, deplete oxygen levels in water, and harm aquatic life. Eutrophication can result in the death of fish, the loss of biodiversity, and the degradation of water quality. Moreover, the production and use of synthetic fertilizers contribute to greenhouse gas emissions. The manufacturing process of nitrogen-based fertilizers, in particular, releases nitrous oxide, a potent greenhouse gas that contributes to climate change. Additionally, the excessive use of fertilizers can lead to soil acidification, reducing soil fertility and negatively impacting plant growth. Human health concerns. The excessive use of fertilizers can have indirect effects on human health through the contamination of water sources. When nutrients from fertilizers enter drinking water supplies, they can pose health risks. High levels of nitrates in drinking water, for example, can cause methemoglobinemia, also known as blue baby syndrome, which affects the ability of blood to carry oxygen. Furthermore, the use of certain fertilizers can result in the accumulation of heavy metals in the soil, which can be taken up by plants and enter the food chain. Consuming crops contaminated with heavy metals can have adverse health effects, including kidney damage, neurological disorders, and even cancer. 9.1.3 Sustainable farming practices. To address the environmental and health concerns associated with pesticides and fertilizers, it is essential to adopt sustainable farming practices that minimize their use and promote ecological balance. Here are some strategies that can help mitigate the negative impacts of pesticides and fertilizers. Integrated Pest Management (IPM). Integrated pest management is an approach that focuses on preventing pest problems through a combination of techniques, including biological control, crop rotation, habitat manipulation, and the judicious use of pesticides as a last resort. By using IPM, farmers can reduce their reliance on chemical pesticides and promote natural pest control mechanisms. Organic farming. Organic farming avoids the use of synthetic pesticides and fertilizers, relying instead on natural methods to manage pests and enhance soil fertility. Organic farmers use techniques such as crop rotation, composting, and the use of beneficial insects to control pests. Organic farming practices help protect the environment, promote biodiversity, and produce food that is free from pesticide residues. Precision agriculture. Precision agriculture involves the use of technology, such as GPS and remote sensing, to optimize the application of pesticides and fertilizers. By precisely targeting areas that require treatment, farmers can minimize chemical inputs, reduce environmental contamination, and improve resource efficiency. Nutrient management. Implementing proper nutrient management practices can help reduce the excessive use of fertilizers and minimize nutrient runoff. This includes soil testing to determine nutrient requirements, using slow-release fertilizers, and adopting practices such as cover cropping and conservation tillage to improve nutrient retention in the soil. In conclusion, pesticides and fertilizers are essential tools in modern agriculture, but their excessive and improper use can lead to significant environmental and health problems. By adopting sustainable farming practices, such as integrated pest management, organic farming, precision agriculture, and proper nutrient management, we can minimize the negative impacts of pesticides and fertilizers while ensuring food security and protecting the environment for future generations. 9.2 Water contamination from agriculture. Agriculture plays a vital role in providing food and sustaining economies around the world. However, it is also a significant contributor to water pollution. The use of pesticides, fertilizers, and other agricultural practices can lead to the contamination of water sources, posing serious threats to both human health and the environment. 9.2.1 Pesticides and herbicides. Pesticides and herbicides are commonly used in agriculture to protect crops from pests and weeds. While these chemicals can be effective in increasing crop yields, they can also have detrimental effects on water quality. When pesticides are applied to fields, they can be washed away by rainwater or irrigation, entering nearby water bodies such as rivers, lakes, and groundwater. Once in the water, pesticides can persist for long periods and have the potential to contaminate drinking water sources. These chemicals can be toxic to aquatic organisms, disrupting their reproductive systems, and causing harm to fish and other wildlife. Additionally, some pesticides have been linked to adverse health effects in humans, including developmental issues, hormonal imbalances, and even cancer. To mitigate water contamination from pesticides, farmers can adopt alternative pest management strategies such as integrated pest management (IPM). IPM focuses on using a combination of techniques, including biological controls, crop rotation, and the targeted use of pesticides, to minimize their overall use. By implementing IPM practices, farmers can reduce the amount of pesticides entering water sources while still effectively protecting their crops. 9.2.2 Nutrient runoff. Another significant source of water contamination from agriculture is nutrient runoff. Farmers often use fertilizers to provide essential nutrients to their crops, such as nitrogen and phosphorus. However, excessive use or improper application of fertilizers can result in runoff, where these nutrients are carried away by rainwater or irrigation water and end up in nearby water bodies. When nutrients enter water sources, they can cause a process called eutrophication. Eutrophication occurs when there is an excess of nutrients in the water, leading to the rapid growth of algae and other aquatic plants. As these plants die and decompose, they consume oxygen, creating oxygen-depleted zones in the water known as dead zones. This lack of oxygen can suffocate fish and other aquatic organisms, leading to significant ecological imbalances. To prevent nutrient runoff and subsequent water contamination, farmers can adopt best management practices (BMPs) for fertilizer application. These practices include using soil testing to determine the appropriate amount of fertilizer needed, applying fertilizers at the right time and in the right manner, and implementing conservation practices such as cover cropping and buffer strips to reduce runoff. 9.2.3 Livestock farming. Livestock farming, including dairy and meat production, also contributes to water contamination. The waste generated by livestock, such as manure and urine, contains high levels of nutrients and pathogens. When not properly managed, this waste can leach into the soil and contaminate groundwater or be washed into nearby water bodies during rainfall events. The presence of excess nutrients from livestock waste in water sources can lead to similar issues as nutrient runoff from fertilizers. Additionally, the pathogens present in livestock waste can pose a significant risk to human health if they contaminate drinking water sources. Diseases such as E. coli, salmonella, and cryptosporidium can be transmitted through contaminated water, causing gastrointestinal illnesses and other health problems. To minimize water contamination from livestock farming, proper waste management practices are crucial. This includes the proper storage and disposal of manure, the use of manure management systems such as anaerobic digesters or composting, and the implementation of buffer zones to prevent runoff from reaching water bodies. Additionally, regular monitoring of water quality near livestock operations is essential to ensure early detection of any contamination issues. 9.2.4 Irrigation practices. Irrigation is a common practice in agriculture to provide water to crops in areas with limited rainfall. However, inefficient irrigation practices can contribute to water contamination. When excessive amounts of water are applied to fields, it can result in the leaching of fertilizers and pesticides into groundwater or runoff into nearby water bodies. To minimize water contamination from irrigation, farmers can adopt more efficient irrigation techniques such as drip irrigation or precision sprinklers. These methods deliver water directly to the plant roots, reducing the amount of water needed and minimizing runoff. Additionally, the use of soil moisture sensors and weather data can help farmers optimize irrigation schedules, ensuring that water is applied only when necessary. Conclusion. Water contamination from agriculture is a significant environmental and public health concern. Pesticides, herbicides, nutrient runoff, livestock waste, and inefficient irrigation practices all contribute to the pollution of water sources. To address this issue, it is essential for farmers to adopt sustainable agricultural practices that minimize the use of harmful chemicals, manage waste properly, and optimize water usage. Additionally, government regulations and support for sustainable farming practices can play a crucial role in reducing water contamination from agriculture and protecting our precious water resources. 9.3 Soil degradation and erosion. Soil degradation and erosion are significant issues that contribute to environmental pollution and pose a threat to agricultural productivity and food security. The degradation of soil quality and the erosion of topsoil can have severe consequences for ecosystems, water quality, and human health. In this section, we will explore the causes and impacts of soil degradation and erosion, as well as discuss sustainable farming practices that can help mitigate these problems. 9.3.1 Causes of soil degradation. Soil degradation can occur due to various factors, both natural and human-induced. Some of the primary causes of soil degradation include deforestation. Clearing forests for agriculture or other purposes exposes the soil to erosion, as the protective vegetation cover is removed. Overgrazing. When livestock graze excessively on vegetation, it can lead to the destruction of plant cover, soil compaction, and erosion. Improper agricultural practices. Unsustainable farming methods such as excessive tilling, monocropping, and the use of chemical fertilizers and pesticides can degrade soil quality over time. Soil compaction. Heavy machinery and equipment used in agriculture and construction can compact the soil, reducing its ability to absorb water and nutrients. Mining activities. Mining operations can disrupt the soil structure, leading to erosion and the release of harmful substances into the environment. Urbanization. The expansion of cities and infrastructure leads to the loss of fertile soil, as it is covered with concrete and buildings. 9.3.2 Impacts of soil degradation and erosion. Soil degradation and erosion have far-reaching impacts on the environment, agriculture, and human well-being. Some of the key consequences include reduced agricultural productivity. Degraded soil is less fertile and has a diminished capacity to support plant growth. This can lead to lower crop yields and decreased food production. Water pollution. Eroded soil particles can enter water bodies, causing sedimentation and reducing water quality. The runoff can also carry agricultural chemicals, such as fertilizers and pesticides, which can contaminate water sources. Loss of biodiversity. Soil degradation can result in the loss of habitat for many organisms, including beneficial soil microorganisms, insects, and small mammals. This can disrupt the delicate balance of ecosystems and lead to a decline in biodiversity. Increased greenhouse gas emissions. Degraded soil releases carbon dioxide, CO2, and other greenhouse gases into the atmosphere, contributing to climate change. Desertification. In arid and semi-arid regions, soil degradation can lead to desertification, where fertile land turns into barren desert due to erosion and loss of vegetation. Economic losses. Soil degradation and erosion can have significant economic implications, including increased costs for farmers, reduced land value, and the need for soil remediation measures. 9.3.3 Sustainable farming practices. To combat soil degradation and erosion, it is crucial to adopt sustainable farming practices that promote soil health and conservation. Some of the key strategies include conservation tillage. Minimizing or eliminating tillage helps to reduce soil erosion and improve water infiltration. Conservation tillage methods, such as no-till or reduced tillage, leave crop residues on the soil surface, protecting it from erosion. Crop rotation and diversification. Planting a variety of crops in rotation helps to break pest and disease cycles, improve soil structure, and enhance nutrient cycling. Diversifying crops also increases the resilience of agricultural systems to climate change. Cover cropping. Planting cover crops, such as legumes or grasses, during fallow periods helps to protect the soil from erosion, improve soil fertility, and enhance organic matter content. Agroforestry. Integrating trees and shrubs into agricultural landscapes can help prevent soil erosion, provide shade and windbreaks, and enhance biodiversity. Terracing and contour farming. In hilly or sloping areas, terracing and contour farming techniques can help reduce soil erosion by creating level areas that slow down water runoff. Organic farming. Organic farming practices, such as the use of organic fertilizers, compost, and biological pest control, promote soil health and reduce the reliance on synthetic chemicals. Soil conservation measures. Implementing erosion control measures, such as the construction of bunds, contour trenches, and vegetative barriers, can help prevent soil erosion and retain water on agricultural lands. By adopting these sustainable farming practices, farmers can protect soil quality, enhance agricultural productivity, and contribute to the overall conservation of natural resources. In conclusion, soil degradation and erosion are significant challenges that require urgent attention. The causes of soil degradation are diverse, ranging from deforestation to improper agricultural practices. The impacts of soil degradation and erosion are far-reaching, affecting agriculture, water quality, biodiversity, and climate change. However, by implementing sustainable farming practices, we can mitigate these problems and ensure the long-term health and productivity of our soils. It is essential for farmers, policymakers, and society as a whole to recognize the importance of soil conservation and work together to promote sustainable land management practices. 9.4 Sustainable farming practices. Sustainable farming practices play a crucial role in mitigating agricultural pollution and promoting environmental stewardship. As the demand for food continues to rise, it is essential to adopt farming methods that minimize negative impacts on the environment, protect natural resources, and ensure the long-term sustainability of our agricultural systems. This section will explore various sustainable farming practices that can help reduce pollution and promote a healthier and more sustainable food production system. 9.4.1 Organic Farming. Organic farming is a sustainable agricultural practice that emphasizes the use of natural inputs and techniques to cultivate crops and raise livestock. Organic farmers avoid the use of synthetic fertilizers, pesticides, and genetically modified organisms (GMOs). Instead, they rely on organic fertilizers, crop rotation, and biological pest control methods to maintain soil fertility and control pests. By avoiding the use of synthetic chemicals, organic farming helps prevent water contamination and soil degradation. It promotes biodiversity by creating habitats for beneficial insects, birds, and other wildlife. Additionally, organic farming practices often prioritize soil conservation and erosion control, reducing the risk of sediment runoff into water bodies. 9.4.2 Precision Agriculture. Precision agriculture, also known as smart farming or precision farming, involves the use of technology to optimize agricultural practices. It utilizes tools such as GPS, sensors, and drones to collect data on soil conditions, crop health, and weather patterns. This data is then used to make informed decisions regarding irrigation, fertilization, and pest management. By applying inputs only where and when they are needed, precision agriculture minimizes the use of fertilizers, pesticides, and water, reducing the potential for pollution. It allows farmers to tailor their practices to specific areas of their fields, optimizing resource use and minimizing waste. Precision agriculture also helps improve crop yields and overall farm efficiency, contributing to sustainable food production. 9.4.3 Agroforestry. Agroforestry is a farming system that combines the cultivation of trees with crops or livestock. It involves the intentional integration of trees into agricultural landscapes to provide multiple benefits. Trees in agroforestry systems can help reduce soil erosion, improve water quality, and enhance biodiversity. The presence of trees in agroforestry systems helps to stabilize the soil, preventing erosion and nutrient runoff. Tree roots also contribute to soil structure and fertility, promoting healthier and more productive agricultural land. Agroforestry systems can provide shade and windbreaks, reducing the need for artificial cooling or heating in livestock operations. Additionally, the diverse habitats created by agroforestry systems support a wide range of beneficial insects, birds, and other wildlife, contributing to natural pest control. 9.4.4 Cover crops and crop rotation. Cover crops and crop rotation are practices that involve growing specific crops in a sequence or simultaneously to improve soil health, control pests, and reduce the need for synthetic inputs. Cover crops are planted between main crops to cover the soil during fallow periods, preventing erosion and nutrient leaching. They also help suppress weeds and improve soil structure. Crop rotation involves alternating the types of crops grown in a particular field over time. This practice helps break pest and disease cycles, reduces soil erosion, and improves soil fertility. By diversifying the crops grown, farmers can reduce the reliance on synthetic fertilizers and pesticides, minimizing the potential for pollution. 9.4.5 Integrated Pest Management (IPM). Integrated Pest Management (IPM) is an approach that focuses on preventing and managing pests using a combination of biological, cultural, and chemical control methods. IPM aims to minimize the use of synthetic pesticides while effectively managing pest populations. IPM strategies include monitoring pest populations, using pest-resistant crop varieties, promoting natural enemies of pests, and implementing cultural practices that reduce pest pressure. By reducing the reliance on chemical pesticides, IPM helps protect water quality and beneficial organisms while still ensuring crop productivity. 9.4.6 Nutrient Management. Proper nutrient management is essential for sustainable farming practices. It involves optimizing the use of fertilizers to minimize nutrient runoff and leaching, which can contribute to water pollution. Farmers can employ techniques such as soil testing, precision application of fertilizers, and the use of organic amendments to ensure that nutrients are applied in the right amounts and at the right time. By adopting nutrient management practices, farmers can reduce the risk of nutrient pollution in water bodies, such as excessive nitrogen and phosphorus levels that can lead to harmful algal blooms. Proper nutrient management also improves soil health and fertility, leading to more sustainable and productive agricultural systems. 9.4.7 Water Conservation. Water conservation practices are crucial for sustainable farming, especially in regions where water resources are limited or prone to drought. Farmers can implement various techniques to reduce water usage and minimize water pollution. Some water conservation practices include drip irrigation, which delivers water directly to plant roots, reducing evaporation and water waste. Farmers can also implement water-efficient irrigation systems, such as sprinklers with moisture sensors, to ensure that crops receive the right amount of water. Additionally, implementing water management strategies like rainwater harvesting and water recycling can help reduce the reliance on freshwater sources and minimize pollution from agricultural runoff. 9.4.8 Agroecology. Agroecology is an interdisciplinary approach to farming that combines ecological principles with agricultural practices. It focuses on creating sustainable and resilient farming systems that work in harmony with nature. Agroecological practices aim to enhance biodiversity, promote soil health, and reduce the use of external inputs. By adopting agroecological principles, farmers can minimize the negative impacts of agriculture on the environment. This includes reducing pollution from synthetic inputs, conserving water resources, and promoting the natural regulation of pests and diseases. Agroecology also emphasizes the importance of local and traditional knowledge, fostering community resilience and food sovereignty. In conclusion, sustainable farming practices are essential for reducing agricultural pollution and ensuring the long-term sustainability of our food production systems. By adopting practices such as organic farming, precision agriculture, agroforestry, and integrated pest management, farmers can minimize the use of synthetic inputs, protect natural resources, and promote environmental stewardship. Implementing sustainable farming practices not only benefits the environment but also contributes to healthier food production and more resilient farming communities. 10. Transportation pollution. 10.1 Vehicle emissions. Transportation is an essential part of our daily lives, allowing us to travel and commute efficiently. However, it also contributes significantly to pollution, particularly through vehicle emissions. The combustion of fossil fuels in vehicles releases various pollutants into the atmosphere, leading to air pollution and its detrimental effects on both human health and the environment. 10.1.1 Understanding vehicle emissions. Vehicle emissions refer to the gases and particles released into the air by vehicles, including cars, trucks, motorcycles, and buses. These emissions primarily come from the combustion of fossil fuels such as gasoline and diesel. The main pollutants emitted by vehicles include carbon monoxide, CO, nitrogen oxides, NOx, volatile organic compounds, VOCs, particulate matter, PM, and greenhouse gases, GHGs, such as carbon dioxide, CO2. 10.1.2 Impact of vehicle emissions. The release of pollutants from vehicle emissions has significant consequences for both human health and the environment. Air pollution caused by vehicle emissions contributes to the formation of smog, which can have severe respiratory effects, especially for vulnerable populations such as children, the elderly, and individuals with pre-existing respiratory conditions. Exposure to vehicle emissions has been linked to various health problems, including respiratory diseases, cardiovascular issues, and even cancer. Fine particulate matter PM2.5 and nitrogen dioxide number 2 are particularly harmful pollutants emitted by vehicles that can penetrate deep into the lungs and cause respiratory and cardiovascular problems. Furthermore, vehicle emissions are a major contributor to climate change. Carbon dioxide, a greenhouse gas released by vehicles, is a significant driver of global warming. The accumulation of greenhouse gases in the atmosphere leads to the greenhouse effect, trapping heat and causing the Earth's temperature to rise. This phenomenon has far-reaching consequences, including rising sea levels, extreme weather events, and disruptions to ecosystems. 10.1.3 Reducing vehicle emissions. To mitigate the harmful effects of vehicle emissions, it is crucial to implement measures that reduce pollution from transportation. Here are some strategies and technologies aimed at reducing vehicle emissions. 10.1.3.1 Improved fuel efficiency. One effective way to reduce vehicle emissions is by improving fuel efficiency. This can be achieved through advancements in engine technology, such as the development of hybrid and electric vehicles. Hybrid vehicles combine an internal combustion engine with an electric motor, reducing fuel consumption and emissions. Electric vehicles, EVs, on the other hand, produce zero tailpipe emissions since they run solely on electricity. 10.1.3.2 Alternative fuels. Another approach to reducing vehicle emissions is the use of alternative fuels. Biofuels, such as ethanol and biodiesel, can be produced from renewable sources and have lower carbon emissions compared to fossil fuels. Hydrogen fuel cells are also being explored as a clean alternative to traditional combustion engines. 10.1.3.3 Public transportation and carpooling. Encouraging the use of public transportation and carpooling can significantly reduce the number of vehicles on the road, thereby decreasing overall emissions. Efficient public transportation systems, including buses, trains, and trams, can provide a sustainable alternative to individual car use. Carpooling and ride-sharing services also help optimize vehicle occupancy and reduce emissions per passenger. 10.1.3.4 Active transportation. Promoting active transportation methods such as walking, cycling, and using non-motorized vehicles can further reduce vehicle emissions. Shorter trips can be made by walking or cycling, reducing the reliance on motor vehicles. This not only reduces pollution but also promotes physical activity and improves public health. 10.1.3.5 Traffic management and infrastructure. Efficient traffic management systems and well-designed infrastructure can help reduce congestion and improve traffic flow. Smooth traffic flow reduces the time vehicles spend idling, which in turn reduces emissions. Additionally, the development of dedicated bicycle lanes and pedestrian-friendly infrastructure encourages active transportation and reduces the need for motorized vehicles. 10.1.4 Government regulations and incentives. Government regulations play a crucial role in reducing vehicle emissions. Emission standards and regulations can enforce stricter limits on pollutants emitted by vehicles, encouraging manufacturers to develop cleaner and more fuel-efficient technologies. Incentives such as tax credits and subsidies for electric vehicles can also promote the adoption of cleaner transportation options. Furthermore, governments can invest in the development of charging infrastructure for electric vehicles and support research and development for alternative fuels and technologies. By providing the necessary infrastructure and financial support, governments can accelerate the transition to a more sustainable transportation system. 10.1.5 Conclusion. Vehicle emissions are a significant contributor to air pollution and climate change. The combustion of fossil fuels in vehicles releases pollutants that have detrimental effects on human health and the environment. However, through improved fuel efficiency, the use of alternative fuels, promoting public transportation and active transportation, and implementing government regulations and incentives, we can reduce vehicle emissions and create a more sustainable and cleaner transportation system. It is crucial for individuals, communities, and governments to work together to address the issue of vehicle emissions and strive for a greener future. 10.2 Air pollution from transportation. Transportation is a vital part of our modern society, allowing us to travel and transport goods efficiently. However, it also contributes significantly to air pollution, which has detrimental effects on both human health and the environment. In this section, we will explore the various sources of air pollution from transportation and discuss the measures that can be taken to mitigate its impact. 10.2.1 Vehicles and their emissions. The primary source of air pollution from transportation is the emissions produced by vehicles. Whether it is cars, trucks, motorcycles, or airplanes, these modes of transportation release pollutants into the atmosphere. The combustion of fossil fuels, such as gasoline and diesel, in vehicle engines leads to the emission of harmful substances, including carbon monoxide, CO, nitrogen oxides, NOx, volatile organic compounds, VOCs, and particulate matter, PM. Carbon monoxide is a colorless and odorless gas that is produced when fossil fuels are burned incompletely. It can have severe health effects, particularly when inhaled in high concentrations. Nitrogen oxides are formed when nitrogen and oxygen react at high temperatures, primarily in the engines of vehicles. These compounds contribute to the formation of smog and acid rain and can cause respiratory problems. Volatile organic compounds are released from the evaporation of fuels and other chemicals used in vehicles. They are a significant contributor to the formation of ground-level ozone, which is harmful to human health and the environment. Particulate matter consists of tiny particles suspended in the air, which can be solid or liquid. These particles can penetrate deep into the lungs and cause respiratory and cardiovascular problems. 10.2.2 Impact on human health. The air pollution resulting from transportation has severe consequences for human health. The pollutants emitted by vehicles can lead to respiratory issues, such as asthma, bronchitis, and other respiratory infections. Long-term exposure to these pollutants has been linked to the development of chronic respiratory diseases and even lung cancer. Children, the elderly, and individuals with pre-existing respiratory conditions are particularly vulnerable to the health effects of transportation-related air pollution. The proximity of roads and highways to residential areas can expose these populations to higher levels of pollutants, increasing their risk of adverse health outcomes. Furthermore, the emissions from vehicles contribute to the formation of ground-level ozone and fine particulate matter, both of which have been associated with cardiovascular problems. Studies have shown that exposure to these pollutants can increase the risk of heart attacks, strokes, and other cardiovascular diseases. 10.2.3 Environmental impact. In addition to its impact on human health, air pollution from transportation also has significant environmental consequences. The release of carbon dioxide, CO2, and other greenhouse gases from vehicles contributes to climate change, leading to rising global temperatures and the disruption of ecosystems. The combustion of fossil fuels in transportation is a major contributor to the increase in atmospheric CO2 levels, which is the primary driver of global warming. The resulting climate change has far-reaching effects, including the melting of polar ice caps, rising sea levels, and more frequent and severe weather events. Furthermore, the emissions from vehicles contribute to the formation of smog, which is a mixture of pollutants, including ground-level ozone. Smog not only reduces visibility but also harms plant life and ecosystems. It can damage crops, forests, and other vegetation, leading to reduced agricultural productivity and biodiversity loss. 10.2.4 Mitigating air pollution from transportation. To address the air pollution caused by transportation, various measures can be implemented to reduce emissions and promote cleaner modes of transportation. Some of these measures include improving fuel efficiency. Encouraging the use of more fuel-efficient vehicles, such as hybrid and electric cars, can significantly reduce emissions. Governments can provide incentives for the purchase of these vehicles and promote the development of charging infrastructure. Investing in public transportation. Enhancing public transportation systems, including buses, trains, and trams, can reduce the number of private vehicles on the road. This can lead to a decrease in overall emissions and alleviate traffic congestion. Promoting active transportation. Encouraging walking, cycling, and other forms of active transportation can reduce the reliance on motor vehicles for short-distance trips. This not only reduces emissions but also promotes physical activity and improves public health. Implementing emission standards. Governments can enforce stricter emission standards for vehicles, requiring manufacturers to produce vehicles that emit fewer pollutants. This can be achieved through the use of catalytic converters, particulate filters, and other emission control technologies. Investing in alternative fuels. Supporting the development and use of alternative fuels, such as biofuels and hydrogen, can help reduce the carbon footprint of transportation. These fuels have the potential to lower emissions and decrease dependence on fossil fuels. Encouraging carpooling and ride-sharing. Promoting carpooling and ride-sharing initiatives can reduce the number of vehicles on the road, leading to lower emissions per passenger. This can be facilitated through the use of dedicated carpool lanes and incentives for ride-sharing services. Introducing congestion pricing. Implementing congestion pricing schemes, where drivers are charged for entering congested areas during peak hours, can incentivize the use of public transportation and reduce traffic congestion and emissions. By implementing these measures and adopting cleaner and more sustainable transportation practices, we can significantly reduce air pollution from transportation and create a healthier and more sustainable future for all. It requires collective efforts from individuals, governments, and industries to make a positive impact and mitigate the harmful effects of transportation-related air pollution. 10.3 Reducing carbon footprint. Reducing carbon footprint is crucial in addressing the issue of transportation pollution and mitigating the harmful effects of greenhouse gas emissions on the environment. Carbon footprint refers to the total amount of greenhouse gases, primarily carbon dioxide, CO2, emitted directly or indirectly by an individual, organization, or product. In this section, we will explore various strategies and actions that can be taken to reduce carbon footprint and promote a more sustainable transportation system. 10.3.1 Sustainable transportation choices. One of the most effective ways to reduce carbon footprint is by making sustainable transportation choices. This involves opting for modes of transportation that have lower emissions and are more environmentally friendly. Here are some strategies to consider. 10.3.1.1 Public transportation. Using public transportation, such as buses, trains, and trams, can significantly reduce carbon emissions. Public transportation systems are designed to carry a large number of passengers, which helps to reduce the number of individual vehicles on the road. By choosing public transportation over private vehicles, we can decrease the overall carbon footprint associated with transportation. 10.3.1.2 Cycling and walking. For shorter distances, cycling or walking can be a great alternative to using motorized vehicles. These modes of transportation produce zero emissions and have the added benefit of promoting physical activity and improving personal health. By incorporating cycling and walking into our daily routines, we can reduce our carbon footprint while also enjoying the benefits of exercise. 10.3.1.3 Carpooling and ride-sharing. Carpooling and ride-sharing are effective ways to reduce the number of vehicles on the road and decrease carbon emissions. By sharing rides with others who are traveling in the same direction, we can significantly reduce the overall carbon footprint associated with transportation. Carpooling and ride-sharing platforms and apps have made it easier than ever to connect with others and share rides, making this option more accessible and convenient. 10.3.1.4 Electric and hybrid vehicles. Electric and hybrid vehicles are becoming increasingly popular as they offer a cleaner and more sustainable alternative to traditional gasoline-powered cars. Electric vehicles (EVs) produce zero tailpipe emissions, while hybrid vehicles combine an internal combustion engine with an electric motor, resulting in lower emissions compared to conventional vehicles. Transitioning to electric or hybrid vehicles can have a significant impact on reducing carbon footprint, especially when combined with renewable energy sources for charging. 10.3.2 Efficient driving practices. In addition to choosing sustainable transportation options, adopting efficient driving practices can further contribute to reducing carbon footprint. Here are some tips to consider. 10.3.2.1 Eco-driving techniques. Practicing eco-driving techniques can help optimize fuel efficiency and reduce emissions. This includes driving at a steady speed, avoiding rapid acceleration and braking, and maintaining proper tire pressure. By driving more efficiently, we can minimize fuel consumption and decrease our carbon footprint. 10.3.2.2 Regular vehicle maintenance. Regular vehicle maintenance is essential for ensuring optimal performance and fuel efficiency. Keeping tires properly inflated, changing air filters, and performing regular engine tune-ups can improve fuel economy and reduce emissions. By maintaining our vehicles in good condition, we can minimize their environmental impact. 10.3.3 Alternative fuels and energy sources. Exploring alternative fuels and energy sources is another important aspect of reducing carbon footprint in transportation. Here are some alternatives to consider. 10.3.3.1 Biofuels. Biofuels, such as ethanol and biodiesel, are derived from renewable sources such as plants and algae. These fuels can be used as substitutes for gasoline and diesel, reducing carbon emissions from vehicles. However, it is important to ensure that biofuels are produced sustainably and do not contribute to deforestation or food scarcity. 10.3.3.2 Hydrogen fuel cells. Hydrogen fuel cells are an emerging technology that produces electricity by combining hydrogen and oxygen, with water being the only byproduct. Fuel cell vehicles powered by hydrogen offer zero-emission transportation and have the potential to significantly reduce carbon footprint. However, the production and distribution of hydrogen fuels still face challenges in terms of cost and infrastructure. 10.3.3.3 Renewable energy for charging. Transitioning to renewable energy sources for charging electric vehicles can further reduce carbon footprint. By utilizing solar, wind, or hydroelectric power to generate electricity, we can ensure that the energy used to charge electric vehicles is clean and sustainable. This combination of electric vehicles and renewable energy creates a truly low-carbon transportation system. 10.3.4 Land Use Planning and Infrastructure. Efforts to reduce carbon footprint in transportation should also include land use planning and infrastructure development. Here are some considerations. 10.3.4.1 Compact and mixed-use development. Promoting compact and mixed-use development can help reduce the need for long-distance travel and encourage walking, cycling, and the use of public transportation. By creating communities where residential, commercial, and recreational areas are within close proximity, we can minimize the carbon emissions associated with transportation. 10.3.4.2 Infrastructure for sustainable transportation. Investing in infrastructure that supports sustainable transportation is crucial. This includes developing and maintaining an extensive network of bike lanes and pedestrian paths, improving public transportation systems, and installing electric vehicle charging stations. By providing the necessary infrastructure, we can encourage and facilitate the adoption of sustainable transportation options. 10.3.5 Education and Awareness. Education and awareness play a vital role in reducing carbon footprint in transportation. By raising awareness about the environmental impacts of transportation and promoting the benefits of sustainable transportation choices, we can encourage individuals, communities, and governments to take action. Educational campaigns, public outreach programs, and initiatives that promote sustainable transportation can help drive the necessary behavioral changes and create a more sustainable future. In conclusion, reducing carbon footprint in transportation is essential for mitigating the harmful effects of greenhouse gas emissions. By making sustainable transportation choices, adopting efficient driving practices, exploring alternative fuels and energy sources, and investing in land use planning and infrastructure, we can significantly reduce our carbon emissions and create a more sustainable transportation system. Education and awareness are also crucial in driving the necessary behavioral changes. It is through collective efforts and individual actions that we can make a positive impact and contribute to a cleaner and greener future. 10.4 Promoting green transportation. Transportation is a vital aspect of our modern society, enabling us to travel and transport goods efficiently. However, it also contributes significantly to pollution, particularly air pollution and greenhouse gas emissions. The burning of fossil fuels in vehicles releases harmful pollutants into the atmosphere, leading to various environmental and health issues. To combat this problem, it is crucial to promote green transportation alternatives that are more sustainable and environmentally friendly. 10.4.1 The environmental impact of transportation. Before delving into the promotion of green transportation, it is essential to understand the environmental impact of traditional transportation methods. The combustion of fossil fuels in vehicles releases carbon dioxide, CO2, nitrogen oxides, NOx, particulate matter, PM, and other harmful pollutants into the air. These pollutants contribute to air pollution, smog formation, and climate change. Furthermore, the transportation sector is a significant contributor to greenhouse gas emissions. According to the International Energy Agency (IEA), it accounted for approximately 24% of global energy-related CO2 emissions in 2020. The majority of these emissions come from road vehicles, including cars, trucks, and motorcycles. 10.4.2 Green transportation alternatives. Promoting green transportation involves encouraging the use of alternative modes of transportation that have a lower environmental impact. Here are some key green transportation alternatives. 10.4.2.1 Public transportation. Public transportation systems, such as buses, trains, trams, and subways, play a crucial role in reducing the number of individual vehicles on the road. By promoting and improving public transportation infrastructure, more people can choose to travel collectively, reducing overall emissions. Additionally, investing in electric or hybrid buses and trains can further decrease the environmental impact of public transportation. 10.4.2.2 Cycling and walking. Encouraging active modes of transportation, such as cycling and walking, not only reduces pollution but also promotes a healthier lifestyle. Building dedicated cycling lanes, pedestrian-friendly infrastructure, and providing bike-sharing programs can incentivize people to choose these sustainable modes of transportation for short-distance travel. 10.4.2.3 Electric vehicles (EVs). Electric vehicles (EVs) are becoming increasingly popular as a greener alternative to traditional gasoline or diesel-powered vehicles. EVs produce zero tailpipe emissions, significantly reducing air pollution and greenhouse gas emissions. Governments and organizations can promote the adoption of EVs by offering incentives, installing charging infrastructure, and supporting research and development in battery technology. 10.4.2.4 Carpooling and ride-sharing. Carpooling and ride-sharing programs encourage people to share rides, reducing the number of vehicles on the road. By promoting these initiatives through incentives, dedicated carpool lanes, and user-friendly platforms, individuals can reduce their carbon footprint while also saving on transportation costs. 10.4.2.5 Sustainable aviation. While aviation is a significant contributor to greenhouse gas emissions, efforts are being made to develop sustainable aviation alternatives. This includes the use of biofuels, electric aircraft, and improvements in aircraft design and efficiency. Additionally, promoting the use of video conferencing and remote work options can help reduce the need for air travel. 10.4.3 Benefits of green transportation. Promoting green transportation offers numerous benefits for both the environment and society as a whole. Here are some key advantages. 10.4.3.1 Reduced air pollution. By transitioning to green transportation alternatives, we can significantly reduce air pollution. Electric vehicles produce zero tailpipe emissions, and public transportation systems emit fewer pollutants per passenger compared to individual vehicles. This improvement in air quality can have a positive impact on public health, reducing respiratory problems and other related illnesses. 10.4.3.2 Mitigation of climate change. Green transportation plays a crucial role in mitigating climate change by reducing greenhouse gas emissions. Electric vehicles, when powered by renewable energy sources, have a significantly lower carbon footprint compared to conventional vehicles. Additionally, promoting sustainable aviation alternatives can help reduce the carbon footprint of the aviation industry. 10.4.3.3 Improved traffic congestion. Encouraging the use of public transportation, cycling, and walking can help alleviate traffic congestion in urban areas. By reducing the number of individual vehicles on the road, we can improve traffic flow, reduce travel times, and enhance overall transportation efficiency. 10.4.3.4 Health and well-being. Green transportation alternatives, such as cycling and walking, promote physical activity and a healthier lifestyle. By incorporating active modes of transportation into daily routines, individuals can improve their cardiovascular health, reduce the risk of chronic diseases, and enhance overall well-being. 10.4.4 Strategies for promoting green transportation. To effectively promote green transportation, a combination of strategies and initiatives is necessary. Here are some key approaches. 10.4.4.1 Infrastructure development. Investing in the development of sustainable transportation infrastructure is crucial. This includes building dedicated cycling lanes, expanding public transportation networks, and installing electric vehicle charging stations. By providing the necessary infrastructure, individuals are more likely to adopt green transportation alternatives. 10.4.4.2 Financial incentives. Governments can offer financial incentives to encourage the adoption of green transportation. This can include tax credits, subsidies for electric vehicles, and reduced fares for public transportation. Financial incentives make green transportation options more accessible and affordable for individuals. 10.4.4.3 Education and awareness. Raising awareness about the environmental and health benefits of green transportation is essential. Educational campaigns can inform the public about the impact of traditional transportation methods and the available green alternatives. By promoting the advantages and dispelling myths, individuals can make informed choices regarding their transportation habits. 10.4.4.4 Collaboration and partnerships. Collaboration between governments, transportation agencies, businesses, and community organizations is crucial for promoting green transportation. By working together, stakeholders can develop comprehensive strategies, share resources, and implement initiatives that encourage the adoption of sustainable transportation practices. Conclusion. Promoting green transportation is essential for reducing pollution and mitigating the impacts of climate change. By encouraging the use of public transportation, cycling, walking, electric vehicles, and other sustainable alternatives, we can create a cleaner and healthier environment for future generations. Through infrastructure development, financial incentives, education, and collaboration, we can make significant progress in transitioning to a more sustainable transportation system. It is up to individuals, communities, and governments to embrace and promote green transportation for a greener and more sustainable future. 11. Waste pollution. 11.1 Types of waste. Waste is a byproduct of human activities that is no longer useful or desired. It can take various forms and can be generated from different sources. Understanding the different types of waste is crucial in developing effective waste management strategies and mitigating the negative impacts of waste pollution. In this section, we will explore the various types of waste and their characteristics. 11.1.1 Municipal solid waste. Municipal solid waste (MSW) is the most common type of waste generated by households, commercial establishments, and institutions. It includes everyday items such as food waste, paper, plastics, glass, metals, textiles, and yard waste. MSW is typically collected by local authorities and disposed of in landfills or incinerated. However, improper management of MSW can lead to environmental pollution and health hazards. 11.1.2 Hazardous waste. Hazardous waste refers to waste materials that pose a significant threat to human health and the environment due to their toxic, flammable, corrosive, or reactive nature. This type of waste includes chemicals, solvents, pesticides, batteries, electronic waste, e-waste, and medical waste. Improper disposal or mishandling of hazardous waste can contaminate soil, water, and air, leading to severe health issues and ecological damage. 11.1.3 Industrial waste. Industrial waste is generated by manufacturing, processing, and industrial activities. It includes various types of waste such as chemicals, heavy metals, sludge, wastewater, and byproducts from industrial processes. Industrial waste can be highly toxic and can contaminate soil, water bodies, and air if not properly managed. Industries are required to follow strict regulations and implement appropriate waste management practices to minimize their environmental impact. 11.1.4 Construction and Demolition Waste. Construction and demolition waste (C&D) waste is generated during construction, renovation, and demolition activities. It includes materials such as concrete, wood, metals, bricks, asphalt, and plastics. C&D waste can be bulky and difficult to manage. Improper disposal of C&D waste can lead to land degradation, water pollution, and increased greenhouse gas emissions. Recycling and proper disposal of C&D waste are essential to reduce its environmental impact. 11.1.5 Agricultural waste. Agricultural waste is generated from farming activities, including crop production, livestock rearing, and food processing. It includes crop residues, animal manure, agricultural chemicals, and packaging materials. Improper management of agricultural waste can lead to soil degradation, water contamination, and air pollution. Implementing sustainable farming practices, such as composting and proper waste disposal, can help minimize the environmental impact of agricultural waste. 11.1.6 Biomedical waste. Biomedical waste, also known as healthcare or medical waste, is generated from healthcare facilities, research laboratories, and veterinary clinics. It includes infectious waste, sharps, needles, syringes, pharmaceutical waste, and pathological waste. Improper handling and disposal of biomedical waste can pose serious health risks to healthcare workers, waste handlers, and the general public. Strict regulations and proper waste management practices are necessary to prevent the spread of infections and protect public health. 11.1.7 Electronic waste. Electronic waste, or e-waste, refers to discarded electronic devices such as computers, mobile phones, televisions, and household appliances. E-waste contains hazardous materials like lead, mercury, cadmium, and brominated flame retardants. Improper disposal of e-waste can result in the release of toxic substances into the environment, endangering human health and contaminating soil and water. Proper recycling and responsible disposal of e-waste are essential to minimize its environmental impact. 11.1.8 Radioactive waste. Radioactive waste is generated from nuclear power plants, research facilities, and medical institutions that use radioactive materials. It includes spent nuclear fuel, contaminated equipment, and radioactive liquids or solids. Radioactive waste is highly hazardous and can remain dangerous for thousands of years. Proper containment, storage, and disposal methods are crucial to prevent radiation exposure and protect human health and the environment. 11.1.9 Organic waste. Organic waste includes biodegradable materials such as food waste, garden waste, and agricultural residues. When organic waste decomposes in landfills, it produces methane, a potent greenhouse gas that contributes to climate change. Proper management of organic waste through composting or anaerobic digestion can help reduce methane emissions and produce valuable resources like compost or biogas. 11.1.10 Plastic waste. Plastic waste is a significant environmental concern due to its non-biodegradable nature and widespread use. It includes single-use plastics, packaging materials, and plastic products that end up in landfills, oceans, and other natural habitats. Plastic waste poses a threat to wildlife, marine ecosystems, and human health. Implementing effective waste management strategies, promoting recycling, and reducing plastic consumption are essential to tackle the plastic waste crisis. Understanding the different types of waste is crucial in developing comprehensive waste management plans and implementing effective pollution control measures. By addressing the specific characteristics and challenges associated with each type of waste, we can work towards a more sustainable and cleaner future. 11.2 Impacts of waste pollution. Waste pollution, also known as garbage or trash pollution, refers to the contamination of the environment by the improper disposal of waste materials. It is a significant environmental issue that has far-reaching impacts on ecosystems, human health, and the overall well-being of our planet. In this section, we will explore the various impacts of waste pollution and the consequences it has on our environment. 11.2.1 Environmental degradation. One of the most significant impacts of waste pollution is the degradation of the environment. Improperly disposed waste, such as plastic bags, bottles, and other non-biodegradable materials, can accumulate in landfills, rivers, and oceans, causing severe damage to ecosystems. Marine life, for example, often mistake plastic waste for food, leading to ingestion and entanglement, which can result in injury or death. Additionally, waste pollution can contaminate soil and water sources, affecting plant and animal life and disrupting the delicate balance of ecosystems. 11.2.2 Soil contamination. Waste pollution can contaminate soil, making it unsuitable for agriculture and posing a threat to human health. When hazardous waste, such as chemicals or heavy metals, seeps into the soil, it can be absorbed by plants, entering the food chain. This contamination not only affects the quality and productivity of crops but also poses a risk to human health when consumed. Furthermore, the accumulation of non-biodegradable waste in soil can hinder its natural processes, such as nutrient cycling and water filtration, leading to long-term damage to the ecosystem. 11.2.3 Water pollution. Improper waste disposal can result in water pollution, which has severe consequences for aquatic ecosystems and human populations. When waste materials, including plastics, chemicals, and sewage, enter rivers, lakes, and oceans, they contaminate the water and disrupt the delicate balance of aquatic life. Marine animals and plants can suffer from the toxic effects of pollutants, leading to reduced biodiversity and ecosystem collapse. Moreover, contaminated water sources can pose a significant risk to human health, causing waterborne diseases and other health issues. 11.2.4 Air pollution. Waste pollution also contributes to air pollution, primarily through the release of harmful gases and the burning of waste materials. Landfills, where waste is often dumped, produce methane gas, a potent greenhouse gas that contributes to climate change. Additionally, the incineration of waste releases toxic pollutants into the air, such as dioxins and furans, which can have detrimental effects on human health and the environment. These pollutants can cause respiratory problems, cardiovascular diseases, and even cancer. 11.2.5 Wildlife impact. The impact of waste pollution on wildlife is significant and often devastating. Animals can become entangled in plastic waste or mistake it for food, leading to injury, suffocation, or starvation. Marine animals, such as turtles, seabirds, and whales, are particularly vulnerable to waste pollution in oceans and coastal areas. The ingestion of plastic waste can cause internal injuries, blockages in the digestive system, and ultimately, death. The loss of biodiversity due to waste pollution disrupts ecosystems and can have cascading effects on the entire food chain. 11.2.6 Human health risks. Waste pollution poses significant risks to human health, both directly and indirectly. Direct exposure to hazardous waste materials can lead to acute and chronic health problems, including respiratory issues, skin diseases, and neurological disorders. The improper disposal of medical waste, such as syringes and pharmaceuticals, can also pose a risk of infection and the spread of diseases. Indirectly, the contamination of air, water, and soil by waste pollutants can lead to the consumption of contaminated food and water, causing various health issues, including gastrointestinal problems, organ damage, and even cancer. 11.2.7 Economic consequences. The impacts of waste pollution extend beyond the environment and human health, they also have significant economic consequences. The cleanup and remediation of polluted areas require substantial financial resources. Governments and communities must invest in waste management systems, recycling facilities, and pollution control measures, which can strain budgets and hinder economic development. Additionally, the negative effects of waste pollution on tourism, agriculture, and fisheries can result in economic losses for communities that rely on these industries. 11.2.8 Climate change. Waste pollution contributes to climate change through the release of greenhouse gases, such as methane and carbon dioxide. Methane, produced by the decomposition of organic waste in landfills, is a potent greenhouse gas that is significantly more effective at trapping heat in the atmosphere than carbon dioxide. The improper disposal of waste also leads to the release of carbon dioxide through incineration and the burning of waste materials. These greenhouse gas emissions contribute to global warming, leading to rising temperatures, melting ice caps, and other adverse effects on the planet. In conclusion, waste pollution has wide-ranging impacts on the environment, human health, and the economy. It leads to environmental degradation, soil contamination, water pollution, air pollution, and the loss of biodiversity. The risks to human health are significant, and the economic consequences are substantial. It is crucial for individuals, communities, and governments to take action to reduce waste pollution through proper waste management, recycling, and the promotion of sustainable practices. Only through collective efforts can we mitigate the impacts of waste pollution and create a cleaner and healthier environment for future generations. 11.3 Waste management strategies. Waste management is a crucial aspect of tackling pollution and ensuring a sustainable future. The improper disposal of waste can have severe environmental and health consequences. To address this issue, waste management strategies have been developed to minimize the negative impacts of waste on our planet. These strategies aim to reduce the amount of waste generated, promote recycling and reuse, and ensure the safe disposal of waste that cannot be avoided. In this section, we will explore some of the key waste management strategies that can help mitigate pollution. 11.3.1 Waste minimization. One of the most effective waste management strategies is waste minimization. This approach focuses on reducing the amount of waste generated at its source. By implementing waste minimization practices, individuals, businesses, and industries can significantly reduce their environmental footprint. Some common waste minimization techniques include source reduction. This involves finding ways to reduce the amount of waste generated during the production process. It can include using less packaging, optimizing manufacturing processes, and implementing efficient resource management techniques. Product redesign. By designing products with a focus on durability, recyclability, and reusability, waste generation can be minimized. This can involve using eco-friendly materials, designing products for easy disassembly, and promoting repair and reuse. Education and awareness. Raising awareness about the importance of waste reduction and providing education on sustainable consumption practices can encourage individuals to make conscious choices that minimize waste generation. 11.3.2 Waste segregation. Proper waste segregation is another crucial waste management strategy. It involves separating different types of waste at the source to facilitate recycling and proper disposal. By segregating waste into categories such as organic waste, recyclables, and hazardous waste, the effectiveness of recycling and disposal processes can be maximized. Some key benefits of waste segregation include increased recycling rates. When waste is properly segregated, recyclable materials can be easily identified and sent for recycling. This reduces the amount of waste that ends up in landfills or incinerators. Reduced contamination. Mixing different types of waste can lead to contamination, making it difficult to recycle or dispose of waste properly. Waste segregation helps prevent contamination and ensures that each type of waste is treated appropriately. Resource conservation. Segregating waste allows for the recovery of valuable resources from recyclable materials. This reduces the need for extracting and processing virgin materials, conserving natural resources and reducing energy consumption. 11.3.3 Waste treatment and disposal. For waste that cannot be avoided, minimized, or recycled, proper treatment and disposal are essential. Waste treatment processes aim to reduce the volume and toxicity of waste, making it safer for disposal. Some common waste treatment methods include incineration. This process involves burning waste at high temperatures, converting it into ash, gases, and heat. Incineration can help reduce the volume of waste and generate energy in the form of heat or electricity. However, it is important to ensure that incineration facilities are equipped with proper pollution control measures to minimize air pollution. Landfilling. Landfills are engineered sites designed to safely dispose of non-recyclable waste. Proper landfill management includes measures to prevent groundwater contamination, control methane emissions, and minimize the release of harmful substances into the environment. Composting. Organic waste, such as food scraps and yard waste, can be composted to produce nutrient-rich compost. Composting not only reduces the amount of waste sent to landfills but also provides a valuable resource for improving soil health and promoting sustainable agriculture. 11.3.4 Extended Producer Responsibility (EPR). Extended Producer Responsibility (EPR) is a waste management strategy that holds manufacturers responsible for the entire life cycle of their products, including their disposal. Under EPR programs, manufacturers are required to take back and properly manage their products at the end of their useful life. This approach encourages manufacturers to design products that are easier to recycle, reuse, or safely dispose of. EPR programs have been successful in increasing recycling rates and reducing the environmental impact of products. 11.3.5 Waste to Energy. Waste-to-energy (WTE) technologies offer an alternative approach to waste management by converting waste into energy. These technologies include processes such as anaerobic digestion, gasification, and pyrolysis. By harnessing the energy content of waste, WTE facilities can generate electricity or heat, reducing the reliance on fossil fuels. However, it is important to ensure that these technologies are implemented with proper emission control measures to minimize air pollution and other environmental impacts. 11.3.6 Circular Economy. The concept of a circular economy is gaining momentum as a sustainable waste management strategy. In a circular economy, resources are used efficiently, and waste is minimized through recycling, reuse, and repair. This approach aims to create a closed-loop system where materials are continuously circulated within the economy, reducing the need for extracting and processing virgin resources. By transitioning to a circular economy, we can significantly reduce pollution and promote a more sustainable future. In conclusion, effective waste management strategies are essential for combating pollution. Waste minimization, segregation, proper treatment and disposal, extended producer responsibility, waste-to-energy technologies, and the transition to a circular economy are all important components of a comprehensive waste management approach. By implementing these strategies at individual, community, and governmental levels, we can reduce pollution, conserve resources, and create a cleaner and healthier environment for future generations. 11.4 Recycling and circular economy. Recycling and the concept of a circular economy play a crucial role in addressing waste pollution and reducing the strain on our natural resources. As we have discussed in previous chapters, waste pollution has severe environmental and health impacts, and it is essential to find sustainable solutions to manage and minimize waste. Recycling and the circular economy offer a way forward by promoting the reuse and regeneration of materials, reducing the need for extraction and production of new resources. 11.4.1 The importance of recycling. Recycling is the process of converting waste materials into reusable materials. It involves collecting, sorting, processing, and transforming waste products into new products or raw materials. Recycling helps to conserve natural resources, reduce energy consumption, and minimize the amount of waste that ends up in landfills or incinerators. One of the primary benefits of recycling is the conservation of resources. By recycling materials such as paper, plastic, glass, and metal, we can reduce the need for extracting and processing virgin materials. This, in turn, helps to preserve forests, reduce water consumption, and minimize the destruction of habitats caused by mining and extraction activities. Recycling also plays a crucial role in reducing energy consumption and greenhouse gas emissions. The production of new materials from recycled materials generally requires less energy compared to the production of virgin materials. For example, recycling aluminum cans saves up to 95% of the energy required to produce aluminum from bauxite ore. By reducing energy consumption, recycling helps to mitigate climate change and reduce air pollution associated with energy production. 11.4.2 The circular economy approach. The circular economy is an economic model that aims to minimize waste and maximize the value of resources by keeping them in use for as long as possible. It is a departure from the traditional linear economy, where resources are extracted, used, and then discarded as waste. In a circular economy, resources are continuously cycled back into the production process, creating a closed-loop system. The circular economy approach emphasizes three key principles: reduce, reuse, and recycle. By reducing the consumption of resources, reusing products and materials, and recycling waste, we can create a more sustainable and efficient economy. One of the fundamental aspects of the circular economy is the concept of product design for longevity and recyclability. Designing products with durability in mind ensures that they have a longer lifespan, reducing the need for frequent replacements. Additionally, designing products for recyclability means considering the materials used and their potential for being recycled at the end of their life cycle. 11.4.3 Benefits of the circular economy. The adoption of a circular economy approach offers numerous benefits for both the environment and the economy. Some of the key benefits include: environmental benefits. Reduced resource consumption. By reusing and recycling materials, the circular economy reduces the need for extracting and processing virgin resources, leading to a significant reduction in resource consumption. Waste reduction. The circular economy aims to minimize waste generation by promoting the reuse and recycling of materials, diverting waste from landfills and incinerators. Lower greenhouse gas emissions. Recycling and reusing materials require less energy compared to the production of new materials, resulting in reduced greenhouse gas emissions and mitigating climate change. Conservation of ecosystems. By reducing the demand for raw materials, the circular economy helps to protect natural habitats and ecosystems from the destructive impacts of extraction activities. Economic benefits. Job creation. The transition to a circular economy creates new job opportunities in recycling, waste management, and the development of innovative technologies and processes. Cost savings. Recycling and reusing materials can lead to cost savings for businesses by reducing the need for purchasing new raw materials and managing waste disposal. Increased resource efficiency. The circular economy promotes the efficient use of resources, maximizing their value and minimizing waste, which can result in improved productivity and competitiveness for businesses. 11.4.4 Challenges and solutions. While recycling and the circular economy offer significant benefits, there are also challenges that need to be addressed for their successful implementation. One of the primary challenges is the lack of infrastructure and facilities for recycling and waste management. To overcome this, governments and businesses need to invest in the development of recycling facilities, collection systems, and technologies that enable efficient sorting and processing of recyclable materials. Another challenge is the need for consumer awareness and behavior change. Many people are still not fully aware of the importance of recycling and the impact of their consumption choices. Education and awareness campaigns can help to promote recycling and encourage individuals to adopt more sustainable practices. Additionally, the circular economy requires collaboration and cooperation among various stakeholders, including governments, businesses, and consumers. Policies and regulations that incentivize recycling and the use of recycled materials can play a crucial role in driving the transition to a circular economy. Businesses can also take the lead by incorporating circular economy principles into their operations and supply chains. In conclusion, recycling and the circular economy are essential strategies for addressing waste pollution and promoting sustainable resource management. By reducing resource consumption, minimizing waste generation, and maximizing the value of materials, we can create a more sustainable and efficient economy while protecting the environment for future generations. It is crucial for individuals, businesses, and governments to work together to embrace recycling and the circular economy as key solutions to combat waste pollution and build a more sustainable future. 12. Individual and collective actions. 12.1 Personal choices to reduce pollution. Pollution is a global problem that affects the health and well-being of both humans and the environment. While government policies and regulations play a crucial role in addressing pollution, individual actions also have a significant impact. By making conscious choices in our daily lives, we can contribute to reducing pollution and creating a cleaner and healthier world for future generations. In this section, we will explore some personal choices that can help reduce pollution. 12.1.1 Sustainable transportation. One of the major contributors to air pollution is transportation, particularly vehicles that run on fossil fuels. To reduce pollution from transportation, individuals can make sustainable choices when it comes to commuting and traveling. Here are some options. Use public transportation. Opting for buses, trains, or trams instead of driving a personal vehicle can significantly reduce air pollution. Public transportation not only reduces emissions but also helps alleviate traffic congestion. Carpooling and ride sharing. Sharing rides with others going in the same direction can reduce the number of vehicles on the road, thereby reducing pollution. Carpooling and ride-sharing platforms make it easier to connect with others who have similar commuting routes. Cycling and walking. For shorter distances, choosing to walk or ride a bicycle can be a pollution-free mode of transportation. Not only does it reduce pollution, but it also promotes physical activity and improves personal health. Electric vehicles. If feasible, consider switching to an electric vehicle (EV) or a hybrid vehicle. EVs produce zero tailpipe emissions, reducing air pollution significantly. As the infrastructure for EV charging stations continues to grow, electric vehicles are becoming a more viable option for many people. 12.1.2 Energy conservation. Energy production is another significant source of pollution, particularly through the burning of fossil fuels. By conserving energy and adopting cleaner alternatives, individuals can contribute to reducing pollution. Here are some ways to conserve energy. Energy-efficient appliances. Choose energy-efficient appliances for your home, such as refrigerators, air conditioners, and light bulbs. These appliances consume less energy and help reduce pollution from power plants. Unplug and switch off. When not in use, unplug electronic devices and switch off lights. Standby mode still consumes energy, so it's important to completely power off devices to conserve energy. Insulation and weatherization. Properly insulating your home and weatherizing it can reduce the need for heating and cooling, thereby conserving energy. Insulation helps maintain a comfortable temperature inside the house, reducing the reliance on heating and cooling systems. Renewable energy sources. Consider installing solar panels or wind turbines to generate clean and renewable energy for your home. While the initial investment may be higher, it can significantly reduce your reliance on fossil fuel-based electricity. 12.1.3 Waste reduction and recycling. Improper waste management leads to pollution of land, water, and air. By reducing waste and adopting recycling practices, individuals can minimize pollution and promote a circular economy. Here are some ways to reduce waste. Reduce, reuse, and recycle. Follow the 3 R's of waste management. Reduce the amount of waste generated by opting for products with minimal packaging and avoiding single-use items. Reuse items whenever possible, and recycle materials such as paper, plastic, glass, and metal. Composting. Composting organic waste, such as food scraps and yard trimmings, reduces the amount of waste sent to landfills. Composting not only reduces pollution but also produces nutrient-rich soil for gardening. Proper disposal of hazardous waste. Dispose of hazardous waste, such as batteries, electronics, and chemicals, at designated collection centers. Improper disposal of hazardous waste can contaminate soil and water sources, leading to pollution. Support recycling initiatives. Participate in local recycling programs and support businesses that prioritize recycling and use recycled materials in their products. By creating demand for recycled products, individuals can contribute to reducing pollution caused by the extraction and production of raw materials. 12.1.4 Sustainable consumption. The choices we make as consumers have a significant impact on pollution. By adopting sustainable consumption practices, individuals can reduce pollution and promote a more environmentally friendly economy. Here are some ways to practice sustainable consumption. Buy local and seasonal. Support local farmers and businesses by purchasing locally produced goods. Buying seasonal produce reduces the energy required for transportation and storage. Choose sustainable products. Look for eco-friendly and sustainable products that have minimal environmental impact. Consider factors such as packaging, materials used, and the company's commitment to sustainability. Reduce water consumption. Conserve water by fixing leaks, using water-efficient appliances, and practicing mindful water usage. Water treatment and distribution require energy, so reducing water consumption indirectly reduces pollution. Avoid single-use plastics. Single-use plastics, such as plastic bags and disposable cutlery, contribute to plastic pollution. Opt for reusable alternatives like cloth bags, stainless steel straws, and glass containers. By making these personal choices to reduce pollution, individuals can play an active role in creating a cleaner and healthier environment. While individual actions may seem small in the grand scheme of things, collective efforts can lead to significant positive change. It is essential for individuals to inspire and encourage others to adopt sustainable practices, creating a ripple effect that can help combat pollution on a larger scale. 12.2 Community initiatives. While individual actions play a crucial role in reducing pollution, community initiatives are equally important in addressing the issue of pollution. Communities have the power to come together, raise awareness, and implement sustainable practices that can have a significant impact on reducing pollution levels. In this section, we will explore some of the community initiatives that have been successful in combating pollution. 12.2.1 Community cleanup drives. One of the most common and effective community initiatives to tackle pollution is organizing cleanup drives. These events bring together community members, volunteers, and local organizations to clean up polluted areas such as beaches, parks, rivers, and streets. By removing litter and waste from these areas, community cleanup drives not only improve the aesthetics of the environment but also prevent the pollution from spreading further. These initiatives also serve as a way to educate the community about the importance of proper waste disposal and the impact of pollution on the ecosystem. 12.2.2 Recycling programs. Communities can establish recycling programs to encourage residents to recycle their waste instead of sending it to landfills. These programs can include the installation of recycling bins in public spaces, educational campaigns to raise awareness about the benefits of recycling, and partnerships with local recycling facilities. By promoting recycling, communities can reduce the amount of waste that ends up in landfills, conserve natural resources, and decrease pollution caused by the production of new materials. 12.2.3 Community Gardens. Community gardens are not only a great way to promote sustainable food production but also contribute to reducing pollution. By growing their own fruits and vegetables, community members can reduce their reliance on commercially produced food, which often involves the use of pesticides and contributes to pollution. Additionally, community gardens can help improve air quality by absorbing carbon dioxide and releasing oxygen. These initiatives also foster a sense of community and provide educational opportunities for residents to learn about sustainable gardening practices. 12.2.4 Public Transportation Initiatives. Encouraging the use of public transportation is another effective community initiative to combat pollution, particularly in urban areas. Communities can work with local governments and transportation authorities to improve public transportation infrastructure, increase the frequency of buses and trains, and promote the use of bicycles and walking as alternative modes of transportation. By reducing the number of private vehicles on the road, communities can significantly decrease air pollution and alleviate traffic congestion. 12.2.5 Environmental Education Programs. Educating the community, especially children and young adults, about the importance of environmental conservation and pollution prevention is crucial for long-term change. Community initiatives can include environmental education programs in schools, workshops, and awareness campaigns. By providing knowledge and raising awareness about the impact of pollution, these programs empower individuals to make informed choices and take action to reduce pollution in their daily lives. 12.2.6 Green Energy Initiatives. Transitioning to renewable energy sources is a significant step towards reducing pollution and mitigating climate change. Community initiatives can focus on promoting the use of solar panels, wind turbines, and other forms of clean energy. Communities can establish partnerships with renewable energy companies, provide incentives for residents to install renewable energy systems, and advocate for policies that support the transition to green energy. By embracing renewable energy, communities can reduce their reliance on fossil fuels and decrease air and water pollution caused by traditional energy sources. 12.2.7 Advocacy and Collaboration. Community initiatives can also involve advocacy and collaboration with local governments, businesses, and other organizations. By voicing concerns and advocating for stricter pollution regulations, communities can influence policy decisions and promote sustainable practices. Collaboration with businesses can lead to the implementation of eco-friendly policies and practices, such as reducing waste and implementing energy-efficient measures. By working together, communities can create a collective impact and drive positive change in pollution reduction efforts. In conclusion, community initiatives are essential in the fight against pollution. By organizing cleanup drives, promoting recycling, establishing community gardens, encouraging the use of public transportation, providing environmental education, supporting green energy initiatives, and advocating for change, communities can make a significant difference in reducing pollution levels. These initiatives not only improve the local environment but also inspire and empower individuals to take action and create a sustainable future for generations to come. 12.3 Government Policies and Regulations. Government policies and regulations play a crucial role in addressing pollution issues and ensuring a cleaner and healthier environment for all. These policies aim to regulate and control the activities of individuals, industries, and other entities that contribute to pollution. By implementing effective policies and regulations, governments can mitigate the harmful effects of pollution and promote sustainable practices. In this section, we will explore some of the key government policies and regulations that have been implemented to combat pollution. 12.3.1 Environmental Protection Agencies. One of the primary ways governments address pollution is by establishing environmental protection agencies. These agencies are responsible for developing and enforcing regulations to protect the environment and public health. They conduct research, monitor pollution levels, and work closely with industries and communities to ensure compliance with environmental standards. Environmental protection agencies also play a vital role in educating the public about pollution and promoting sustainable practices. 12.3.2 Air Quality Standards. To tackle air pollution, governments set air quality standards that define the acceptable levels of pollutants in the atmosphere. These standards vary from country to country but generally include limits on pollutants such as carbon monoxide, sulfur dioxide, nitrogen oxides, and particulate matter. Governments monitor air quality regularly and take necessary actions to reduce pollution levels when they exceed the established standards. This may involve implementing stricter emission controls, promoting cleaner technologies, and encouraging the use of renewable energy sources. 12.3.3 Water Quality Regulations. Water pollution is a significant concern worldwide, and governments have implemented various regulations to protect water bodies. These regulations focus on preventing the discharge of harmful substances into rivers, lakes, and oceans. Governments set limits on pollutants such as heavy metals, pesticides, and organic compounds in wastewater and industrial effluents. They also enforce regulations to ensure proper waste management practices and promote the use of advanced treatment technologies to purify contaminated water. 12.3.4 Waste Management Policies. Effective waste management is essential to prevent pollution and protect the environment. Governments have implemented waste management policies that aim to reduce the generation of waste, promote recycling and reuse, and ensure proper disposal of hazardous materials. These policies include regulations on waste segregation, collection, and treatment. Governments also encourage the adoption of circular economy principles, where waste is seen as a resource and is recycled or repurposed instead of being discarded. 12.3.5 Renewable Energy Incentives. To combat pollution from fossil fuel-based energy sources, governments have introduced incentives to promote the use of renewable energy. These incentives include tax credits, grants, and subsidies for individuals and businesses that invest in renewable energy technologies such as solar, wind, and hydroelectric power. By encouraging the transition to clean energy sources, governments aim to reduce greenhouse gas emissions and mitigate the impacts of climate change. 12.3.6 Emission Standards for Vehicles. Transportation is a significant contributor to air pollution, particularly through vehicle emissions. Governments have implemented strict emission standards for vehicles to reduce pollution from the transportation sector. These standards specify the maximum allowable levels of pollutants emitted by vehicles, such as carbon monoxide, nitrogen oxides, and particulate matter. Governments also promote the use of electric vehicles and provide incentives for their adoption to further reduce emissions. 12.3.7 Environmental Impact Assessments. Before undertaking major development projects, governments often require environmental impact assessments, EIAs, to evaluate the potential environmental consequences. EIAs assess the project's impact on air, water, soil, biodiversity, and human health. Governments use the findings of these assessments to make informed decisions and impose necessary regulations to minimize adverse environmental impacts. EIAs help ensure that development projects are carried out in an environmentally responsible manner. 12.3.8 International Agreements and Cooperation. Pollution is a global issue that requires international cooperation to address effectively. Governments participate in international agreements and conventions to collaborate on pollution control efforts. Examples include the Paris Agreement on Climate Change and the Basel Convention on the Control of Transboundary Movements of Hazardous Wastes. Through these agreements, governments commit to reducing pollution, sharing best practices, and providing financial and technical assistance to developing countries. 12.3.9 Enforcement and Penalties. To ensure compliance with environmental regulations, governments enforce strict penalties for violations. These penalties may include fines, imprisonment, or revocation of licenses or permits. By imposing penalties, governments create a deterrent effect and encourage individuals and industries to adopt cleaner practices. Regular inspections and monitoring help identify non-compliance, and enforcement agencies take appropriate actions to hold polluters accountable. 12.3.10 Public Awareness and Education. Governments recognize the importance of public awareness and education in pollution control. They invest in campaigns and educational programs to raise awareness about the impacts of pollution and promote sustainable practices. Governments work with schools, communities, and non-governmental organizations to educate the public about pollution prevention, waste management, and the importance of preserving the environment for future generations. Government policies and regulations are essential tools in the fight against pollution. By implementing and enforcing these measures, governments can create a framework for sustainable development and ensure a cleaner and healthier environment for present and future generations. However, it is crucial for governments to regularly review and update these policies to address emerging pollution challenges and incorporate new scientific knowledge and technological advancements. 12.4 International Cooperation for Pollution Control. International cooperation is crucial in addressing the issue of pollution on a global scale. Pollution knows no boundaries and its impacts can be felt far beyond the borders of individual countries. To effectively combat pollution, it is essential for nations to come together and work collaboratively towards finding solutions. This chapter explores the importance of international cooperation in pollution control and highlights some of the key initiatives and organizations that are working towards this goal. 12.4.1 The global nature of pollution. Pollution is a global problem that requires a global response. The emissions from one country can travel across borders and affect the air, water, and soil of neighboring nations. For example, air pollution from industrial activities in one country can contribute to smog and respiratory problems in another. Similarly, water pollution from agricultural runoff can contaminate rivers and lakes that flow into multiple countries. The interconnectedness of pollution means that no single country can tackle the issue alone. International cooperation is necessary to share knowledge, resources, and best practices in order to develop effective strategies for pollution control. 12.4.2 International Agreements and Treaties. Over the years, several international agreements and treaties have been established to address pollution and promote environmental sustainability. These agreements provide a framework for cooperation among nations and set targets for reducing pollution levels. One notable example is the Paris Agreement, which was adopted in 2015 by nearly every country in the world. The agreement aims to limit global warming to well below 2 degrees Celsius above pre-industrial levels and to pursue efforts to limit the temperature increase to 1.5 degrees Celsius. By committing to reduce greenhouse gas emissions, countries are taking a significant step towards mitigating the impacts of climate change and reducing air pollution. Another important agreement is the Basel Convention on the Control of Transboundary Movements of Hazardous Wastes and Their Disposal. This treaty aims to minimize the generation of hazardous waste and ensure its environmentally sound management. It promotes the reduction, recycling, and proper disposal of hazardous waste, and encourages countries to cooperate in the safe handling and disposal of such waste. 12.4.3 International Organizations and Initiatives. Numerous international organizations and initiatives are dedicated to promoting pollution control and environmental sustainability. These organizations play a crucial role in facilitating cooperation among nations and providing technical expertise and support. The United Nations Environment Programme (UNEP) is one such organization that works towards addressing global environmental challenges, including pollution. UNEP provides a platform for countries to collaborate on environmental issues, facilitates the exchange of knowledge and best practices, and supports the implementation of international agreements and treaties. The World Health Organization (WHO) also plays a significant role in international efforts to control pollution. WHO provides guidance and technical support to countries in assessing and managing the health risks associated with pollution. It conducts research, develops guidelines, and promotes awareness to protect public health from the adverse effects of pollution. Additionally, initiatives like the Global Environment Facility (GEF) provide financial support to developing countries for projects that promote sustainable development and address environmental issues, including pollution. The GEF funds projects related to pollution control, waste management, and the conservation of natural resources, helping countries implement sustainable practices and technologies. 12.4.4 Sharing knowledge and best practices. International cooperation in pollution control involves the sharing of knowledge, experiences, and best practices among countries. By learning from each other's successes and failures, nations can develop more effective strategies for pollution prevention and mitigation. Platforms such as international conferences, workshops, and scientific collaborations provide opportunities for experts and policymakers to exchange ideas and share research findings. These interactions foster innovation and enable the development of new technologies and approaches to pollution control. Furthermore, international cooperation allows countries to learn from different regulatory frameworks and policy approaches. By studying successful pollution control measures implemented in other countries, nations can adapt and implement similar strategies that are suitable for their own contexts. 12.4.5 Funding and technical assistance. International cooperation also plays a crucial role in providing funding and technical assistance to countries that lack the resources and expertise to address pollution effectively. Developed countries often provide financial support and technical assistance to developing nations to help them implement pollution control measures and adopt sustainable practices. Through international partnerships and collaborations, countries can access funding for pollution control projects, capacity building programs, and the development of sustainable infrastructure. This support enables countries to invest in cleaner technologies, improve waste management systems, and implement pollution prevention measures. 12.4.6 Challenges and future outlook. While international cooperation is essential for pollution control, there are challenges that need to be addressed. One of the main challenges is ensuring the active participation and commitment of all countries. Cooperation requires collective action and a shared responsibility to protect the environment and public health. Additionally, disparities in resources and capabilities among countries can hinder effective cooperation. Developing nations often face financial constraints and lack the technical expertise to implement pollution control measures. Bridging these gaps and promoting inclusivity in international cooperation is crucial for achieving meaningful progress in pollution control. Looking ahead, it is imperative to strengthen international cooperation and collaboration in pollution control. This includes enhancing the exchange of knowledge and best practices, providing financial and technical support to developing nations, and fostering partnerships among governments, organizations, and communities. By working together, nations can overcome the challenges posed by pollution and create a cleaner and healthier environment for present and future generations. International cooperation is not only a necessity but also an opportunity to build a sustainable future for our planet.